Discovery, go at throttle up. Discovery, go at throttle up. Discovery, go at throttle up.
Wait, what, Elforce? NSF is looking for someone who can model upcoming launches in KSP? Huh. I've been known to do that from time to time. Yeah, I don't think I can. I can't sing and play. I should have quit you long time ago. Every time I go with a baby darling, shiver the blows all down my spine. Dude, I can't sing and play that. Forget how to play. I can't remember the rest of that song. I can never get it right. Yeah. Squeeze my baby. You ain't nothing but a 2-bit. Here, one more, and then we start. Okay? What should we play? Actually, you know what? I wonder if I remember how to play this song. Forget how to play the rest of the song. No offense, but your guitar is a bit out of tune. Rem, I take super offense to that. I'm offended. How dare you? How dare you? How dare you take advantage of my playing? You are not allowed to criticize. I don't care, dude. It's fine. I really don't care. It is out of tune just a little bit, but it's alright. It'll work. It's mostly my bad playing, dude. Yeah, no, that's true. You can't DMCA me if my guitar is out of tune, right? Yeah, you can tell right there. Guitar Karen, how dare you not appreciate my bad playing? Can you imagine if people are actually like that, man? Holy crap. Nobody loves you like the way I do. There's a part where he just plays strings here and it goes. Nope. I can't play, dude. Sounds like you're running the headphone jack into the PC. Sounds? What are you talking about? Sounds? How do you... No, it's a Behringer X1204. It's just a little bit out, Rem. Just a little bit, but it's fine. Whatever. We can make do with it. It's alright. Oh, the lower strings, yeah.
Discovery, go at drop up.
Alright. That's enough. That's enough. And Rem, I take super offense to it. Can you tell by how upset I am? Look at how upset I am, man. Ugh. You can just feel the seethe. You can feel the seethe through the screen. Look at how upset I am. Look at, I'm so pissed. Oh, Reginald. I disagree. Alright. So how's the new KSP update? Fun? I convinced Scott, so Scott was playing KSP last night late on his stream, and I convinced him to make a trebuchet with ground anchors. And we launched a probe into orbit around Eve from Gilly with a trebuchet. Yeah, it was pretty fun, actually. Any word on a new launch date on the Starliner? Audrey, something happened. It's hardware related, so call sign Seether. I love it. Yeah, it was pretty fun. Pretty funny. Let's see, what else do we got? Yeah, they got a sticky valve, dude. They got a sticky valve. Alright, so, where did we last leave off with our Starship modeling project? Dude, seeing all these Starship pictures, man, oh, dude, I just... Look at this. Look at this. Look at this. They mated Starship last night. Last night, dudes. Last night. Bro. Hardware related again. What do you mean again, Hibbit? Taradra, how you doing, buddy? You feeling better? The headaches, dude. Like, Taradra, I don't know what's going on with you, but I know I got nasty headaches from not sleeping. If I don't sleep, if I don't get more than 6, my head starts to pound badly. Buzz. Feeling better? Yeah. Like, yeah, it gets pretty bad, dude. You left off with the stringers. Yeah, that's right. I kind of want to model the Raptor engine today. I meant it was a Boeing issue again. Yeah, I know OFT wasn't hardware. All right. No, it's all good, man. It's all good. I never get more than 6. I don't know. It might be what I'm eating. What do you eat? I'm gonna load up Maya while we're doing this. Like, what's your diet, dude? I'm careful with that, man. I don't... Very careful. Last. Okay. DM'd you an update on my starship. I think you'll like the nose layout. Is that 3D, Thomas, or... I'm waving to you. I waved to you with whatever that is. Okay. Crap. Okay. It's 2D? Oh. Well, that's a shame. Well, that's just a crying shame then, mate. Isn't it? Alright. No, wait. Not isn't it. In it. It's just a crying shame then, mate. Isn't in it. In it. Can't do 3D? You tried? Nah. I mean, Taraja, you gotta... Like, dude, I don't even... I'll be honest with you. I don't even eat that healthy, to be real. I just don't... I just do intermittent fasting. That's what I do. It's hard to do, but I basically just jump right into work with a cup of coffee. That's about it. And, yeah, I just keep drinking coffee until the end of the night. Till the end of the night. And then I make myself a big meal before I go to sleep. I mean, I'll be honest. I don't really drink soda that much. A couple beers here and there, but it's mostly coffee and water. Just drink a lot of water, dude. That'll help. It's hydration half the time. Do that, you eat once per day. I mean, like, I made myself stir fry the other day. Made stir fry for Brimo and I. Took like... So, I took like green beans, broccoli, carrots, flank steak, and some rice, and just mixed it all together. Yeah, Cryptech, the lack of physical activity with intermittent fasting, I don't gain any weight. I don't gain weight. That's why I'm not like 300 pounds over here. I've just stayed at 250 for like the last 5 years. Yeah, Jack does that. 7 meals a week. Which playlist do you use for your music? It's Robert Parker. He's a Swedish synthwave musician, space button. Here, I can link you. I'll link you End of the Night. That's one of my favorite albums from him. That's the one I listen to the most here. He's whitelisted all of his music for Twitch. That's why I listen to it so much. Because I know for a fact that you don't have to worry about DMCA or anything. Yeah, fellas, like... I don't mean to sound like anybody else, and you know, your body, your choice. I totally get that. I totally agree with that. You do whatever you want, you know. But like, if you want to lose weight, like, first of all, you gotta want to. And like, second, like, yeah, it takes a lot of mental discipline to do intermittent fasting, because I'm always hungry, always. I grew up playing a lot of sports. Like, and I'm not trying to say like, oh, Chad, EJJ, Thunder Chad. No. When you play a lot of sports and do a lot of physical activity, you're always hungry. Always. I'm always hungry. I could devour like an entire pizza right now. No problem. Yeah, dude, easily. So I gotta be careful. Is this a Raptor schematic? Oh. Nice. I don't think it's a schematic. I think it's just some art. First question, Elon mentioned that the Raptor is a 3-to-1 oxygen rich. I didn't understand that. Correct second question, he said the grid fin is electric, not hydraulically controlled, and that it has a gear system What would that gear be for? It's a reduction gear. The motor spins at high RPM, but you don't need it to spin at high RPM. You need torque. I mean, the electric motors make torque, but it's not going to be enough torque to move that grid fin. It's through a gearbox. They got the motor going into a reduction gear, like a windshield wiper motor. Same thing. Literally the same thing. It's just a big windshield wiper motor, but with a Tesla Model 3 motor. So like, yeah, it's around, I don't know, man. I try to eat as best as I can, dude. Like, so stir fry is kind of like my new hotness right now. I used to just eat mac and cheese with like hot dogs and hamburgers in it. It's good enough. It's not the best. Not the best thing for you. That and ramen, and then I cook with Brimo sometimes, you know. But I made stir fry the other day, and dude, see, I like that because stir fry fills you up. It's all vegetables with a little bit of meat in there, and it'll fill you up. If you have like beef stir fry, tasty. What the hell would the reduction be in that? Probably 9-to-1 with a lever arm, goalie, if I had to guess. Yeah, stir fry is amazing. I use soy sauce for the stir fry. I know it's a lot of salt, I get it, but it's fine. It's really not an issue. Anyway, let's get to this. So let's go in here, plus in layer. This is old parts. Let's go. And let's add that there. Visualize that. I started making the stringer, and yeah, I wasn't too happy with that. So I'm going to also add that to old parts and just leave it. So we have our ring, right? We're going to need, I don't know, should we work on the ring? What should we work on? Did we ever fix the Z fighting? Yeah, no, it's fixed. The far clip plane, we've fixed that. Yeah, it's all set. We do have a two-sided face, and it is 3 mil. Or, well, it's a little bit more than 3 mil, but that's okay. All right, let me switch my prefs and make sure that yeah, we can use feet for now. That's okay. All right, so we have the ring, right? And let's just name this to SS Ring 1. All right, so what should we work on? Let's do the bulkheads, I think. Let's get some chill music up and go from there. Nah, here we go. Alright, so let me just make sure that this works how I think it's going to work. So Starship is 20 rings tall, pretty sure. So yep, alright, so move that 6 up on the grid. There we go. We got a couple of rings there. I'm sorry, I couldn't help it. Ah! Let's go. Alright. Actually, you know what? We've listened to that before. Here, how about this one? There we go. We haven't listened to this in a while. Alright, so Starship is 20 rings. So let's see if this works how I want to. I still have my grid set to feet because the rings are 6 feet. So if we did this correctly, right? That means I should just be able to duplicate this, right? And then, so that's 3. And then we can do duplicate special. Ready? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Boom. There's your starship. We have made a grain silo. Alright, so that does duplicate how I want. Good. So it should be really, 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 really simple to get the bulkheads and everything else made. That should be really, really not difficult. So what I'm gonna do, we'll work on the bulkheads. So it seems like all the bulkheads are more or less the same shape. It's just the cap. The cap is different. So let's put this on a non-selectable layer. Non-reversible tremmy pipe to the differential girdle spring on the up end of the Grammys. The turbo encabulator has now reached a high level of development and is successfully being used in the operation of No for Trunnions. Alright, so there's my ring right there. Alright, so, Thomas. I need reference. Thomas! Tomas! Necesito reference. A. Reference of what? Tomas. We need the bulkheads. Give me the bulkheads and put the Vigo in the art room. In the art room. Chat, you. Everything you're doing is bad. I want you to know this. I want you to know this. Put the Vigo. Put the Wario in the art room. In the art room. Gary, everything you're doing is bad. I want you to know this. Okay. Watching your stream is bad? Probably. Warning. Stream can cause extreme nerddom. Yeah. Warning. The following stream can cause extreme nerddom. The following stream can cause extreme nerddom. The stunts performed by Jeb and company in these in the following stream could result in death and destruction. Blueprint? Ah, yeah, that's right. Raph's blueprints. This will be good. Anyway, I'm just kidding, guys. You don't need to go find the blueprints. I was just gonna look for reference. Thomas, I need the production thread, dude, and I always can't find it because I'm inept. Okay. See? Okay. Alright. You got 2 shooters, here and here. Right? When the ambush comes to shoot, we got 2 shooters. 2 shooters across from each other. Shoot each other dead. Talk about an ambush? I just ambushed you with a cup of coffee. Alright, let's see what else we got. So it seems like these bulkheads, for the most part, are just... They're all more or less the same. It's just the cap. The cap changes. So see this cap piece right here? And that, once again, that's Elon to a T. Yeah, pretty much, Admana. Do you have Raptor models? No, but I can make them. I can make those. Yeah, Admana, I don't know what's going on with that. I haven't talked to them regarding that in a very long time. It's in the other room, drummer. I knocked it over and I had to fix it. But even then, a 3D model is not going to help me too much because that model is the old Raptor. The Raptor design has changed, so let's just go with bulkheads for now. So this is coming from Raphael Adami here. Let's see what we got. Making this for a 3D printed model or for KSP? No, I'm making it because I want to model it, dude. Nothing more. Not getting roped in again. Last time I did this, I was like, hey, you know, we should, you know, I just wanted to model it, right? And then chat's like, oh no, you should make it into a parts pack for KSP, and it ended up never getting done. So I'm not gonna promise myself anything. I'm just gonna model something and go from there. Interesting, Forge. Alright, so this should be pretty straightforward stuff here. I'm just trying to... Okay. Pretty much, Lulz, yeah. I was thinking I would really like to just make this as a model so I can show people what the heck I'm talking about when I'm sitting here pointing at NASA spaceflight footage. In your opinion, model the top dome and do what SpaceX does? Sad to see Boeing have so many issues with Starliner. Guys, it's a test flight. Look. Look. I'm going to say I'm only going to say this once, but we all know that that's not true. So here's what I'm going to say. It's a test flight, guys. They're going to have problems, okay? It's a test flight. Stuff's going to go wrong, but it's important to be careful. It's very important to be careful, okay? You know, this contempt bull crap, dude, it really pisses me off. Like, that, not pisses me off, that's not really the right way to say it. It's just annoying. Like, oh my god, I feel so bad for Boeing. Like, this is some pity freaking contest, dude? Bull crap. That's, don't listen to people that talk like that. They'll get it done. They'll get it done, and they'll get the valve right. They just gotta fix it. It's no problem. It's a test flight. Stuff like this is gonna happen. This is what happens when you do waterfall testing. It's just, that's just how that works. Look, it's not SpaceX, alright? You know, SpaceX threw SN11 on the pad and it blew up. It hard started the engine and exploded when it was trying to land. I mean, it's not like that. It's not a just send it type of testing. It's a different type of testing, and this like contempt that people have, contempt, excuse me, that people have for Boeing because they're not testing like SpaceX is very, very annoying. Oh, I feel so bad. No, don't feel bad for them. Cheer them on. It's pretty simple stuff. You don't need a freaking aerospace engineering degree to understand that they're not engineering the same way that anybody else does. They're not engineering the same way that SpaceX does. Let me put it to you like that. Give them some time. They'll be fine. It'll go. Trust me. It will. Like, Ark, I feel you. It's annoying, but cheer them on, dude. Don't have contempt for them. They'll get it. I want 2 spacecraft flying. I want 8 spacecraft flying. I don't want 1 spacecraft. I want all the spacecraft. I'll cheer on anybody that throws their hat into the ring, dude. That's very important to understand, dude. What's that, Thomas? Mystery and Mischief have moved on. Hey, it went back to being named Mr. Steven. You even cheer on Arca? Yeah. I didn't mean any contempt. I know you didn't, Arksign. I know you didn't, dude, but I see it on Twitter all the time. And I see it I see it in chat. It's not not like that. I know what you're trying to say. You want Bowen to do. You want them to do good. Me too, man. I'm with you. With you on that one. All right. Let's model a bulkhead out here. I'm wondering if I should start with the ring. You have the ring. And I see your bulkhead is as big as mine. Let's see how well you handle it. Yeah, Jake, once again, folks don't understand, dude. They don't get it. They don't get it, man. They just don't get it. It's short memories, man. You know? So, like, Ark, here's what I'm telling you. Just cheer them on, dude. Cheer them on like you would SpaceX. Like, be like Tory Bruno. Tory Bruno congratulates SpaceX on their milestones all the time. He congratulated them when Starship landed. Be like Tory Bruno. We need more people like Tory Bruno. Oh, that just reminded me. Blue Origin released that today. Speaking of... Oh my god. Yeah, exactly, Forge. I know. Guys, stop this. Stop this nonsense. Stop it. Stop doing that. Stop it. No, you stop this. How am I supposed to fight against this? Like, what am I supposed to do with this? I don't know. I just want to make a bulkhead. Let's go. They put out 3 PDFs about it as well. Gary, why? All right, so duplicate this. Thomas, how tall is one of the bulkheads? How tall are we talking here? I can use the ring to make one. So remove that object from the ring layer. Sure, blame the Mr. Gary. Here, let me pull up Raph's blueprint. Okay, so it looks like the bulkhead is about 2 rings tall, give or take. Does Raph have a measurement on one of the bulkheads here? 3.61 meters. Okay. I don't want to look at them. Oh dear. Oh dear. Forge, we'll talk about that during Space News. It looks like we got 3.61 meters on the bulkhead, right? So I'll switch my measuring system away from feet for a second, and we'll go back to metros. 61 metros. How do the leadership look at this and think it's a good idea to put it out? I don't know, man. I don't know. I love how NASA, the GAO released a protest, and Blue Origin's like, no, we need 2 landers. We need 2 landers. And Dynetics is like, understandable. Have a nice day. Somebody make that meme. Somebody make that. Blue Origin with the sieve And Dynetics, understandable. Have a nice day. Yeah, it made me respect them pretty hard. But no, I still like what Blue does. Dude, just focus on yourself, man. You have all this cool stuff. You always talk about these flight-proven technologies. Show people the stuff. Show people the goods. Trust me, they'll go for it. Look, if Tori Bruno can turn around freaking ULA, because ULA used to get dumped on all the time. If you can turn them around, dude, you guys can do it too. How do I... I need, create. I forgot how to do it. Measure tools. Distance tool. Oh, yes. Yes. 3.61. Oh, baby. Yes, I remember now. You can make rulers in Maya. Oh! Score! And now I should be able to vertex snap. Oh, baby. There we go. 3.61. Bingo. Now I don't have to keep switching the grid units around. Well, actually I should, but it's okay. Bulkhead distance. Okay. What do you think of my starship? Your starship's amazing. Give it a lick. Tastes just like raisins. Why not just import the reference photo? Nah, I don't need to do it. Lemprod, we could do it this way. Hey. Hey. Hey, 95. This is... Wait, why do you have RCS out on the wings? Is that something I missed? Oh, dude, we could have made that. And I know how Starship re-enters now from the Venture Star program. That's freaking cool, dude. Really cool. Haven't made a KSP Super Heavy yet. Neptune was Super Heavy, Jeff, back in the day. Besides Neptune? No. These blueprints from Raphael are fantastic. They're super freaking useful. Alright. What's the diameter on the header tank, dude? Do we know header tank diameter, Thomas? Because if I can get header tank diameter, then I can make every single bulkhead. Because that cap right there on a common this is a forward bulkhead. I think this is a methane forward bulkhead from this reference picture. That's the one with just the cap on it. The methane aft bulkhead would be this upside down with the header tank inside of it. And then the bottom bulkhead for Starship is this with the thrust puck on it, right? I had lots of roll issue with the thing, so I added RCS to the wings. The lunar starship needs a lot of refueling just to land on the moon once? Yeah, 3.14 meters, apparently. Right. So we'll just go into our calculator here. 1.57, okay. So if I switch this to minus 1.57 right there, Then go to my other locator point here, set that to 0, and set that to positive 1.57. Boom. There we go. So now I'm going to take these vertices, and then we're going to do a little bit of that. So I'm using scale to scale this stuff inwards. And I know we're making a cone that doesn't look like it. I'm going to basically, so, okay, doing 3D modeling like this, it doesn't matter really if you're using CAD or Maya or whatever. I basically like finding a datum point and working off of that. So that's why this blueprint, Raphael Adami's blueprint right here, is really helpful, because I can get measurements. And if I can get measurements and you get proportions and measurements right, it really doesn't matter if you're making an engineering model or if you're making a game model. The proportions are going to be correct. That's the hard thing to do in 3D modeling, getting your proportions right. It looks okay, Thomas. It doesn't look bad. All right. So I'm finding reference points. I know that this outer bulkhead, the bottom of the bulkhead, is 9 meters wide. And this one is 3 meters wide from what we were saying. I mean, Thomas, that kind of looks right. Here, let's... I mean, I got to get the shape, but... it's getting there. All right, so now let's go in here. Yeah, it looks right. So now we got to get this profile curve here. So what I'm going to do is I'm going to go in here and I'm going to create I'm going to get my curve tool out. We can use a CV curve tool, right? And then we're going to vertex snap that, right? So I'm using V for vertex snap. And what I'm doing is I'm going to use a profile curve here. And that profile curve can be my reference. Instead of sitting here and messing with this all day, I'm just going to make this curve the right angle that we need. And we can do that by adjusting the control vertices. So those two need to be, for the most part. This is just basically a profile line that I'm trying to get, and we're trying to basically match that profile right there. What will this 3D model be used for? For showing people how Starship is made, mostly. Yeah. Alright, that needs to go up there, and then you need to go like here, and then that one needs to go right there. This is the control vertex that we're going to mess around with the most. Can you overlay the picture into Maya? Of course I could. I mean, if you really want to. Here, let me go in here. I already have it. That's right, I already have it. So we can go into image plane, import image. So we're in grain silo source images. Alright, check it out. Okay, so let me set the alpha channel on this. Or not alpha. Yeah, I mean alpha gain should be good. Let me set it to 0.5 because it's kind of hard to look at. There we go. Hey, actually my profile curve was not too incredibly bad. It wasn't the worst. Not bad for doing it by sight, I suppose. I'm wondering what's going on here, though. Here, let me select the image again, and let me make sure that that one is the same. Oh, okay. It looks like the bottom locks bulkhead is just a little bit different. What's your favorite or most used keyboard shortcut for Windows? Control Shift Escape, or just copy and paste, I guess. Turbo. Guys, I do that as a joke. One of these days I'm just gonna remember to do that in real life by complete accident, and it's gonna be a little weird. Okay, so it looks like we do have a little bit of a difference in the bulkheads. The methane bulkheads look to be a little bit different from the LOX bulkhead. This is 3.16 and that one's 3.62. Interesting. I've heard weirder sneezes. Yep. You should 3D print your model when you're done. Nah, I'm just gonna make it. Alright, you know what? I'm gonna start with the bottom one. We'll start with the bottom bulkhead because, well, we're 361, so this one is closer to the bottom one. Alright, let's go in here like this. And if that's the case, so I'm gonna... We're gonna go in like that, right? Because that's the width that we're looking for. And then let me adjust my profile curve. It pays to be like thorough right now. This is the time where it really pays off. You gotta be careful. Make sure you get this right, especially with the profile curve. Now, you could do a couple of different things with this profile curve, which is actually pretty cool. You could revolve it and make the shape that you want, and then convert it to a subdivision or a poly. You could use a revolved surface, and that could do it. Now, if that doesn't make any sense to you, basically, there's a couple of different ways I could make this. Yeah, that's basically it. There's a couple of different ways that I could make this, and that's about it. The way I'm going to do it is use a profile curve. I'm going to use that profile curve, and we're going to make the... we're going to add edge loops in to make that line and go. Can you export it so we can 3D print it? No. I'm 3D modeling it because I want to 3D model it, and that's it. I'm not making a pack for KSP. I'm not making, oh, EJ, let's 3D print it. Nope. I'm just making a Starship model. I don't know what I want to use it for. Well, it's the only reason why I'm like, no. Because the last time I did this with the shuttle pack, I ended up just getting like too deep, too fast. Let's just model. Let's just 3D model and go. No. Like, people keep asking me, like, oh, did you 3D print it? No. 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 Whoosh. No. Yeah, and it never got done. Exactly. Yeah, I know. Thanks, Grayson. There. Alright, let me set the alpha channel here on Raph's picture to 0. Well, it's not alpha channel, it's alpha gain, but that's okay. Okay, split the outer and the inner edges. And then just move them to that profile right there. Right? And then 1 or 2 more pieces of geometry and we should be good. Split that edge. And then go on the inner axis here. Repeat that command. And then right here, like that. Perfect bulkhead. I just had to rub it in, didn't you? Yeah. Okay, cool. Awesome. These are ads that I don't care. What's this ad for? Cool. Remind me to avoid your company at all costs. Thank you. Okay, yeah. Sweet. I will do that at all costs now. That was an Uber advertisement, so good. Now I use Lyft from now on. Excuse me while I delete the Uber app. You think I'm kidding? Done. All right. I got an advertisement for Twitch on YouTube. Oops. Modeling Wednesday. All right, so let me bring the image plane back in. Alpha gain 1. There we go. It's just, yeah, it's tough to see stuff with the dang image because it's black and white. I hate ads with a fiery, burning passion, guys. I can't stand them. Content creator hates ads. You damn right I do. You don't know what's right for my friggin' stream. I do. Stop trying to think that you do. It's friggin' annoying, actually. Oh, great. You have to pay for it, drummer, right? Yeah, no, thank you. I'll just use ad blocker. Thank you very much. Okay. That looks good. Alright, so now we should be able to sleeve this, right? Just like what SpaceX does. This is getting out of hand. What's that, Forge? Making a nice fruit bowl? Yeah, how'd you know? I've been gone for the past week. Now I'm confused. What's the difference between next step Appendix N and Appendix H? I don't know. I'd have to go read. I guess that's the topic for discussion for today for Space News Livid, huh? So this is the Ch4 Aft Bulkhead. Alright, so this piece is ready to go. And what I'm going to do here is delete the history on it. Because that thing is pretty much good to go. It needs to be UV'd if we were going to texture it, but that's no big deal. One of the Raptor engines that's on SN20 is fired on Booster 3. Cool. Ch4 Aft Bulkhead profile. Alright, cool. So we have our aft bulkhead, and now what SpaceX does is they sleeve these things, but we have to put a thrust structure in, I suppose. The 3 Raptor mount structure, I'm not sure how that kind of goes together. So I'll just hold off on that for a moment. Let's go to the next bulkhead. This is the aft, or basically just it's the aft methane tank, but it's the top of the LOX tank too. So this is just, that's called a CBH, or common bulkhead in spaceflight. Or, yeah, basically in rocket science, I suppose. That's the way to say that. Any plans to make it down for the Boca orbital test? I don't know. I don't know, man. Kind of want to watch it here. And we'll send you a copy of that forecast. Back to story. Let me get translate on the Y right here. Okay, so now I'm going to make the aft methane bulkhead. And I'm pretty sure we could just, I'm just going to copy this, right? And then I'm going to set it back to 0, right? Which, okay, 0 is up there. And I'm just going to modify this one a little bit. It should be about the same profile from what I can tell. It's just this is a little bit different. Epic. It is pretty damn cool. I'm going to go ahead and say that that's about the same size. It looks like the one with the methane is 3.14, Thomas. I think that's right. I think the thrust puck was a little bit different. So this is the Ch4 Aft Bulkhead. put that over there. This is not too incredibly difficult making this. And now the top bulkhead shouldn't be too difficult as well. It should just be the same thing. Alright, now give me the methane bulkhead here. I'm going to duplicate it. It looks to be about the same. Yeah, the methane bulkheads are pretty similar. Okay. It looks like the methane forward and aft bulkheads are the same thing. Once again, textbook Elon Musk. Hey, Tech, what's going on? Okay, so let me go over here into the outliner. Just go put that into a rulers group. Ruler. Layer. Save. I'm just organizing everything here. There's Raphael's image right there, and then there's the profile curve. Profile curves. And then we need a group here for old parts. There we go. There. I like your bulkheads. Thank you. Alright, so we have the 3 bulkheads here. So this shouldn't be too difficult to get this completely right here. I mean, these are very primitive shapes. It probably took a while to get these shapes right, though, from what we could tell with Mark 1, Mark 2, and Mark 3, and Mark 4. Remember, they kept blowing up? Can you explain a bit about this project and what your plans are for it? My plans are to model Starship, and that's about it. Yeah, that's about it. No, it's not going into Kerbal. No, I'm not 3D printing it. No, I'm not blah, blah, blah. No, I just want to make a model of Starship because it's a nice thing to have. It's a nice thing to have, S-Master, when I'm explaining stuff to people. So, like, the other day... Here, let me save this. The other day when Zarya was having problems, dude, I decided that I was going to try something a little bit different. And what I tried was going into... I used one of NASA's ripped models from... This one came from Inventor, I think. I used one of NASA's ripped models, and I used it to show where Nauka was going, where it docked to, and what happened with the thrusters. And this model is cherry, dude. It's really, really cool. Like, it has the Canadarm on it and everything. And then Dexter is on the end of the Canadarm. And then it has all the solar panels, and they're fairly high detail too, which is really, really freaking cool, actually. Like, there's the batteries. That's the battery pack right there, see? Portside battery packs. They replaced these. They replaced those with lithium batteries. So I used this to show where Nauka was docking. I took Piers off and deleted it, and then I copied Zarya, and then I made Zarya look like Nauka, because they're both functional cargo blocks. And then I showed where it was docking, and then we used that. This is a NASA rip, yeah. You could tell it was ripped from another program because of all the nasty Z fighting that you're seeing around. And nothing is textured. It did pick up some shader information, which is pretty cool, but... Ah, yes, the Mark I thrust dome. Yeah. So, I mean, guys, like, I could make this. I could model this, no problem. It would just take some time. Like, we could remodel it, and then I could remodel these pieces and put them into KSP. That's something that could be done, but the thing about 3D modeling is that it's tedious. It's tedious and it takes time. But the payout is really, really cool. It's like building a project in KSP. It's like the SSTO. We've been working on the SSTO program about 2 months now. I started it in May 25th. It's, yeah, about 2 months, a little over 2 months, and look at what we've done. It just takes some time, that's all. So I don't know, like, that's you know, kind of where I'm at. I don't know where this project is going to go. I have no idea. Let's just model some bulkheads and we'll see where it takes us. I should probably UV this stuff. Now would be the time to UV it. For texturing if I wanted to. But once again, even using it as an engineering model or just a diagram for what you just saw, it could be useful. The 3D printer works, Hell Hydra. It's just, yeah. I'm not gonna say that Bremo and I are over it. It's just we just don't really have that much to print lately. That's all. I fixed it. I rebuilt the entire thing. Should have probably done that on stream. Anyway, so watch this. So I'm gonna adjust the alpha gain again on this and just kind of make it invisible for a second. Let's bring the ring back in. You have the ring, and I see your bulkheads are as big as mine. Let's see how well you handle it. Alright, so let's bring the image back into the fold. This is, once again, this is Raphael Adami's kind of Starship blueprint picture. Alright, so let me switch my measuring system back into kilofeet. Here. Yeah, I know, everybody. Ah, feet. Ah. So to answer my own question from earlier about the difference between Next Step N and Appendix H is Appendix H is basically the original HLS contract that SpaceX won, and Appendix N is just like the second round to Appendix H. I can see why Blue Origin wants NASA to award the second Appendix H provider, because that's what was NASA's plan. Livid, okay, here's the thing. I agree with them. Straight up. I agree with Blue. NASA should award them a contract. They should have awarded 2, just like they said they would. I agree with them. Not necessarily because I think Starship is better. It's not. Not reverse that. Not necessarily that I think the national team is better. Starship is way more capable of a vehicle, but you pay for that capability. They're right in that regard. But also at the same time, if Elon Musk can yeet 5 Starships up into space in like a week, then it doesn't matter. It really doesn't matter. Lunar Starship can be refueled in a week. And we know that's what he's doing. Personally, if it was really up to me, I want... Your boy's greedy, okay? Your boy is greedy. I want NASA with SLS to have a pathway to the surface of the moon, and I want SpaceX with Starship to have a pathway to the surface of the moon as well. I want people launching on Starship, and I want people launching on SLS. I want national team lander components being launched on SLS Block 1B with Orion, and I want people launching on Starship, and 2 Starships docking in space, transferring cargo and crew to the lunar lander. Starship comes back down, another one comes up, refuels that Starship, rinse and repeat as many times as you need, go to the surface of the moon, come back, transfer back to a regular starship, come back down. I want both of these. Yeah, I want both of these systems. I'm greedy. I really don't think that space is well established enough as an economic. I don't think SpaceX is not SpaceX. I don't think going into space commercially is as economically viable as everybody thinks it is, and the only way to do that is to have more competition. And even if it is a competition between NASA and SpaceX, that's fine. Public and private partnerships are very beneficial, and NASA having its own in-house program on top of those public-private partnerships is the best that we can get. I want the best for NASA. I want the best for NASA, and I want the best for SpaceX, and I want the best for Blue Origin. I'm dead serious about that. I cheer everybody on because I'm greedy and I want more spaceships, not less. It's always that same argument that I go over every damn time, dude. Every frigging time. You know, people are like, oh, well, we should use all Starship, or oh, we should use all SLS. Why? Oh, I'm sorry. I didn't realize you wanted less rockets. Great. We're literally on the verge of being able to have more than one access way to the moon. For the first time, pretty much ever in human history, and everybody, no, we shouldn't. Yeah, sure. Okay. Creeper, what's up, man? Alright, so let's go in here like this, bring the image back in. There we go. And now, give me this aft bulkhead. Let's duplicate one of those. Flip the sucker upside down. Let's bring this bad boy over here. Oh, yeah. Very nice. And yep, there it is. She's sleeved. Okay, so that's 4. Let's duplicate. And then let's bring the image back. Okay, so duplicate again, duplicate again, duplicate again, duplicate again. Now give me one of these. Aft bulkhead, duplicate that. Bring this sucker up over here. Flip that upside down where it needs to be. There we go. Okay. Duplicate it again, duplicate it again, duplicate it again, duplicate it again, duplicate it again. And now give me the forward bulkhead, right? And boom, we have SN5. SN5 with no engines and no parts, but we have the structure for SN5. Booster 2 or nah? I mean, what I'm trying to do here, I'm kind of trying to make a halfway engineering model. Half engineering model and half like just something I can show people. Like that NASA ISS model. What I'm trying to illustrate here is basically how SpaceX makes this stuff. So they basically crank out one ring. There's a tent in Boca Chica that just literally makes these. That's it. There's another tent that makes this and that. That's it. 3 pieces. 1, 2, and 3. This is just a copy. The forward bulkhead is just a copy. The difference between the aft and forward bulkhead is that one has a cap on it and the other one has the header tank, right? That's it. That's the only difference. And then, depending on how these rings get stacked, they'll have internal structure, or they'll have stringers on them, or external structure. And yeah, that's it. I need to go into camera settings. Hang on. Like, I'm trying to just show people... I'm trying to show people just... Oh, Midge, hey, what's up? Yeah, Tessa, exactly. I'm trying to just show people how this stuff goes together and where Elon is at. Did you watch Timmy's interview, dude? Oh my goodness, it's so damn good. So that's what SpaceX is doing. They have 110 is making those and 110 is making these. That's it. And they have a jig. They have a jig that makes the header tank one, and they have a jig that makes the thrust puck one, and that's it. And I'm pretty damn sure that the bulkheads for the booster as well are very similar. If I had to guess, they're probably similar. The booster is probably the same thing. In fact, I could probably make you the booster right now if you wanted to, with this combination of parts. It just seems like the only difference really is the thrust structure for the booster. The thrust structure has a huge plate on it to hold those 9 Raptors, right? So, but I'm going to go ahead and bet you that the booster, the bottom bulkhead is probably a little different because it has the thrust structure, but the mid bulkhead, the CBH, and the top bulkhead are probably exactly the same as Starship. No, knowing Elon, it's probably the same, dude. The minute it dropped, yeah. So, see, there you go. That's what SpaceX does. That's why they crank this stuff out so quickly. And the fact that stainless steel is really easy to use shows that, like, I mean, check this out, dudes. I'll go over here, right? We'll take this. I'll take my original ring, right? And we'll just move it over here. Right? You want to make a super heavy? You want to make super heavy? You want to make another Starship? All right. Let's go SH ring, right? Now watch. How tall is super heavy? Do we know? $70 meters, huh? All right, so Yanity, it's about 70 meters, 36 rings. Thank you, Thomas. So Yanity, what I can do is if I set temporarily, I set us to meters for a moment, right? And if I go into my measure tool, distance, right? We can go X snap to grid. And set that to 70, translate 18. There, that's set to 70 meters right there. And then if I go back and I change my settings again, back to feet. Now, I know people are like, well, EJ, why are you using feet? That's so stupid. The rings are 6 feet, guys. They're 6 feet. And that, because the steel rolls are 6 feet because it's made in the States. Now, don't get me wrong. SpaceX is probably doing the conversion over. But the rings, the rolls that they make this stuff out of is 6 feet. So 33 or 36, Thomas. So that's okay. SH ring. That should be 1. Down here should be 1. That should be 2. That should be 3. Sorry, it doesn't want to. There we go. So 1, 2, and take that, put that as 3. So because the rings are manufactured in 6-foot rolls, it's easy to switch if I switch my units back over to feet, I can just duplicate it and we can snap to grid and get a perfect height. That wouldn't necessarily work with the greeters. Hi, how you doing? Welcome to the stream. With the grid in meters. Greeters. Nice. Alright, so if we duplicate, right? So that's 5, 6, 7. You just keep doing duplicate special. It'll go all the way up to 36 rings. There's super heavy. There you go. Done. And it's funny because it did my conversion over to 229.65. That's how much, if I'm looking at that right, what's 70 times 3.3? I'll bet you. Close enough. What's that, Big Pop Bear? What do you use to 3D model? I'm using Maya. Yes! I convinced Scott, guys, Scott was streaming late on Twitch last night. I convinced him to make a trebuchet and use it to launch something into Eve orbit from Gilly. And it worked. we were launching things into Eve's orbit from the surface of Gilly with a friggin' trebuchet. You guys gotta go watch that VOD. It's so funny. Oh my goodness. Yeah, Scott was messing with ground anchors, and I'm like, dude, use the ground anchors to make a trebuchet. I was doing that. It's a good idea. And Scott's like, no, wait, that's a good idea. I don't think I even need the ground anchors. And he found a way to tension struts to make a damn trebuchet, which was funny as hell. Didn't Elon say that he prefers metrics in his interview? Actually, I'm pretty sure, Kem, that he said that he prefers what works. He prefers the one that's the simplest way to measure. Actually, Kem, I felt pretty damn vindicated, actually. Because I always talk about, dude, I don't give a crap what the measuring system is. Use what makes sense. Use what makes the most sense. It's something that I've talked about for a very long time. And in Timmy's interview, that's basically what Elon said. He said that measuring thrust in kilonewtons is stupid. And measuring tank pressure in pascals is dumb. It's just as dumb as PSI, which made me really happy. They're using bar because one atmosphere is really easy to understand. 14.7 PSI or 101 kilopascals. 1 bar is really simple. So they use bar and then they use tons for thrust, which use what makes the most sense. It has nothing to do with what measuring system is better. Even though, with that being said, I know the metric people are going to see that. I get it. Metric's easier. It's easier to use. I fully concede that. But use what makes the most sense. I love it, dude. I'm all about that life. Use what makes the most sense. Now, as an American, does our system make sense? No. I understand that. I'm not saying that ours is better. Like it's a little bit contrived. It makes no sense. I get it. We stole it from England, all right? But do they know what they're doing? They have no idea what they're doing. We should have thrown it in the harbor. But yeah, I mean, Elon's thing about using what makes the most sense really made me happy, because that's right. That's the right way to look at it. Why would you limit yourself to one way of thinking? Because, dude, nothing in the world is completely square like it is in metric, all right? So like, if you need something that can take a certain type of compressive load, right? Our brains would be like, oh, okay, 10 millimeters should be thick enough. That should be fine. When in reality, if you do some element analysis, it might be like 4.375 millimeters or something, right? It's never gonna be a round number like that. It's never going to. So, I mean, engineering calls for an application of material, right? And how you make that material really depends on what you're doing. And it's never gonna be It's never going to be round numbers. It never is. It's never round numbers. That's not how it works. You know, the base 10 system, just like our system, like Imperial, is just meant to quantify certain things, right? But if you're doing not real engineering, like if you're doing engineering, like, you know, and you're coming up with like compressive load for a certain material, for like if you have a slab of material, like if we're talking structural engineering, the thickness right there is never going to come out to a round number. It never will. We might make it a round number because it's easier, right? But that has nothing to do with it. If you were like wanted to really get this to like a safety factor of 1.5, that might not call for a 10 mil plate of steel. It might call for a 10.57555 repeating, of course, mil plate of steel, right? It use what makes the most sense, and I 100% agree with him on that. That is the smartest thing, one of the smartest things I've ever heard Elon Musk say. Don't limit yourself. You're limiting yourself thinking that way. I totally agree with it. Exactly, Endo. All measurement systems are arbitrary. You use what makes the most sense. I've been saying this for years and people call me crazy. Also, Kilofeed is the best. Yeah. Anyway, so yeah, see? 36 rings. Thomas, where's the bulkhead? What ring is the bulkhead at? Actually, I could probably just go and look. Oof. Yeah, we'll get into that later. You have the ring, and I see your Schwartz is as big as mine. What about kiloyards? Let's see. Meme Lord post anything today? Nope. Sick. Yeah, I agree. I agree, Jim. That's a good idea. Pick by RGB. Excellent. Okay, so there's stringers going between the first and second ring. Where's the bulkhead? Where was the bulkhead sleeved? Is the bulkhead sleeved on the stringers, Thomas? Because the engines are hanging out the bottom, right? Yeah, Biz. Well, bananas is clearly... standard banana measurement is... SBM is clearly the best measuring system. Would a kiloyard be pretty close to a kilometer? Actually, yeah, it would. Alright, so... I don't have a bulkhead here for super heavy because I'm just messing with this right now. So... let me look at that picture again. Okay. It seems like they offset the sleeves, Thomas. So, the sleeves on these rings are never, they're never, like, on the bulkhead seams like that. And yeah, that makes sense to me. It looks like there's something like this. They always offset them by, like 2 or 3 feet in, or about 2/3 of a meter. So, oop, no, that's the main bulkhead. Hang on. I don't want to use that. I want to duplicate it. There we go. There. Alright, now what ring is the... okay, 22. Between 22 and 23, and its sleeve, the sleeve is downward facing. Super Heavy doesn't have a header tank, though, I don't think. But it does have this, an aft bulkhead tank that's probably really similar. 19, where are we at? 22? Okay. And then we need to flip this sucker upside down. That's 21, 22. Yeah, okay, so it's on the 22nd ring. And it's like right... Is it 22 to 23? Yeah, 22 to 23 is where it's at. And the sleeve, the end of the bulkhead probably connects in right here. It's always offset a little bit. So like, once again, they never line up a bulkhead seam with a ring seam like that. See what I'm talking about? And that's probably for pressurization. It's stronger that way. So it seems like it's down there like that. So I'm going to offset 2 feet, right? Just like that. And then give me another one of these bulkheads. That's the forward one. We'll take that. Super Heavy doesn't have a header. Pretty sure it's just a hole in the cap. Got it. And then let's go over here. So the top bulkhead isn't sleeved. So, okay, so 34 has the vent lines. Those are the vents for the methane tank to bring the pressure down on the tank. This is an autogenous pressurization line right there. That's a hot gas thruster. There's the grid fin holes, and that's the hoist mechanism. Elon actually went into detail in Timmy's interview with what all this stuff is and how it works. And honestly, his spiel about autogenous pressurization with the thrusters and simplifying the design, God, that made me so happy. Because, yeah, no, Thomas, I'll be honest, dude. I was really pumped from Tim Dodd, from Everyday's interview with Elon. If you guys haven't seen it, go check it out on his YouTube channel. Hey, Forrest, what's going on? Sorry, I can't see. Yeah, Forrest, 311. Yeah, hey, how you doing? Because a lot of the stuff that Elon was talking about is the stuff I've been saying. You know, if you want Starship... So, SpaceX has been saying a Starship needs to work like an airplane. It needs to work like an airplane. And I'm like, okay, cool. I've been saying for years that if it's going to be like an airplane, you have to simplify the design as much as humanly possible. And he said all that stuff yesterday, and it made, in that interview, it made me feel really good. I'm like, holy crap, okay, cool. Because sometimes, dude, I'm wondering if my finger's on the pulse, so to speak, with this stuff. Because people ask me a lot of questions. So, like, sometimes I'm like, is that right? Am I saying that right? I mean, sometimes I get it wrong, but that's something that I got right. Did I understand Elon's interview incorrectly? Did Elon imply that folding the grid fins on Falcon 9 was unnecessary in hindsight? Draco, they folded the grid fins because Falcon 9 is horizontally integrated. I don't know if he just forgot or something, but yeah, the grid fins fold because it's horizontally integrated. You have to tip Falcon 9 over onto its side to put it on the launcher. So having the grid fins out, I suppose you could. You could just keep them deployed, but that would be a pain in the butt during integration and processing. They fold so they can put the booster on a ring and twist it around and work on the thing. At least I'm pretty sure. This was the CBH for the Booster 3 build. Okay, it's just got a downcomer in it. Got it. Thanks, Thomas. It looks like we're sleeved on the 35th ring. So, actually, right there this is the 35th ring, right? Yep. And there you go. Starship prop tanks, super heavy prop tank. Bingo. This is what I wanted to do with this. Show how easy, it's not easy. Let me put it to you like, let me say it's not easy, but like, this is what SpaceX is trying to do. They're trying to simplify this. And I'm probably going to delete this, to be honest with you, because none of this stuff is UV'd. But, see what I'm talking about? Easy peasy. It's easy-ish. Like, this is very, very simple for rocket production. Like, how Falcon 9 is made, for instance, right? Falcon 9 starts with a bunch of sheets of aluminum lithium, kind of like this, right? And then what they do is they put them through a metal brake and they get them to be concave. And then they make a barrel out of those, right? By friction stir welding them together. So it would be like if you took... it'd be like if you took the ring, right? And then kiss the ring. And then did that. So they basically take a sheet of aluminum, and don't get me wrong, that sheet of aluminum is a lot bigger than just a 6-foot roll like this. It's like that, right? I've seen the barrel jigs for Falcon 9. So they take a sheet of aluminum, right? They drill a bunch of stringers into it, not drill, mill is the right way to say it. They mill a bunch of stringers into what's called an iso grid. An aluminum iso grid is what it's called. Actually, I think SpaceX uses an ortho grid. Hold on. Yeah, there you go. Basically like that. They have a block of aluminum that's pretty thick, like, I don't know, 60 mil thick or like 1.5 inches or something. And they put it onto this big 5-axis mill. I mean, that's Tory Bruno with ULA, and then that carves out this kind of checkerboard onto it, and that's the internal structure. This checkerboard basically is like making the entire outer wall of the fuel tank into a structural. It's like basically an I-beam almost, right? That's actually NASA's external tank, which is made very similar to Falcon 9 and Vulcan for what it's worth. Yeah, they just mill a bunch of stringers into it. Now, SpaceX with Starship, they weld a bunch of stringers to the inside. But they take those milled iso grids, right? Or ortho grids, and then they do this. They put them into a jig. Like that. Right? And then they'd weld them all together. And then they take a bunch of these barrel segments and then like that. And then the bulkheads are actually very similar. The way they make the bulkheads for Falcon 9 is pretty similar to Starship. With the bulkheads, it's just a bunch of panels that they kind of press into a curved shape, and then they pie cut them so they look like a pie slice, and then they put them all together. They literally pie cut them. That's what it's called. If you take a sheet of metal and you pie cut it, actually pie cutting comes from tubing, believe it or not. So how would I pie cut something? We'd have to do... I can just show it like this. They take a sheet like this. Sheet. They take a sheet of steel, or, well, in Falcon 9, or in Falcon 9's case, it's aluminum, right? And they cut it into a piece like that. And then they put it into a big press. And that press basically makes the piece do this. Right? They bend it into... They press it into a piece like that. And then they take a bunch of these things, these pie-cut pieces. And the pie-cut pieces are these. And then they put them on a jig that looks like a Native American teepee. Almost, and then they place the panels on it, and then they weld them all together on a jig. The jigs look, yeah, they look like teepees. Let's see. Michoud has big welding jigs. You'll be able to see them. See? Well, I mean, that's the jig for Orion, but same concept. Hey, Galactic. Привет. Как дела? Oh, there it is. Right there. See? Bingo. Giant teepee. So they mill them and then roll. Exactly. Tweets. They put them through a gigantic metal brake. Dude, this metal brake is like as big as a Mack truck. And then just... and it bends it. Like what an English wheel would do. It's really cool. Like, seeing this stuff come together makes me happy. See, that right there is a jig for a ring for SLS right there. But there's the jig for making bulkheads. They'll take those pie cut plates and they'll set them on this thing. This is just a clamp. The yellow is a clamp. It actually comes back, and they'll set the plate in on these tracks right there. See the metal tracks? Oh, that's so freaking cool. Oh, dude. Yes. See, they set the plate in there, and then they'll make a bunch of those plates, and they'll set them, and then this is a stir welder. It's a 3-axis stir welder, and they'll move this in, and this thing just goes zzz, zzz, rotate it, zzz, rotate it again, zzz. It'll just zip up the pieces until you get one welded piece. That's really, really cool. Oh, this is fantastic engineering. Look at that. See, this is a vertical friction stir welder. Or, well, actually, it's a 3-axis. Meaning 3-axis of movement. I mean, it can pitch, yaw, and roll. And, well, translate up and down. So actually, it's 5-axis. It can go up and down. It can go left and right. It cannot go forward and back. So that's a 5-axis vertical friction stir welder, which is that's really cool stuff, man. Oh, that's so sick. And right now, these machines are probably cranking out more bulkheads for Core Stage 3, if I had to guess. Yeah, see? These things are just clamps. And they put each plate in there, and then this yellow thing kind of clamps it in position.
Discovery, go and throttle.
And then it leaves the seam wide open, and that's where this whole thing is a turntable, and then they'll just zip it up. Zip, zip. Like, zip, yip, yip. Dude, it's so cool. I know guys that work on these things. It's really, really cool. Biff! Super Heavy's looking insane from Elon's Twitter yesterday. I know. Isn't it crazy? Yeah, see? That's the pie cut plate right there. But yeah, check it out, dude. I have we made the rings and the bulkheads, and we have a Super Heavy thing going on over here. Yeah, Galactic, I've seen it. We'll talk about that more during Space News, man. Okay, so we have our bulkhead pieces more or less. I need to tailor each one, right? We got to tailor each one to be a, one that holds the header tank, etc., and one that we got to do the downcomers and stuff, right? And then we have our main ring right there. What else do we need? The nose cone. We got to make the nose cone. So let me bring Raphael's image back in. And we have to make a nose cone piece. So let's bring this down here. Let's group all this into Starship Prototype. And then we'll group Super Heavy, all the Super Heavy stuff in to one thing. This is the outliner over here. The outliner is basically just a list of everything that's in the scene. So I always talk about hierarchies in KSP and why they're so important. So check this out. If you see, I'm making groups. All these groups are the group function right there. See how it's the arrow with see the icon for it? All it is just a 3D transform in space. And everything is parented to that 3D transform. See, I'm controlling the transform right there. I can move it over here like this. It looks like I got a locator in there as well. And see, I moved the locator with it. I don't want that. That's the measuring, that's the ruler. I don't want to bring the ruler in. Now, everything is parented to that, just like in KSP. And you can see the hierarchy right there. So this would be like if I had one root part as my, like to translate it into Kerbal terms, the transform, the group transform, is my root part of this subassembly, right? And every single one of these parts is attached to the root part directly. So this would be like if I didn't stack one on top of the other and made every part attached to the root part and then gizmoed it into position, because that's basically what I did. If I wanted one to move with the other and we wanted to make this more like KSP, this one right here, so where's ring 1? So ring 2 would be parented to ring 1. So that means wherever ring 1 goes, ring 2 will go. See, when I select that, it moves both of them like a subassembly. And then the bulkhead should be under ring 1 as well. Actually, it should be under ring 2. So now wherever ring 2 moves, that moves. This is why I know Kerbal so well, and why I can build in KSP. We could build ridiculous stuff without it getting Kraken struck, because I learned all about hierarchies and how they work in a rigging class at school. I mean, keep in mind, it was a long time ago, but it's rigging. It's basically just rigging. Like, that's how they animate characters in 3D. So now everything went back to being parented to the root transform here, which is prototype. Farm, what's up, dude? See? And now we have our starship and we have our super heavy. But I'm going to move these over here for the time being, and I got to work on a nose cone. So give me one of these rings here. I'm going to duplicate that ring. And what I'm doing right here, guys, is basically I'm getting all the parts that I need to build starships. These are just examples. These are just examples of pieces that I'm working on. And I use them to make like a very, very prototype super heavy and basically SN5 and SN6. And then the cool thing is, if we wanted to make something pretty neat here, check that out. Remember SN 7.2? The prototypes that tested out the bulkheads? All SN 7.1, 7.2 are is this. All they do is test the prototypes like that. That's it. That's all 7.1 and 7.2 are. All they're doing is testing the connection between the bulkheads and the rings on the bottom and on the top. Because they know the rings will be able to hold the pressure here, 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 and here. 7.2 is just that. That's it. 7.1, 7.2, all their prototypes, that's what it is. It's just a sleeved top bulkhead and a sleeved bottom bulkhead. That's all. And now SpaceX knows. Now I know what you're going to say. Well, they just have top and bottom. What about the center bulkhead? What about this piece? Well, if I'm looking at this right, the bottom of the methane tank and the top of the methane tank, the two bulkheads for that, same part. Only need to test it once. Doesn't matter if it's upside down. It doesn't matter if there's a header tank right there either. Or just a cap. You only need to test it once. It's the same part. Havix, what's going on? Pretty neat, huh? And that's SpaceX, dude. That's how they roll. It's very simple stuff. It's not simple, but you get what I'm getting at. It's about as simple as you can rock it. What does the Raptor engine weigh and how much thrust? They're aiming for 230 tons of thrust farm, which is 2,300 kilonewtons, or no, not foot-pounds, kilonewtons to pounds. £500,000 of thrust. That's their aim. It doesn't make that right now. Raptor makes about this right now. It makes about 40,000 pounds of thrust. They're aiming for 500,000 pounds of thrust and change. In terms of weight, we had this conversation the other day, and I said the thing weighed as much as a Mack truck, and that's, I think, where I was getting confused with that. I think I'm incorrect, first of all. The motor doesn't weigh that much. The motor with its mounting, with its transport jig, does weigh that much. So the motor with its stand weighs that much. I think Raptor weighs, I don't know, I think Raptor weighs, what is it, guys? Like 2-3 tons? It's not much. It's very, very small. Compared to Saturn, a single F1 engine, guys, so this is one F1, makes this much thrust. It's 1.5 million per engine. It's by far and away the most powerful single nozzle rocket engine ever devised. An RD-170 Energia's boosters is the highest thrust output liquid fuel engine ever devised. The RD-170 can produce that much. And Farm, no. An F-16 is, F-16s are around there. I don't think F-16s produce 500,000 pounds of thrust, dude. Don't get me wrong. F-16s are powerful. That one engine, whatever it is, I forget the name of it, is a beast of a motor. But it's not producing 500,000 pounds of thrust. Planes do not need that high of a TWR. It's an F-110, 17,000 dry, 29,000 with the burner. Or it uses a Pratt & Whitney F-100, block 52. 17,000, 29,000 dry. That's powerful, but it's not Raptor powerful. Raptor is 500,000. This is 29,000, dude. Raptor engines are insane. They are insane for what they're doing. Considering a Raptor engine could fit on the back of an F-15 or an F-16, it could fit. Oh, it's a drone. It's a drone. Okay. I was gonna say, the stripes, it's a drone, guys. It's yeah. See, it's a QF-16. Q is the Air Force designation for unmanned. So there's QF-4s and QF-16s, and yeah, it's unmanned, which is that's actually pretty cool. F-16s are great aircraft, man. Really, really good. Very, very maneuverable. The thing's like a damn mosquito. Kind of like the plane, too. It's the same idea. It's supposed to go fast. And General Dynamics was one of the first, implemented this plane. It was one of the first planes with what's called a fly-by-wire system, meaning you have a joystick, and that joystick is being interpreted by a computer, and that computer is applying the commands from the joystick into the computer, and the computer controls the control surfaces. Fly-by-wire is what almost every plane uses nowadays, and it was an idea that came from the military. Hey, Evil Rays, thanks for the host, man. Ever since seeing Iron Eagle as a kid, I love the F-16. The F-16 is a good plane, man. It really is. You can do all kinds of stuff to it. Like, we sold it to the Israelis, and they modified it. Dude, it's a really good platform. You can do all kinds of crazy things with it. Like, look at all this stuff that they added to the back. I forget what all that stuff does, but they added all kinds of measuring systems. Like, dude, it's a really good test bed. Even NASA has used F-16s to do stupid things, but see all this extra stuff on the Israeli plane? I forget what they're doing. I forget what they did with it. Why they had this like this, but yeah. It's not a kefir. What the heck is it called? I forget. Fuel cells and fuel tanks? Yeah. Yeah, the Turks use them too. That's a... Yeah, and the F-16 is... You guys saw that, right? It blocked 52. Block 52. We'd be lucky... We're lucky with rocket science to get a Block 3 or a Block 4. Or even a Block 5 with Falcon 9. The F-16 is up to Block 52. That's how much that thing could be upgraded. It's a really cool plane. I mean, it ain't no F-15, but it's still pretty good. Me, personally, more of an F-15 guy if we're going to talk Air Force planes. Sorry, it's just actually, I mean, if we're really going to talk Air Force planes, the F-22 is where it's at. But F-15s are good. I mean, but my favorite is the F-4. F-4 is my favorite because screw you. I can go faster than you. Alright, so let's make our nose cone, shall we? So I'm going to start with a ring. You have the ring. And I see your Schwartz is as big as mine. Let's see how well you handle it. I've made that reference like 6 times today. I'm sorry. Alright, so we're going to go all the way up here like this. And then I'm going to take this and I'm going to scale that inward, and now we just made a nice big cone. YF-23, my dad worked on that program, Andrew.
Discovery, go and throttle up.
My dad worked on the oil pumps, machining them for that program. See, you went through the agent program. I wrote that program. What did you think of her? She doesn't talk much, but if you'd like, I can arrange a much more personal relationship. Alright, so now I inserted an edge ring here. Hey, crossing Marco. 11-month resub. Thanks, man. So I inserted edge loops on the inside and the outside here, and now we're starting to get more nose cone-like. It's not pointy enough, chat. Chat, it's not pointy enough! Alright, so I'm adding in edge loops right where SpaceX puts their bulkheads. When I talk about Russian jets, the MiG-31, I was never a MiG fan, Galactic. Sukhoi. Sukhoi is my favorite when it comes to the Russian stuff. Nothing screws with an Su-35. Nothing. That is one of the best fighter planes ever made. And I'm saying that as an American, you know, and you won't get that kind of praise from most. But I'd like to think that I know a good deal about how this stuff works. That thrust vector control system is genius. Genius. Nothing screws with an Su-35. I mean, that's one of the few planes that could go toe-to-toe with an F-15, and if pilot skill was equivalent, it'd be pretty evenly matched. Yeah, that's my favorite, dude. Sukhois, Su-35s. I do like the MiG-21, though. The MiG-21 is cool, because the MiG-21 is the same idea as the F-4. Just go faster. Just go faster. Did you see the Checkmate announcement? They made a very good commercial video for it. At MAKS, dude, yeah. I saw it. I was shown it in chat. It looks pretty cool. It looks like they went with a scoop intake that's, it looks like they went with a scoop intake like the X32. I think it's the X32. Yeah, see that scooped intake. It's an interesting design. You know, I was looking at the Checkmate the other day, and you know, I don't see any particular feature here that... I mean, it's kind of like a F-23, I guess. Off-topic question, but do you think Starship will take any big hits in Delta V now that the grid fins are locked in the open position? Negligible. Yeah, negligible amounts. No, this looks to be a pretty cool design. I'm not sure about that scoop intake, though. But then again, Galactic, Boeing came out with something like that. I think it's the X-32. In the early 2000s, there was something with Boeing came up with a design with a similar intake. This was the plane that was competing against the F-35. So this was the X-32. And it had that kind of scooped intake. Now, once again, it's not a copy. That intake is completely different. But the Checkmate does have a similar style of intake. Now, it's not the same. It doesn't look the same at all. And it's split down the middle like a Eurofighter almost. I'm not sure why you'd have an air intake like this. There is a reason. Because, see, what I know about engineering is, like, I don't know exactly what that does. I'll be honest with you. It's probably designed to break the air, to get the air, to vector the air into the engines a certain way. Because we've seen it on two planes now. I saw it on you see it on the Checkmate, and you see it on the X-32. Okay? So that tells me that you'd make an intake like this to achieve a certain result, just like a plane would have canards on it for a certain result. The Eurofighter, for instance, right? The Eurofighter has canards on it so it can move its center of pressure temporarily forward and be able to outturn things, right? The Sukhoi has advanced thrust vectoring so it can do the same thing. If the engines point like this, the plane will drift through the air, like if you're doing a Pugachev's Cobra, right? If you're doing a Cobra maneuver, it's designed to do the same thing. It's all about application. So that tells me that intake is there for a reason. Hey, Zape, welcome to Mission Control. You're going throttle up. And then for the win, 2-month resub. Thanks, guys. So I don't know what that intake does. I'll bet you it's designed to break the air in a certain way to get it to slow down without creating a lot of drag. Fighter jets have this problem, guys. This problem, basically, is that jet engines don't like supersonic air. They really, really don't. They really have an issue with those, with supersonic air. You have to slow the air down. So a good example of that, you have to slow the air down to subsonic. So you have to actually have the air go into the intake and then create drag. You have to create drag somehow. You have to compress the air. Like there needs to be a venturi in the intake before the jet engine, because if air's going in at supersonic speed, it'll just go right through the jet engine and come out. It'll bypass the combustor. It'll just go right through it. They figured this out in the 50s, the Americans and the Soviets. Us and them both figured that out. You need to ramp the intake somehow. You have to get the air to slow down inside of the intake and then feed into the engine, or else the air will just go right through. Yeah, there's also radar cross-section. I doubt the intakes are there for just that, but once again, could be wrong. Alright, so we got our nose cone right there, and I don't have the pointy part of the nose cone. I'm probably going to make that out of a primitive sphere. But we can hide Raph's image again. Why solve one problem when you can solve several at once? Yeah, can pretty much. Dude, good engineering, just because it looks very simple, doesn't mean it wasn't simple to engineer. That's something that I've also learned. Like, I'm sitting here saying, oh, look, SpaceX can make these bulkheads for Starship, right? Look at how easy they made it. When in reality, they had like 6 or 7 different designs of this, and they all blew up on the test stand. This design is easy to make, but it wasn't easy to figure out how to make it right. You know what I mean? They went through a ton of different iterative designs. They blew up test articles on the test stand, and then they figured out the best way to get this done, right? Rumor is it's for international sales, much like the F-35. I mean, Russia has a defense industry just like we do. Just because it, like, farm an F-16, dude, you know. F-16s are very simple. It's a very simple plane, with the exception of the avionics. But it's a pretty simple plane, pretty easy to work on. Don't ask me how I know that. I know guys that worked on F-16s other than present company. It's pretty simple to work on. Does that mean it was easy for General Dynamics to engineer it to be that simple? Hell no, man. No. It's very, very easy to make an engineering thing complicated. It's very, very difficult to make an engineering concept simple. And that's why, you know, keep it simple, stupid is a moniker of all engineers. Hey, Snake, what's going on? So, let's go in here like this. I'm going to take my nose cone that we just made. We're going to move it over here like that, right? And then give me my Starship prototype. We'll move it back into position here. And then, whoop.
Discovery, go at throttle up.
Goat at throttle up. Arga Blue, 21 months. And Marrakesh, 16 months. Thanks for the support, fellas. I appreciate it. All right, so let's duplicate this. And then we'll duplicate that. And then we can hide the image. And boom. Starship. There it is. With payload bay and bulkheads. Just traveling a bit. How are you? How are you? Good, man. I've been following your road trip on the Twitterers. Looks like fun, man. Are the sides of the fuel tanks the same sheet of metal as the outside of the rocket? Yes. Yeah, Flykin. Yeah. The inside of the fuel tank. The inside and outside. The inside of the fuel tank is the outside of the rocket, dude. Yeah, it's one piece. And that, Flykin, that's part of the reason why I'm making these models, okay? Because, see this right here? That's the methane tank, right? See this right here? This section? That's the LOX tank. The bottom, Flykin, it's all about saving mass with rockets. You don't need extra things if take away as many parts as you need. Bare minimum to make it work. And now, don't get me wrong, that's SpaceX's mentality. Not everybody does this, right? But the bottom of the methane tank right here, so that's the methane tank. That's the top of the methane tank, that's the bottom. The bottom of the methane tank is the top of the liquid oxygen tank. This is the LOX tank right there. See? Save mass as much as possible. And these rings right here, inside of the ring, is the fuel. And then it's just one plate. It's one steel sheet. 3 mil thick. Actually, no, 4 mil. 4 mil thick. This one is 4 millimeters. With SpaceX went to kept a 4 mil design. It's 4 millimeter 304L stainless. Inside is fuel, 4 mil steel, outside air. Yep. Yeah, 4 millimeters. So, Flyke, and the other thing is that rockets use pressure. They can pressurize the fuel tank, and it'll keep it stronger. My running thing with that is a can of, well, this is a beer can, but same concept, is a soda can or a beer can. It's open. It's not pressurized. If I tried to crumple this, I could crumple it really easily, right? But if this thing is full and it's not opened, it's under pressure. Stand on it when it's under pressure. You can stand on a can of soda when it's under pressure, and the pressurization will make it stronger. Rockets do that all the time. Heck, some rockets can't stand up unless they're pressurized. Check this out. You want to see what happens when a rocket that uses that principle? Check this out. Look at what happens with this Agena stage when it depressurizes. Well, actually, the Agena didn't depressurize. The first stage of this Atlas Agena did depressurize, and the Atlas can't hold the Agena stage up. There was a LOX leak. Watch. Yeah, drifting. Yep. See, look. If you don't keep it pressurized, that's what happens. Now, don't get me wrong. The Atlas... Oof. And look, see, there's all the RP1 that spilled out. Oh, man. So, they had a LOX leak from the LOX tank, and it popped. See, you can see it's right there. The tank is pressurized, and there's ice on it, right? And then this is a little bit later. You can see that there's no ice on the tank. It depressurized, and there's nothing that you can do. Seriously, there's nothing you can do. It's a fully fueled rocket. You can't go near it. I mean, you can. But it's leaking liquid oxygen everywhere. Super hazardous. So they just kind of had to say, meh, all right, whatever. And then the LOX tank crumples, and then the RP1 tank pops right there. You see how thin that steel is? Ironically, that's actually stainless steel. But Atlas uses the Atlas rocket. That particular Atlas rocket uses what's called balloon tanks. And that's what I mean when I say it can't stand. Oh, that was my guitar. That's what I mean when I say it can't stand up. It'll do that. Now, Starship won't do that. Starship is using 4 mil thick stainless. That balloon tank is like 0.5 millimeter. Yeah. It's like maybe 1 mil at best. Yeah. Now, they don't make Atlas V's first stage like that anymore. Atlas V's first stage is a 7,000, no, it's 7,000 series. 7,000 series aluminum iso grid. I talked about that a little earlier in the stream. It's basically just an aluminum tank that's thick enough to be able to hold itself up. But Atlas's second stage, the Centaur 3, yeah, no, it has to be pressurized. It's not called a balloon tank for no reason. Because if you pop the balloon, the tank will pop like a balloon. They don't call them balloon tanks for nothing. Yeah, aluminum foil is actually a little bit thinner than the outer tank wall on a Centaur stage. But not much thinner. Seriously. Oh yeah, and Centaur 5, dude, I gotta show you how. Here, hold on. ULA's new Centaur stage. You want to see how they make it? They literally take tinfoil in like a vacuum and they form it around a mandrel almost. It's ridiculous how they make these how they make Centaur 5 stages for Vulcan. It would be like if you took tinfoil and put it over a soda can, right? And then vacuum sealed the inside. It would end up hugging the can. You take the can out and you have the can's shape. That's how they make the bulkheads for Centaur 5. It's really friggin' cool, actually. Because they're doing it with metal. They're doing it with stainless steel, which is just... Alright. Hey, Wolfpack. Oh, dude, and once again, this is why I hype on what everyone's doing, because it's so damn cool. I'm trying to find, I'm trying to see if they have a picture of it somewhere. Here, let's see if this one has it. No, that's just an infographic. They have a thing on ICPS. Tori Bruno's talking about Centaur 3 right there. We watched that video. L44, L101, L44 again. Here. Check it out. There's your milled aluminum right there. And they're, look at that. They're machining an orthogrid. Oh, it's so cool. And then look at the brake. That's how they get the panels to curve. That's so cool. That's a thrust ring right there on a 5-axis jig. Internal stringers. Repost for you. So, dumb question. If that's the case, how do rockets not crumple under their own engine power when it has less fuel, let's say on orbit? Great question, actually, dude. It's called tank ullage. A rocket will generally have helium tanks inside of the fuel tanks, and the helium tanks will leak gas into the tank as the fuel drains. It's called tank ullage. Yeah, that's what it does. So right when the rocket engine turns on, the helium tank valves will open and they'll start leaking helium. I say leaking, but they'll start pushing helium into the fuel tank to keep it at the same pressure. Yeah, you touched base on a really, really hard thing to solve with rocketry. Your tank pressure can't change or else it's going to crumple, right? And if you drain all the fuel and ambient pressure outside is vacuum because it's an upper stage, you have to keep that pressure, right? Or else your rocket engine will smush your stage. They have to deal with that same problem during max Q, and that's why maximum dynamic pressure when a rocket launches is such a big deal, because you don't want to push on it in accordion your rocket on the way up. That's, yeah, also a bad idea. Yep, that's a vertical friction stir welder. See, there's the barrel segment. I wonder if they're going to show Centaur in here. Yeah, and inerted, that's right. Look at that. Crazy. You guys notice how that's one piece? How you gonna make a hemispherical piece of aluminum like that? That's some machining pornography right there, dude. But helium is flammable. No, helium is inert. Hydrogen is flammable. Yeah, helium's an inert gas. Yeah, meaning not flammable, not reactive, like nitrogen. They could use nitrogen too, but nitrogen is heavier. Seriously, you want to find a gas that's lighter. Like, and I'm talking about, when I say lighter, I mean mass. Like, helium's mass is lighter. I know about mini motorways, Duber. I watched the Mustang and the E63 go at it, too. I watched it last night. Good stuff. Ullage, Charles. I'll type it in chat. Ullage. Now, the cool thing is that rockets use tank ullage for a lot of different things. So, you know, we're modeling Starship, so I'll tell you about this. So, I'll tell you about this. How these rocket engines work, Starship needs to be simple, right? So, there's an interesting problem to solve with Starship. Starship itself, not so much super heavy, but with Starship. Starship is supposed to go and land on other planets, and the idea with SpaceX is, with what Elon wants to do, right, is that you can refuel on other planets. There's no helium on other planets, and even if, well, that's not true. That's not true. There's helium on other planets. We just, you know, there's just no factory to try to get helium isolated and then fill up your COPVs, right? There's no way to do that. Well, there is, but not right now. When there's no factory there, it's hard to get helium. So, how do you solve the tank ullage problem here? So, say Starship goes and lands on the moon, right? And they're somehow able to make methane on the moon without carbon, right? Let's just play off that contingency. Say they are. Say they could do it. If you had helium tanks inside of here, how are you going to refill the helium tanks? Well, you bring the factory. I mean, they could do that, Owens. Yeah, Starship could do that initially, but not on the first trip. right? So how are you going to solve that problem? There's trace helium in the moon's atmosphere. Yeah, Xanath, but even if we could get at that, it's going to take years to collect all of it and get it to fill up even like one tank. You need a bunch of helium tanks, right? Booster 4 is being unhooked from the transport stand for lift. Why does it need to be refilled? Engil, it needs to be refilled because you need to keep your tanks at a nominal pressure. So a rocket is gonna lose tank pressure because the fuel is draining out and going into the rocket engines, right? You have to keep this at the same pressure. The pressure delta can't be too high, or else the thing will crumple and shatter like that. You don't want to do that. So how a lot of rockets work, how Falcon 9 works, how Atlas 5 works, how Delta works, is they have a bunch of fuel tanks in here. They're called composite overwrap pressure vessels, COPVs for short. And what these COPVs do, they look like this. They're just a bottle that it's kind of like a scuba tank almost. It's a scuba tank that's wrapped in carbon fiber, and they're on the inside of the big tanks. Now, Starship can't do this. Starship is supposed to go to the moon. It's supposed to go to Mars. There's no helium on Mars that we could use to fill up one of these things. Heck, there's not even there's a helium shortage on Earth. Like, that's why helium is so damn expensive, right? But it's the best thing for tankage for rockets. Now, SpaceX is using an idea that they borrowed, believe it or not, from the shuttle program. Now, if we go over here and we look at the space shuttle's external tank, okay? This is the disposable primary structural vessel of the space shuttle. It holds everything together, right? If you look at it, do you see any ullage tanks in there? Nope. Why not? Well, in the case of the space shuttle, the external tank is expendable. It doesn't come back, right? The orange tanks don't come back. They burn up in the atmosphere. So NASA, when they designed this, they wanted to keep the tank as simple as possible. And they don't want to go sit here wasting helium every time they go to launch, right? You don't want to make this complicated. This thing needs to be simple as possible. So NASA came up with the idea with Aerojet Rocketdyne nowadays, with their RS-25 to use what's called autogenous pressurization. Jonas, you already said it. See these two lines right here? Not the big one. That's the fuel line coming from the liquid oxygen tank. That's the fuel line. There's the pickups for the fuel line. And then it goes out the bottom of the LOX tank, takes a right-hand turn right here, and goes around the hydrogen tank, and then that feeds into the bottom of the space shuttle. Simultaneously, the hydrogen tank has a pickup here, and it goes out the top right there to the space shuttle, and then they mix those two, and it goes out the engines. Now, inside of a shuttle engine, they have what's called a tap-off. That tap-off, it's not called a tap-off. I don't believe they called it that with the shuttle engine, but I forget. Long story short, a rocket engine takes liquid fuel and liquid oxidizer, combines them together and shoots them out as gas, right? Out the back. The shuttle engines take a little bit of that gas, a little bit of the gaseous oxygen and a little bit of the gaseous hydrogen, separated, of course, and they pump them. It pumps them through these lines. These two little lines right here are pneumatic lines. Pneumatic means they carry gases, and they go right back into the tanks. So liquid oxygen comes down here. Liquid hydrogen comes down here. They go into the back of the space shuttle. The space shuttle engines, before they blow the gases up, takes a little bit of that liquid oxygen, turns it into gaseous oxygen by heating it up, because rocket engines are hot, and then it takes a little bit of liquid hydrogen and heats that up, and those tap-offs go right into these pneumatic lines. And that's how they maintain tank ullage with something that has no COPVs. It's called autogenous pressurization. SpaceX is using the same thing. They're doing the same thing with Starship. And Super Heavy, for what it's worth. They're doing the same thing. Starship is going to use autogenous pressurization because you can't make helium on Mars yet. Soon, maybe someday. But for right now, for the interim time, if we want to go to Mars and be able to come back pretty easily and not have to worry about sitting there refining helium on the surface for years before you can return, I mean, it's already going to take years before you can return anyway. I mean, but we're talking like 10 years instead of 2 years. The engines actually keep the tanks pressurized with a tap off. Yeah, it's pretty smart. Pretty smart stuff. Hey, Tron. Inching up on that half decade. We're getting old, man. Yeah, I know. What I mean is, can't the helium that was released in the fuel tank go back into the helium tank? You could do that, Engil. Yeah, you could. Now you need a pump. Now you need a pump to pump that helium back into the COPVs. So that's added mass to your rocket. And now on top of that, you're going to need some way to separate the helium. Because if you're pumping helium into a liquid hydrogen tank, some of that hydrogen propellant is going to do what's called boil off. Okay? And when it boils off, because the liquid hydrogen exists as a liquid at a very, very cold temperature, almost 0 Kelvin, which is really cold, like incomprehensibly cold for a human. It needs to be liquid fuel at a very low temperature. I think it's like almost like minus 500 Fahrenheit or something ridiculous like that. I always forget it off the top of my head. I have to go look it up. But long story short, the tank is at really high pressure and the propellant is really, really cold, and that causes it to boil. That screws with the boiling point because physics, right? So some of that hydrogen gas or some of that oxygen or some of that liquid oxygen or liquid hydrogen will boil off and become gas. Now you have helium mixed with hydrogen or mixed with oxygen. That's a problem. So now on top of pumping back into the helium tanks, you have to separate it somehow. You need a separator built into the side of your rocket. You see how this gets complicated real quick? And the easiest way to describe like rocket efficiency to people, I could show you the delta V formula, right? Like, I could show you this, that one up there, the DV formula, to show you the rocket's range. Or I could explain it like this. When you launch a rocket, the more fuel you have on your rocket and the less rocket that you have on your rocket, the further it goes. Simple as that. That's a really easy way to explain that. If you bring something that has alpha radioactivity, you can produce helium. Yeah. Nuclear fissile materials are heavy though, Seg. But yeah, once again, guys, I'm not saying that it's possible. I'm not saying that it's impossible. I'm saying that right now it pays to put less rocket on your rocket. In the future, that might not be the case. When we move to fully reusable rocketry, it doesn't matter how heavy your rocket is, right? If something like Starship works, then putting some kind of separator on it that separates helium so you can reuse it if you want to, that could make more sense. Because saying, like me saying, don't put a helium separator on it, right? And don't put a helium separator on it. It's too heavy. Don't put, a helium pump to be able to pump the helium back into the tanks, right? Don't do that because it's too heavy. That's as stupid of an argument as saying, oh, don't put landing gear on an airliner because it's too heavy. Don't put landing gear on it. That's a stupid idea. Have it land on an air cushion or something. Right? Like, in the future, hopefully, rockets are treated more like airplanes. But for the interim time right now, it pays to put less rocket on your rocket. Less rocket, more fuel, more payload. Goes further. Simple as that. Well, not necessarily more payload, but you get the idea. I mean, seaplane, that was the idea for the longest time, nuclear drifting. If it hadn't been for World War II, we would have flying boats everywhere. Part of the reason that jetliners and airports became commercially viable is that because during World War II, we built airfields everywhere. The Brits, the French, the Germans, the Russians. We built airports everywhere. Some of those airports became racetracks if you're in the UK, Silverstone, for instance. Or if you're in the US, Sebring. Some of those military airports ended up being like Sebring in Florida was a bomber training facility. They trained people to fly B-17s. Or in downtown Orlando, Orlando International Airport has the call sign MCO because it was McCoy Air Force Base. It was a bomber. It was a bomber base with B-52s on it that were stationed there to nuke the trash out of Cuba in case they tried anything. Well, we all know how that ended. I'm really happy that never got used. Yeah. You see what I'm talking about? The reason why we have modern airliners that land on airfields is because during World War II, everyone built airfields everywhere for the war effort. And that's what made that's part of the reason why airlines became commercially viable. If World War II never happened, we would be all flying around on boats right now because there was no money building airfields all over the place and having planes that land on land. We didn't have the infrastructure, so we made flying boats instead. That's why flying boats were a thing for a little while, and then after World War II, it just kind of moved to landing on airfields, like landing on nice concrete slabs and stuff. That's a little bit easier. I didn't know that Sebring was an airport for a base. Yeah, it was a bomber training facility, Merkers. The backstretch at Sebring goes down the ramp where they parked bombers, dude. Here, I'll show you. I mean, in Kerbin, because we can't build infrastructure anywhere, if you're going to explore Kerbin, it pays to build a seaplane. Up until World War II, that's exactly what they did. Sebring is down here. Yeah, if you look at it from here, it's a bomber base. Actually, the backstretch is a runway. The main straight is the ramp. Yeah, this was an Air Force base. It's pretty obvious when you look at it from up here. This was all base housing and stuff where Sector 2 and Sector 3 are. And also, shameless plug for Sebring. It's a great track. Difficult. Very difficult track. Tough track to drive. The bumps on those damn concrete slabs. Oof. Yeah, the concrete ain't doing anybody's suspension any favors, that's for sure. Because these are all slabs, the car does this when it rolls over them. So, like, if you go to try and turn with your tires doing this, they go and you lose traction and you go into the wall. Perm International is a joint civil-military airfield hosting a small number of fighter and bomber planes. Yeah, I mean, Galactic, I mean, on the Eastern Front in World War II, there were airports built everywhere because the front lines was constantly moving forward and back and forward and back and forward and back. So, yeah, I mean, there's tons of infrastructure built out there. In basically from the Urals to the west, all the way to Berlin, there's tons of infrastructure built in there because, well, there was a lot of war happening there. Let's just say that. A lot of war happened in between Moscow and Berlin. Yeah, I'll just say a lot of war and we'll leave it at that. Yeah, but there's tons of airfields all over the place. And then the reason why it goes all the way to the Urals, which I know is east of Moscow by a pretty good distance, is because in 1942, 1943, what the Russians did was they moved all their factories closer to the Urals, out by like Omsk and Novosibirsk, all that way. They pulled all their infrastructure into the center of Russia almost. They moved all the factories that were where the Germans were coming. They packed everything up and left. There's a lot of abandoned airfields. Yep. And that's where Russia's industrial base is to this day. It's in Moscow and everything like east of Moscow to the Ural Mountains. That's where Russia's industrial base is still there. It stayed there. Just like the American industrial base is still basically in the Midwest. For the most part. I mean, it's moved around a little bit, but... The Centaur stuff is 110 in that video. Yeah, alright, here, let's see. Yeah, watch this. Flykin, are you still here? Watch, ready? Did you see it? They pulled it over like a friggin' balloon. Look at how thin that stainless is. Look at watch again. Ready? Thanks, Phil. Ready? Ready? Yes, I need my sound effects. That's important. And then they'll take a bunch of those and they'll weld that all together. That's Centaur 5, dude. Look at that. That bulkhead is as thin as paper. That's why they need such a crazy jig to hold it up, or else it'll just deform like paper. Look at. Oh my goodness, that's so cool. There's the ML. Fun fact, I know the guy that was operating that crane. Just saying. Yeah, there's the sound suppressor. This is the pad and stuff. Yeah. That's how thin it is, Flecken. It's really cool. Alright, so I have my bulkheads. We have our rings. We have our nose cone pieces. We have our aft sections. We got to work on making the header tank, the thrust structure, and then we should work on stringers here. You could punch through it, short line. Oh, absolutely. Yeah, it's as thin as paper, guys. That's not a joke. It's not an exaggeration. I need to set my render distance here with the cameras, just on a side note. Where do we set the render distance? What is the purpose of those water jets around the launch pad? Hooded, that's a sound suppression system. So rockets spray water on the pad in two spots, okay? You have an above the launch table water system, and then you have in the flame trench, okay? This right here is called a sound suppressor, and that one is called a pad deluge, all right? So this one over here, after the rocket launches, it sprays water all over the pad, and the reason why it does that is to protect the pad. Seriously, it protects it. The water absorbs all the heat from the rocket engines and prevents the pad from getting damaged. This thing over here is called a sound suppressor. What they do is, in the flame trench, they spray water through the rocket's exhaust. One, it does cool it down a little bit. And two, it suppresses the sound. Why? Water absorbs sound. Seriously. If you think about like a submarine uses sonar, right? To hear things, because it's not like they have a frigging window, right? They use sonar. They can hear stuff 100 miles, 200 miles, 300 miles away. Heck, some submarines can hear planes flying around. Water absorbs sound really, really well. And they do that to keep the sound of the rocket down. Now, the reason why they do that is not for our hearing. There's no humans near this when this goes off. No. You don't want to be standing right here when the rocket goes off. The sound is enough to, well, kill you. Seriously, the sound waves coming from a rocket engine really is not good for humans' internal organs. I mean, yeah, it's not good for you. That's not why they do this, though. There's a sound suppressor here because the sound from the rocket engines is not just enough to damage a person. It's enough to damage the rocket on the way up. Seriously, the sound bouncing off the ground and reverberating off the ground and coming back up can cause vibrations on the rocket that can cause it to explode. Heck, on the first shuttle mission, they didn't spray enough water on the pad, and it was enough to shake some tiles off of Columbia. Seriously. the SRBs overperformed. They did better than they thought they would. And you can hear it being called on Columbia's ascent trajectory by the flight controllers. Columbia, you're lofting a little bit. You're going to be slightly high at staging. The boosters overperformed, so they didn't spray enough water on the pad. And the sound from the SRBs was so violent, it literally just shook tiles right off. It shook tiles right off the orbiter. What about this? Get this, a giant pit. Soyuz. So the Russians have a sound suppression system with Soyuz, right? The Russians have a sound... well, they don't have a sound suppressor. They have a pad deluge. But the Russians have... here, we'll look at Site 1-5. The Russians just dug a big hole in the ground. But they still spray water on the pad to protect the pad from when the rocket goes off. Because even a small rocket like Soyuz still makes... I mean, still makes... It's still hot. It's not like it's not hot. Oh yeah, the sound isn't good for you. Tell that to Battlefield. Yeah, so the Russians come up with once again, a little more of an elegant solution. Just dig a friggin' big hole. Can't have the sound of the rocket bounce off the ground if there's no ground. Once again, very elegant solution. It's a good idea. It works. It's not smart. It's not the stupidest idea. It's pretty damn smart. Slick 37B just tanks the plumes of the R-68. Yeah. Well, how they did that, Phil, was they put the flame trench... They made the flame trench far enough away from the pad where it doesn't really make a difference. Cosmo Quest, thank you for the raid. We gotta mess with my cameras here. I'm working on making Starship prototypes in here. What was Cosmo Quest up to? Just like the Space Pen pencil. Well, Merkers, there's a caveat to the Space Pen pencil thing, dude. And I'm not saying the Russians are bad at engineering. They know what they're doing. 4 p.m. Space News, you got it, Twitch. I have one of those space pens right here. How long did you say the fuse was? Veronica, what's going on? How you doing, Cosmo Quest Raiders? So, the space pen is a pen that's designed to write in space, right? Because a regular ballpoint pen needs gravity. This Fisher Space Pen is designed to work in space. The Russians just use a pencil, right? And it seems like the pencil is a much easier application. But the thing about the pencil is, pencils create graphite dust. Graphite dust gets clogged in your life support system, and then you can't breathe. And that's why the Russians also engineered a space pen. Yeah, the Russians have their own version of this. Because, yeah, a pencil is an easier application, but pencils create dust. And that graphite dust floats around in space. It doesn't stay on the ground. And guess what? It inevitably clogs up your life support system. Yeah. Elegant solution in that regard, but, yeah, not something you want in the long term. It conducts electricity also. Yeah, I don't need to say why that's probably a bad idea. Crayons? Oh, great. So we want paraffin floating around? Yeah, I don't want that. I'll just use the pen. Thank you very much. Sharpies in space? Sharpies might work, yeah. Anyway. Guys, I'm showing people today, I'm working on building Starship tanks, and I'm showing how SpaceX manufactures the tanks. Like, why they do what they do. All I did was basically model these pieces down here, which is they're very simple pieces, right? The nose cone, the ring, and the bulkheads. And then with these parts right here, I was able to make these. Starship and a Super Heavy. Now, don't get me wrong, I don't have the rocket engines or anything. We gotta do that. Hey, Jalal, what's going on, man? Pretty much, Flykin. Yeah, you don't want water, or you don't want anything getting into your environmental control systems except for basically CO2. Looks like they are having a problem with one of the lines connected to the Booster 4 fuel lines. Alright, so what should we make next? The next thing... I really want to get the camera clipping figured out here because this is... Here, let's go into here and see if we can get the camera clip figured out. The clip plane is what I'm looking for. Focal length, lens squeeze, ratio stop, focus distance, shutter angle, COI. Headed off to school in 2 weeks, gotta leave the PC behind. Oh, that stinks. But hey, it is what it is, dude. What are you going to school for, Jill? I'll refresh my memory. Hang on. Camera attribute, far clip plane. Let's set the far clip plane to 1,000. Now we're talking. There we go. I'm gonna set it actually to 2,000 just so I can zoom out and we can see everything. Perfect. Yeah, that's what I was looking for. Excellent. Also, wasn't there another thing where one of the sections was reporting a fire and there wasn't any? It turned out to be a leak of a dangerous gas. Yeah, stuff like that happens all the time. It's just routine. It's just maintenance, man. It's just like if you're in a house and you have old pipes and a pipe bursts. It's just another thing to fix. There's maintenance on stuff in space. It doesn't last forever. All right. Sweet. So we were able to put all this stuff together. I think the next thing we should do is I should work on the thrust structure here. And then we should work on the header tank and then we should work on the cap and the nose cone there. Once again, I'm trying to make this out of as many simple pieces as possible. Alright, that goes over here like this. And then close that out and see, yeah, now I can see everything, so we can... Yeah. Oh, yeah, that starts to get a little messed up. Didn't like that. Yeah, whatever. From far away, yeah, because the edges are close to each other. Yeah, like, Also, EJ, what do you think about Nucleon and Zeus space concept? I like it. Galactic? We're trying to do something like that too, but Nucleon is a cool idea. That's good call. We should make more things like that. Nuclear space tugs with ion systems, with ion propulsion. Horosho. Etyo horosho. We should do that more. Okay, so let's work on the thrust structure here. Let's go out of here. Let's get out of that. We don't need the jig like that. We don't need Baikonur. Do we have a render of the thrust structure? Thomas, is the thrust structure still that cone piece? Oh, baby. Look at that picture from last night. Unbelievable. Eee, that's nice. I want to make this next. Fuel delivery manifold. That's the methane. That's the methane delivery manifold, which is for super heavy, which is insane. 29 pipes. It's a 29 port manifold, which is just okay. And now memes. So Norway? Always has been. How easy is it to hook up a rocket engine? SpaceX did it fast. It's a couple of bolts. That was dank meme. Alright, let's go over here. Alright, that's what it looks like, Thomas. Is there roughly a set time for Space News to start at? About an hour, broke. Okay, so it's got a lip like that, and then it goes up, and it's got a bunch of stringers. And then we have the pipes. Oh, that's... yeah, all right. First complex object of the day. Okay, so methane comes through here, this pipe, right? And then that splits into three, I think. Thomas, do we got a picture of this? I got a picture of the bottom of this thing so I can see where the methane pipes are. That's the methane inlet right there, no doubt. Please hold. Holding. Alright, so get my images back up here. I'm going to rotate Raphael's image upside down here. Raphael Adami is a NASA spaceflight forums user. File097 made this blueprint, and I'm using it. Using it here for reference. Okay. I'm gonna save these pictures in my Starship folder. Thanks, man. What's up, Sirius? Look what I found bot today. That's... didn't copy the right thing. Oh, that's cool. It's NASA playing cards, and each one has a bunch of different missions on it. That's cool. They have mission patches. I like it. What exactly are we modeling of Starship? Yes. I'm working on the thrust puck right now, Swishio. The thrust puck is the piece of Starship where all the Raptors are attached to. It holds the three vacuum... vacuum. It holds the three Raptor centers. These things. It's the things that these are mounted to, or the thing. We're gonna make that now. We got about an hour left, so I can get the basic shape of it right there, and that's what we'll do. So give me a cylinder here. And I'm actually gonna make this thing upside down. So this is our first kind of detailed part in here. All right, so let me set the pivot point here.
Discovery, go at throttle up.
Hey, Pork. Hope you're having a good day. Absolutely, man. Making Starship parts. I'm going to make the thrust structure here. And now that can go right there, because that's the one with the thrust structure, right? Yes, it is. Okay. So I'm just going to put that there kind of as just a a reference here. Now let me get the image back up. Okay. Okay. That's a mount. There's a gimbal actuator. There's another gimbal actuator right there. That piece is going to be difficult to make. But we're working on just primitives right now. Okay, I think I see it. Alright. So, the first thing that I'm going to do... Still sealed? Oh, very nice. First thing that I'm going to do is make this go slightly up and out. Actually, right there should be fine. Okay, so now that gives me my base right here, the buttery biscuit base. Actually, the image doesn't need to be... because the thrust structure is right side up. So Starship uses methane. It runs on poop. People order our patties. Those yellow things are stiffener rings, just like on the MVAC, right? Yellow things, Swishio? I think that's just... those are just covers so people don't bump into it and chip the outside of the nozzle. Those are not... that's not something that's going to stay on there. Are you planning to play Starbase? Yep. Why is it that when something happens, it's always you three? Self-burn? They're pool noodles, Swishio. Alright, so it seems like the inside of this goes kind of straight down and in. Alright, so let's go back over here. We need to take this, and I'm just using scale. I'm just taking the scale and making it smaller or bigger. And then let me look at reference again. So we need to make a little bit of a lip, almost. How am I going to do that? So that basically needs to go like that, right? Actually, you know what? You know what's a better way to do that to ensure that that's right? Select this piece again, grab its vertices, right? And then move it in here like this. And then I'm going to use what's called face extrusion here, where I'm going to select only the bottom faces on this, and I'm going to hit Control E, and we should be able to extrude down. There we go. Perfect. And then there's a little bit of a lip there for the methane inlet. So I'm going to do the same thing. We're going to go up here like this, and then right around here, the fuel lines inside look very nice. SN-17's aft. Okay. I'm not at the fuel lines yet, but... Oh. Oh. Ooh. Ooh. Oh, I like how they did that. Yeah, they split it to go around the methane line. Yeah, very nice. There's your methane inlet line, so that's coming from the pad, going into the methane downcomer. And then there's your locks. The locks just pours in. And then there's valves. There's 3 valves right there. And the valves will open to pressurize the header tank. And fill it up too. That's cool. That's really cool, actually. I wonder if I actually have a... Actually, no. Well, there's 3 inlets right there. Interesting. It's not that bad, Swishio. If you've been paying attention to my... Like, how I make stuff in Kerbal, same thing. Alright, so... We're going to extrude, and then we're going to scale inwards and upwards just a little bit. Because I'm trying to get that right there. See that ridge? That's where the structure for the thrust puck stops. And then this is methane. This is the methane tube. It splits it. It looks like it's in a plenum right there, and that plenum splits into 3. Yeah, that's definitely what's going on there. There's definitely a methane plenum right there. And then see, these are the methane inlets for the 3 Raptors right there. We can model all this later. It's gotta kind of take it one at a time. So I'm going to use the scale function to get that flat, right? Then give me those faces right. Ooh, I did it bad. I screwed up. I screwed up badly. Undo. I double extruded stuff, and I think I had it set to edges, and it extruded edges and not faces. That's not what I wanted. So let me just make sure that this piece is not like screwed up in any way. Okay. Alright, so... Yeah, see, I need to make that lip right there. Okay. Got that all figured out. Now we can extrude out the rest of this. Perfect. And now we have a little bit of a curved shape going up to the top of where the methane downcomer comes in.
Discovery, go at throttle up.
Hey, Tom, what's up, dude? That's a 9-monther. And so I added an extra line in there. We added an extra loop so I can make the rest of the methane pipe. And now I just gotta... The edge normals came out a little weird. Yeah, okay, but see how now you can't see that indent line? So what I'm gonna do is I'm gonna play with the edge normals here, go to the edge loop, and then I'm gonna harden those edge normals. It's hard. Edge normals are just basically... It basically just is a way for the geometry to tell how a texture or how a shader will figure out that edge. So if I harden the edge normal, see how there's a defined line in there now? It's a little bit easier to see. If I softened out the edge normals or kept them soft, look. Now you can't really see it. It's just telling it how to kind of understand the shading. Understand how the edge shading works. They're called edge normals. And once again, I want these ones to be hardened edges so you can see that defined line a lot easier. Just bought an electric bicycle. Oh, that's cool. Oh, see down here? Hardened edge normals make this look like a... You can see the lines right there. That's very defined. You don't want that. We'll soften the normals out, and now that should look like it's nice and smooth. Okay, making progress. Now this thing has like kind of a lip almost to it.
Discovery, no one
So what we're gonna do is I'm actually gonna move these up like this. No. I'm thinking. Switch you. Grazie, amico. So it looks like there's a lip on the thrust puck that goes up and out. And I'm not sure how I'm going to make that. I think what I could do is take this edge and move it inwards just a little bit. Like that. And then what we can do is if I go into my edge loop tool, right? We'll take this edge, 2-edge ring and split, right? And then move that like that. Just move it up just a little bit. I don't want to split that edge in half, right? Oh. I don't want to select the bottom faces, just the side faces, like that. Because what I want to do is I'm going to extrude it again. Then we're going to go out with it like this. And we're going to make that lip piece that's down at the bottom. See this thing? This kind of like angled up piece like that. It looks like this piece goes down and then it goes out and up and over. So I'm going to work on that right here. Yeah, there we go. I'm pretty sure that's what we're looking for. Actually, the way I had it is pretty good the way that it is. I think that's good. Good enough. How does that look? Oh. Damn edge normals. I need these ones to be hardened edges because they're defining lines. There we go. Perfect. Sick. Now, let me just, okay. So, okay, that's the seam right there. All right, got it. Do we know of a new ETA for Starliner? Something is wrong with the valves, dude. Yeah, something's weird with it was a mechanical thing. And I'm not sure how it was missed during like checkout or anything, but yeah. But hey, it's their first try. Give them a second, man. It's gonna take a second to get it right. Okay. Looking good. My man. Slow down. Looking good. My man. Excellent. I want Crew Dream Chaser already. Don't we all? What's up, Canadian? How you doing? I'm thinking Minecraft for tomorrow for early hours. Or it could be tomorrow, it could be Friday. What's easier for you? I want to like to know. If possible, what would be better? Alright, so this goes in a good ways, and then it basically goes straight down, and it looks like it has more internal stringers right there. If I remember correctly, the RCS valves were cross-wired on the first one too. I don't remember that happening. Fridays are better for me, Saturdays are best. We can do Minecraft on Saturdays, but, well, dude, doing early hours on Saturdays after a long Friday stream kills me, dude. So we'll aim for Friday, okay? Could do back to back, maybe. I want to keep working on that project. I don't want to be away for too long, man. We got to keep going. City ain't gonna build itself. No, that's too much. We need to be out here, like, kind of. Let me look at this again. Yeah. Okay. It looks like. It looks like that this goes this is hollow, right? And it goes inwards, right? And then it connects right there. Like, the piece, like if you have your piece like this and it goes out like that, and then we have the lip piece that we just made, right? And then it looks like it goes in, and this spot is where you mount the engines, right? And then right here, there's that dip, right? And it looks like it goes like that, and then it revolves in a cylinder. And then there's a methane plenum right here, and then the pipes come out. Like that. I think that's what we have here. So I think the lip right there is the key. Are you the gatekeeper? Are you the key master? That's a long way in, actually, now that I'm looking at it. Yeah, okay. Because it needs room for the mount. We are working on the on-ramps, off-ramps for the highway. Much trickier to make them look right than expected. Yeah, I know what you mean. Let me go into the top view. So that's the lip, right? And then that edge right there is the mount. No, the lip's right there. Okay, I see it. Yep, alright, I knew that didn't look right. This needs to be like right there, for the most part. Like there. And then, actually, hang on, let me just move that back into position. Cool. So right now, guys, I'm working on the thrust puck for Starship. And then if the engine mount is right there, the engine mount slightly clips over a little bit. So now what I can do is extrude this up like that. That doesn't look right. So let's go in here like this. What's up, my pick? That looks to be the right size right there. Yeah, I think that's maybe just a little bit more. Are you modeling the internals too? Yeah, man. I'm working on the thrust puck right now. I mean, this isn't necessarily an internal, but the way I had this set up is, yeah, I could do it. Here, you want to see what I have? Look, I modeled the bulkheads, the ring, and the nose cone. So I have the thrust bulkhead, methane bulkhead, bottom, or the CBH, and then the top, and then the ring, and then the nose cone. And, you know, I made some prototypes here, and those look right to me. Is this going into the 3D printer? Nah. No, Swish, it's just gonna, just want to model something, man, that's all. Yeah, that's pretty much it. There. Now we're talking, dudes. Okay, so now these inner pieces here need to go down like that, and then something about that doesn't look right either. Maybe there's the methane plenum right there, but see. Huh. Okay. I mean, these... I don't think the inner wall does that, does it? I don't think it does that. It's going good, Sneaky. How are you? I don't think the inner wall does that, but it definitely looks like... It looks like this goes a good ways in. And then, when I say there's a plenum, I mean there's just basically a... Like, it's not... A plenum is just kind of an area that you store something before it splits into a bunch of different things. So, like... A plenum is at the beginning of like a manifold. Like an intake manifold on a car has a plenum that has air kind of sitting there, and then when one of the pistons open, when one of the intake valves open up, it pumps air that way because the piston goes down, right? And then another one opens up and it pumps some air that way, right? With this though, it's liquid. Pustthruck. But see, the thing is that if you look at this picture, that's definitely straight up and down. The inner wall of this is definitely flat. But if I go over here, right, and then I take this inner edge and I make it look like that, that doesn't look right. That does not look like that. There's an optical illusion here that I'm missing. See, you can see those weld marks right there? Those weld marks are the stringers. That's these. That's the weld marks from those. And there's definitely an internal... You can see there's a weld mark right here. These are pen marks. Those are penetration marks. When you weld stainless or aluminum or steel... You want to get good pen with the weld. If you don't get good pen with the weld, it's going to be a bad weld. You want the weld to go all the way through. And you can clearly see that weld, that stainless weld went all the way through because you can see the burn mark right there. Simultaneously, this is the top side of the weld for these stringers right here. You flip it over, you can see the burn marks for those stringers, which means the stringers are going up to here, which leads me to believe that this piece right here is that piece. It's the lip. Which means that this thing, yeah, is way low down on this. Okay, cool. That actually explains a lot. Excellent. Because this doesn't look right. That's much too big. So let's go in here like this, loop that over, select both of those edges, right? And move them out like this. Because, yeah, see, that looks a lot better. Yeah, okay. Yeah, alright. I figured it out. What are we looking at, please? It's the thrust structure for Starship. That way that goes right there. And then this one goes right there. So, there. Just like that. Now, does that look more like it? Yeah. Yeah, see that burn mark? It's about halfway up this where that connects back in. So, like, if we just cut this thing in half, it would look like this. So the methane downpipe comes in, right? And then you have your lip, right? And then it goes down again. And then you have your lip out here, like this. And that connects into the tank bulkhead, right? So, like, liquid would be right here. then it goes inward like this, and then it does that. Right, and then it's got stringers there and stringers there, and then this is where the motor mount is, right here. It's a freaking bug in my face. And that would make sense because that means the LOX line would come out here. Because we know the LOX line goes right in through the motor mount into the Raptor engine. The Raptor engine would be down here, so there would be a mount like this, and then the rocket would be down there. Yep. Okay. Can I get Perm to share something for Space News? I'll accept the links when I go on break, Duber. But yeah, just remind me when I come back. Are you going to do the same thing for Super Heavy? Goof, I don't think that Super Heavy utilizes the same thrust puck. I thought that it would for the longest time, and then they said how many engines would be on it, and I was like, yeah, they're not doing that. The Super Heavy thrust puck is a little bit, it's bigger, first of all, and it's a little bit different. Yeah. Super Heavy is confusing. Real confusing. Yeah, Super Heavy has this. Yeah, exactly. The octopus. Yeah, the thrust puck is a little bit different. Yeah. That's Starships, and that's Super Heavies. Oh boy. Okay. It's probably not confusing if we broke it down and figured it out. There's one pipe going straight down into the engine that's right above, and then these are splitting like that. This is the methane, right? And then these are going to the outer ones. You don't have enough diameter to put all of them on one, so you stagger them and stack them. And then these right here, these outer plates are just gussets to hold the whole thing in place because it's going to be under a lot of load because the engines are basically pushing on the thrust plate, which is what this is attached to, right? And then you also don't want to compressive shock load the downcomer, which is why they have a flex pipe right there. Makes perfect sense, Thomas. It makes sense to me. Pretty straightforward stuff when you think about it. I'm wondering, it's interesting why they went with a funnel right there for the LOX lines. Or no, these are the methane lines. Why would you do that? Why would you go from a big to small diameter? I wonder why they reduced. I'm sure there's a good reason. I just don't know what it is. To increase velocity? I mean, yeah, it's possible. Yeah, probably. I mean, I can't really think of another reason. Can you guys? So there's the thrust puck. and now we gotta do... We could do the stringer pieces, which shouldn't be too hard. They are undoing the hold-down straps that are stabilizing booster 4 to the SPMT. Cool. Maybe confusing is a wrong word. Complex is a much better word. Yeah, I'll go with complex. That's fine. Okay, so now we have to add a couple of pipes. Not that, not yet. This is what we need to work on. So I need to make something like this. So we only really need to model that flange once. There's a flange here with a bunch of bolt holes in it. These black pieces are just covers. It's just a protective cover to make sure nothing poopy gets in there. And then they have the bottom capped off. There's just a metal cup right there that they welded temporarily, of course. These are gimbal actuators right there. I should be able to make that. That shouldn't be an issue. That's those pieces. Yeah, we can make that. We can use some vertex chamfering to do that. Shouldn't be too hard. The mount plate on the thrust structure might be a little bit more difficult to figure out. Okay. Impressive work. Thanks, man. Alright, so the pipes. I'm going to do that. Because this thing does need to go... We need basically a gigantic... Yeah, see, they have a capped flange up there as well. I wonder why they ribbed it like that. See, that's weird. See, there's all these small things here and there that it's just really weird to understand it. Yeah, painter's tape. That's the methane inlet line here. That's coming from the pad, so... See the methane inlet right there? There's your LOX inlet right there. The LOX inlet just leads basically in here and just fills the tank up. Alright, so... Give me 1 second, I'm just trying to make the that methane plenuma jig here. Looks like Astra might be launching in a window running from the 16th to the 19th per the TFRs. Cool, cool. Ah, wired. Yeah, what do they know, Galactic? Alright, let me look at this picture again. Okay, so this goes to the lip, basically, right? To about here. I'm basically making the inside of the methane line. And now we can extrude this out one more time and then kind of... It looks like it does something like this. And now... For these edges in here... Man, this is going to be a pain in the butt to UV if I ever do it. There. Cool. And then the 3 methane pipes will come out of there. Now you can see how I'm good with KSP. It's just a CAD system, man. I keep telling people this. All right. That's a good enough shape for the thrust puck right now. And we can get, dude, we can get crazy with this if you want. Like, I can get very detailed. There's tricks that you can do to get this super, super freaking detailed. Are the binds controls similar to KSP? Kind of. Like, to get into the gizmos, instead of 1, 2, 3, and 4, it's W, E, and R for translate, rotate, and scale. It's close enough. It's close enough to get the point across. Okay, cool. All right, so I don't need the image plane for a while. Nice. That piece came out good. Now we got to do the stringers and everything. Okay, we can model one more piece and then we'll start Space News, okay? So I don't think I need the bulkhead anymore, so we can... I can move the bulkhead just off back to its position over there. Alright, how does this piece look? It doesn't look bad, but we have some nasty edge normal problems here. There we go. And that one we can soften it. There you go. Nice and clean. You would love the ship I'm building in Starbase. It is almost exactly like this program you're using right now. Yeah, no, I know. Starbase, dude. Starbase is the real deal, man. Thrust. Thrust, puck, Groupo. Okay, so what I'm going to do here is I'm going to save as. We're going to save a new file. Okay, that looks real good. Now we got to do the stringers and we got to do the pipes. We can do that, or we can do the upper pipes first. I'll do these ones. The stringers shouldn't be too hard to figure out. The stringers are just an extruded piece. Well, not extruded. It's just bar stock. Well, not bar stock. It's box stock for the most part. It looks like it's just cut down. The welds might be hard to. I don't know. I don't know how high res I really want to make this. The welds could be. I could model them, but it would be better if I was texturing this. It would be better to just texture it. Like I can weld all the burn, like we can texture all the burn marks for it if we need to. Thomas, do we have a picture of these with no covers on them? I'm seriously impressed with your Maya skills. Did you do 3D modeling for work at some point? I thought you mentioned that a while ago. Hammer nails, I went to school for it. Are you modeling just for fun? Yeah, it's actually Appler. I was using Maya the other day to show people the ISS during what happened with Nelka. And people really seem to like that. So might as well do it with Starship. We talk about the damn thing every day. See? I only modeled this. That's all I modeled. And then we were able to duplicate the parts and make a lot of stuff there. Send me the file so I can print it. Printing it would be difficult. I can get you a photo. I mean, yeah, Gold. I can imagine what this looks like. I suppose still has a cover on it, but it's bolted. Let's see. Thomas is my guy, Gold. Yeah, just a standard pipe flange. Alright, we'll bust this out. Doing that might be a little bit difficult. And then chamfering, not chamfering, doing a vertex cut might be. I'm thinking about how I'm going to make this. Alright, let's do it quick. I should be able to get this done quickly. So take the thrust puck, and I'm just going to move the thrust puck over here for now. And then let's go in here like this, and I've been using 20-sided polys, which is high poly count, but I'm modeling for detail right now, so it's okay. Alright, let me... Alright. Actually, you know what? Delete that and bring the thrust puck back over so I can get the right scale. Give me a primitive cylinder. Give me a primitive cylinder. I hit Z by accident. Alright, just move that off to the side for a second, and now we got to come up with the pipe. So the pipe should be about that diameter. I mean, I'm going to eyeball this. It doesn't... So the pipe with its diameter goes about halfway up here, a little less than halfway up, right? And then it basically needs to fit right here. Yeah, what we have is pretty much right. And then the top needs to go up here, the bottom needs to go down. Obviously, it needs to go down into the thrust puck. I gotta mess with that. I'll work on that in a moment. Thanks, Supercraft. Alright, so take this. Take the edge loops and extrude them inwards like this. And we're going to make a pipe, right? I'm not sure what the stock of that pipe is, but I'd assume it's pretty thick. We'll just go there. That should be fine. Now take these and you can use the scale to get them coplanar. So if you scale down like that on the y-axis, because I scaled them in, those faces they weren't flat, but now they are. All right, so now we're going to go to that edge loop, right? And then I'm going to extrude it down here. And we're going to basically, I made the pipe hollow. That's all. So now I'm going to take these, right? And then like that. And now it looks like we made a full cylinder, right? But we got to do something else a little bit here. These vertices that I brought next to each other, they're actually not... See, they're not welded. We got to weld them to each other. So... No, not vertex normals. Back it out. Back it out. Merge the verts. And now... I welded those two together, and now if I select this, it's one thing. I'm gonna basically weld those things together, or in Maya it's called merging the vertices. And then G is repeat command. You gotta be careful here. You don't want to select too many, because if you select too many and your threshold is too high, like watch. If I select that and I hit G, see how it merged all of them? So that's an attribute for the vertex merging function right there. See how it merged all of them together? There's a threshold. The threshold is how many vertices are within a certain distance of the thing that you're trying to merge. If you don't have the threshold set correctly, it's going to merge too many verts for you, and you're going to have to untangle that later. You can set the threshold in the editor up here. Like if you go up here and you go into the merge options, you could set your distance threshold, and that distance threshold is correlative to the grid that you're using. So 0.1 is 10 centimeters. Now, if you're wondering why that's going on, it's because the camera shape is clipping into the object. I need a hug. Okay, Bree. Yeah, I know. I'm sorry. Okay, so now all of this is sewn back together. It's one shape. So we can soften the edges on the inside and out. And now we got a pipe. See? I made it hollow. Right? Pretty straightforward stuff. Alright, now we got to make the flange at the top. This piece shouldn't be too... That should be really easy. So... let me go to my edge loop tool. We want to insert an edge loop here. Insert an edge loop here. And then insert an edge loop basically there. That's fine. You know what? It would probably be better if I saved that function for last, the vertex making the pipe hollow. It would be better for our workflow if we did that last. I'll show you why in a second. And heck, I'm going to go even as far as, for now, deleting the top face. So now what I'm going to do is take these, right, and we're going to go out with them like this. Like that. Okay, but that's not the right shape that we have right here. They're about to lift booster 4. I know, Andy. Yeah. Yeah, see, that's not exactly the right shape. It's close. Now we can take this edge loop, right? And we can move this up here. And what we can do is make those coplanar with the scale tool, right? And now that almost looks right. That's close, once again, but not exact. I'm going to take this edge loop, right? And then we're just going to scale it out a little bit.
Discovery, go at throttle up.
Cool. Hey, human, 26-month resub. I'm sorry, Bree. That sucks. Now, the reason why I wanted to save that pipe function thingamajigger for last is because with this top piece,
Discovery,
go at throttle up. Human gifted a sub to chill Cottontail? Thanks. There. There's your pipe flange, right? And now this is going to extrude down like that, but yeah, see? Now, now we take those, make them coplanar like that, and then we're going to do the same vertex merge function. Now what I got to see is if I can double select these and then do a vertex merge. Yeah, vertex merge. Yeah, we can. Okay. See, we can select a bunch of vertices because he's outside of the vertex mesh threshold, merging threshold. So we just merged all of them together, and now this should move both of the faces. Yep, perfect. All right, there you go. There's your pipe. Done. We can go into our side view here. Soften the edges, go into the side view again, soften those edges, go back into object mode. Now we have a pipe. I'm going to select that edge though, and we're going to harden that edge. Okay. Are you planning to use this in a 3D animation? Nope. I'm just planning to model. I haven't done this in a while, Kaz. Okay. This is the locks. So I'm gonna put TP for thrust puck. Let's go there. TP locks pipe. That's the locks main pipe, and then now we got to make the header pipe. The pipe that should go from the that's the locks main. I think this one is attached to the header tank. All right, so if I duplicate this, now what angle do you think that's at? 45? Like that? I'm not really making my own parts in KSP per se. I'm just modeling this so I can show people. Guys, I always have to sit here and draw out a paint diagram and show everybody how this all works. It probably would be better if I just had a 3D model, right? That's why I'm doing this. That's the main reason. I just want to 3D model this so I can show people how this all comes together. Okay, so that flange is basically lined up with that flange right there. So, flange. Yeah, having a visual would be really useful, huh? It looks like my... It looks like these might be a little too long. I think SpaceX's are more like that. All right, so then in that regard, we get rid of that, and then we duplicate this, and then we move it 45 like that. I should start Space News, guys. We gotta start it soon. And then just basically move it that way until we figure out exactly where it needs to go. Yeah, that's close enough. I think that's right. I mean, it doesn't have to be exact. Once again, it's just a visual representation, right? All right, so here's what we'll do. Give me the edge loop, insert the edge loop, right? We're gonna do that right there. And then I'm gonna take these faces down here for this piece, and we're gonna get rid of them. So now we have just an empty pipe. But the inside of that pipe is right there. We'd have to section this piece out. I mean, if I'm remembering correctly, there's a way to do this. No, that's not it. Is it a boolean? Yeah, that's what it is. I remember now. Yeah, we can cut that thing. I just forget where the intersection. Oh, baby. Score. Alright, yeah, it's a boolean. Thank you. I forgot the name for it, dude. Difference. Nope, that's not what we want. We have to... Union? Oh gosh, no. Alright, so let me duplicate this, right? I'm just gonna move this piece off to the side for a second. And then I'm gonna duplicate this and we'll move that off to the side for a second. Alright, let's do that. And then I think we have to do a different, or an intersection. Yeah. Perfect. Ooh. It did not like that. Something strange is happening here. I have to mess with the Boolean tools. You can check this for another chuckle after Grab's link. If you need a quick chuckle break, check this out. Ugh. Ew. Solid as a brick. Nice. You know what's funny? When people come in here speaking other languages and swearing in other languages and thinking that I don't understand that. A Boolean we might not have to do that. Let me So something strange is happening right there. See that? Oh, it's putting vertices all over the place. Yeah, the Boolean might be a little bit too much for it to understand. Screw that. Okay, it's 4. I'm here. Bad cop has arrived. What's up, Jim? So here's how we'll do this. I'll use a split polygon, which is called multi-cut now. It used to be called the split polygon tool. A Boolean would be better, but it's okay. The tool, I forget how to use the damn tool, because reasons. So I'll just use the multi-cut, and we'll go from there. So I'm cutting the surface into this, and then what we're gonna do is I'm gonna make these pipes one thing. And then, boop, there. Much better. Last, I got a question for you. Alright, I'm gonna take a break. Any chance for you to return to Hearts of Iron? Yeah, maybe. Maybe, dude. Oh, I want to keep going because I'm on a roll, but it's alright. Here, I'll just delete this and let myself know next time what I was doing. So what I'm going to do is I'm going to cut both of those pipes with the multi-cut tool, combine them, and then merge them and make them one piece. Once again, it'll be difficult to, might be a little bit on the difficult side to, might be a little bit on the difficult side to UV that, but it's alright. Anyway, alright guys, I'll be back in a second. Let me save that thing out, and yeah, we'll keep working on that some other time. Maybe we'll just keep doing it on Wednesdays. I don't know. I'm going to take the downcomer images and save them. All those pictures from the downcomer. Thank you for the reference, guys. I really appreciate it. Reference is such a big pain in the butt. That's such a big deal. All right, I'm going to... That's such a big deal to get it all, and you guys are doing me a huge solid by getting the reference for me. Thank you, Thomas. Oh yeah, the Rocket Lab tour. We can watch that. Let me just make sure that I'm wading through everything here. I just want to sort out all my reference pictures with comparatively to the Space News links. I gotta wade through it because I have a bunch. Okay, that's the entire save that. I have that already. We have that. Okay. Cool. Boop. All right. Anyway, fellas, I'll be back in a second here. I'll be back in a moment. I'll switch this over to Space News now, and we'll go from there. Okay, be back in a moment. I brought up the wrong thing there, but I think I have it now, so... All right, dudes. Actually, you know what? I'm here. I know that's what everybody wants to see, so let's get the booster force stacking. Alright. I got my coffee, and I'm going to bring up our buddies over at NASA Spaceflight here. This is the NSF stream. If you guys want to, if you want the link to the stream, just let me know. But these are our buddies over at NASA Spaceflight here. And once again, the NSF guys are cool enough to be able to let me restream this. They don't let everybody do that, and I do appreciate it. Just make sure you go over there and support them over on YouTube, okay? I'm serious. Like, and you know I wouldn't unironically say go and subscribe to a YouTube channel if I didn't absolutely freaking mean it. So just make sure you head over there and support those guys. So, you know, if we, you know, get enough people going over there and subscribing to the channel, they'll keep letting me watch it over here. Right? So let's check it out. So what we're seeing here is Booster 4. This is Booster 4, the fourth super heavy or Starship first stage, I guess. They kind of just call it super heavy. They're lifting it onto the launch pad. This is actually a pretty big deal. Booster 4 is carrying 29 Raptors on it. You can see them right there. You're trying to follow along in Blender. Oh, that's cool, Unprod. Yeah, there you go. Nice. Yeah, 29 Raptor engines. They stacked them overnight. And Starship, which was in two pieces yesterday, Starship 20, which was in, once again, it was in two pieces. They stacked that too, and they installed its engines overnight. So it's really a nocturnal endeavor at this point. Plumbing really juts out. Yeah, right? Yeah, super heavy is straight up engines bristling out the sides. How much is 29 Raptors approximately be worth? If you have to ask, you probably can't afford it, Raw. Dude, I don't know. SpaceX really hasn't been too forthcoming with how much one of these things costs. I can't imagine, like, maybe like $10 million a motor or something like that. That's a huge guess. That's a huge guess based off of other rockets, fellas. Huge guess based off of other rocket motors. Like shuttle engines are like 20 million a pop. And maybe this deep into production, SpaceX has probably gotten the price per unit down because they're making a lot of them, but I have no freaking idea, dudes. Around 1 to 2 million. Well, that's their target, Ian. From what I understand, that's the target price, isn't it? I give a very conservative guess, S-Master, and that's just based off of other rocket engines. But once again, there's not many other rocket engines that have been, even at this point, there aren't many other rocket engines that have been produced in these quantities. I'm pretty sure there's more Raptor engines than shuttle engines at this point. Like total shuttle engines from the entire program. I'm fairly confident there's, yeah. It was active at $2 million a year ago, so $1 million is the target. Crazy. It's crazy, Ian. So if we're figuring, all right, we can do the math out. If we're figuring $2 million a pop on the upper end for a Raptor price, there's 29 of them, so 50. You're looking at about 58 million right there, and that's not including the super heavy tank, which is, yeah. I mean, heck, considering what that thing does, how much do you figure for the tanks? Another couple mil? So let's figure like 60 million. 60 million for that is actually really good considering what that does. It's literally the most powerful first stage ever devised. What about the AJ-26? Maybe. I think the only somebody would have to go look. I'm not sure how many AJ26s were produced. It was they made 4 N1s, and then there was a 5th, and then they dismantled it, and those leftover engines found in Taris, right? So maybe there were more NK15s and NK33s than Raptors at this point. But the most widely produced rocket engine, I think, at this point is Merlin by a long shot. The Merlin engine, they've made thousands of them at this point. See Ian's last. And Elon said he wants $1,000 a ton of thrust. So at 230 tons, he wants to hit 230K. Makes sense. Yeah, that Tim interview was amazing. Hey, Mutter, 71 months. Someone forgot the pants. Yep. Yeah, it has no Atlas pants on it. I think this will do a 9-segment test hypersonic. I want to pretend like I heard that somewhere, but Steven, I think it's just the name, Finn. The name or the spray paint is just, they spray painted it at different points on the nozzle. 230K is unheard of. That's sci-fi numbers. Well, Bouncy, if you guys watched Tim Dodd's interview with Elon, the first part, there's a 3-part thing. I watched it last night after the stream. I purposely made some time to go and watch it. Tim doesn't want his stuff being restreamed, which is fine. I totally get it. I'm not going to take that personally, and nobody here should either. So I watched it on my own time. But it really gives you a good insight as to where Elon's at with scalability. This is why he's obsessed with production. Because he knows that, look, you can make a rocket engine like the Saturn V, or you can make a rocket like the Saturn V, and you can make it powerful enough to move stuff to the moon. That's all fine and dandy. And that is expensive. But that's only half the battle in his mind. Well, actually, not even. That's like maybe a third of the battle. The other 2/3 are building a lot of them. If you have a lot of capital and you can manufacture a lot of these things, then the price will come down over time. It's economies of scale. And we know Elon knows that with Tesla, absolutely. That's why they started cranking out Model 3s like crazy, even when they were operating at a huge loss, right? Tesla was not profitable for a long time. Now, that ain't the case anymore, but do you think we'll measure rockets by tons per dollar instead of dollars per ton in our lifetime? Yeah, maybe. It's crazy that he got that access. Yeah, I don't know how he did that, but good for him. It was great insight. Really nice to hear. I really agree with Elon about a lot of things when it comes to rockets, when it comes to how rockets should fly and stuff. I really, I want to say that we're on the same page, but I know I'm just some moron that makes fake spaceships in KSP. I get it, but I really do think that the way he thinks about it is the right way to think about going into space. I know, Space Button, isn't it cool? Yeah, it's a memory. Yeah, maybe. Yeah, Cirrus, I really like the way he goes about thinking about engineering. It's not, you're constraining yourself when you try to work like how NASA does. And that explains why we've made only expendable launch vehicles and a partially reusable launch vehicle. Because we're like, no, you can't question. No, reusability doesn't make sense. It doesn't make sense. And no, you can't make a reusable launch vehicle. We not contrived, but a very constricted way of thinking got us to this point. And yeah, this is like getting back to the big crazy ideas like that we saw during the 60s. And in that regard, Elon thinks like an engineer from 50 years ago, which is kind of crazy. I love how the bits about how he got stuck optimizing the thing that shouldn't even exist in the first place. Nuts, dude. Yeah, crazy. Yeah, it's awesome. I was so cool hearing him talk, dude. It was a freaking treat. Freaking treat. Make sure you guys go over there and support Timmy, too. Everyday Astronaut. I really love where his mind's at, dude. How he's going about solving these problems. I get it. The way this looks is like if you put a bunch of thuds at the bottom of a 5-meter fuel tank in KSP. Yeah, right? Yeah, I know. Yeah, we got 2 other parts coming. Mm-hmm. Did I get your news links? Yep. Well, the Lucy one we covered yesterday, so I don't need that one. I got the one from Christian. Okay, got a Resevo. Okay. We got Rocket Labs Tour. Yep. I mean, this is what we're watching right now, though. I know, Joe. Pretty crazy, huh? The booster swaying back and forth makes you nervous. It's fine. They got it on wires. It's all good. You want a little bit of sway, guys. If it's not swaying, then that means physics isn't working. Yeah, you need a little bit of sway is no problem. It's okay. $200 tons just dangling there, more or less. Any idea on how much that all weighs? It's under 200 from what I understand. That's what Elon was saying in that Timmy interview yesterday. What do you think about the center engines being lower? Aerospike. That's what I think about it, GravShark. Falcon 9 does the same thing. You're getting a slight aerospike effect by having the middle engines a little bit lower. Are you going to model the booster too? Yeah, of course. Sounded more like the target was under 200 tons. Well, let's just say 200 tons in change, human. It's not really pertinent. We're not engineering anything. We're just making estimations. We'll say 200 tons and we'll call it a day. Or we will also accept very frigging heavy as an acceptable answer. 200 tons in chains or extremely freaking heavy. Yeah, that works too. What are the dark things that are stuck to the side? Those are composite overwrap pressure vessels. I'm not sure why they're there, to be honest with you. I'm thinking they're there in lieu of autogenous pressurization, but I could be wrong. How many engines do you think are fully installed? It's got 29 engines on it, Balxy. 29 engines. That's got all the engines. Now, whether they all work, I have no idea. I'm starting to think that this stacking, this huge, let's get the thing stacked by August 5th, or let's get the thing built by August 5th, is not it getting ready for launch by August 5th, but them having full stack capability so they could put the whole thing together. I think that's what it is. And in that regard, some of these engines might be inoperable or untested. And they're most likely using them for fitment. They're doing fit checks. So I don't know if all those Raptors are hooked up. I don't know if they all work. They might. Maybe we know at least 9 of them are because they said they wanted to use 9 of them, right? The exposed engines just look wrong. It's, Ian, it's certainly something. It reminds me a lot of Neptune, to be honest with you. I had this thing with Neptune, do you remember? The shuttle engines were hanging off the side because I couldn't fit that many underneath. And Neptune also had lower center engines, like 4 years ago. Neptune looked exactly like that. And then I had fixed grid fins and no landing legs with Neptune also. Man, what the hell? Wait a minute. Wait a minute. Elon, what? Hey, that's my idea. You dick. No, when BFR was first released, for the newer viewers, when SpaceX first came out with the big freaking rocket or Big Falcon rocket, I tried to make a scale replica of it in KSP. So the BFR was originally supposed to be 12 meters. So in KSP, I made a 9-meter core rocket with shuttle engines on the bottom that looked like that. And I couldn't make landing legs that were strong enough to hold the thing up. So I just said no landing legs. And I just landed it on the hold down points, believe it or not. I landed it on its hold down points. And we couldn't make a grid fin that folded down because it kept breaking. So I just made the grid fins fixed. I made them just able to do this and that's it. which is very interesting. I did that in like 2017. I could show you guys the craft files if you want, and I'll show you the date on the craft files too. It is moving. It ended up looking exactly like this, which is strange. I had my engines hanging off the side because I couldn't fit enough engines under... Holy crap. So when I say, oh, it looks just like Neptune, it looks like the rocket that I made in Kerbal, because Kerbal's scale is 66% of real life, give or take. That's the running thing, and I have that right from the developers. So something that's like 1 meter tall would be 660 millimeters in Kerbal, right? So I wanted to make a scale version of BFR. BFR was 12, so I made it 9 to 8, which is not, that's actually not exactly scale, but it's close enough. And then SpaceX scaled down BFR in 2017 to a 9 meter core diameter, so it ended up being about the same size. You still have any doubt Elon watches the stream? I don't know, man. Maybe he does, maybe he doesn't. I don't think he does. I seriously don't. I don't think he has the time for that. Kerbin the Planet is 10.625 smaller, though, so different scaling. That's right from the developers, GrabShark. That's the parts. The parts are scaled. Yeah, the planet's obviously different, right? But in terms of part scaling, it's 66. Or actually, it's closer to like 62? Something like that. I think it's taller than Neptune. I forget how tall Neptune was. I'd have to go and look. Yeah, OX, right? Yeah, maybe Endo. There's many reasons to believe he does watch this. Oh my gosh. I don't know, man. I don't want to... Louis, I've said this once, I'll say it again. I don't even want to entertain that idea. Midge-sama! What's up? Physics. Tabamari, I think that's much more likely what's happening. Yeah. Yeah, I tried making landing legs for a rocket that big. It didn't work. And clearly SpaceX is kind of on the same page there. Looks like some engines are unfired. They have white nozzles inside. Yeah. Ian, and once again, it was the same thing with Starship. Starship had like a white liner on the inside of the nozzles, and I don't know if that's, oh my god. I don't know if that's something left over from the manufacturing process or what, or if it hasn't been fired. It might be that. Or if they're going with some kind of coating or whatever. That's what I guessed on Twitter, but it's much more likely to be a fit check. From where to where are they lifting? They're taking that thing and they're putting it on this thing. 29 engines, guys. There's 9 on the inner ring. So, well, 8. There's 1 in the center, fellas. 1 in the center, 8 on the inner ring, 20 on the outer ring. Each one of those engines produces somewhere in the ballpark of, what would you guys think? Like, it's probably like 2,000 kilonewtons at this point. Oh my gosh. Yeah, it's Kato, Baz. It's crane-assisted takeoff. I don't know, Crafter, maybe. No, it goes right here, on this big stool right here. This thing right here is the launch table. Oh my goodness. Does it count as a milk stool? I'll allow it. Wow. That's impressive, man. Hey, R2B2. Holy crap. You ever stared at it? Marveled at its beauty? Its genius? Did you know, chat, that the first Starship was designed to be a quite perfect launch vehicle? Totally stainless steel without pain and suffering. It was a disaster. Nobody would accept the rocket. Entire prototypes were lost. Which leads you to the booster that you see before you. Wow. Yeah, see over there? R2B2. And it has an R2D2 sticker on the side. See that? I don't know, DMAF. I don't know when they're going to static fire. I'll tell you this right now. The pad is nowhere near operational capability. And that's even taking into account SpaceX's quick speed. That thing's nowhere near being finished. Don't get me wrong. It's closer to... The rate that SpaceX has been going at is absurdly fast. They are going very, very quickly. But right, even then, like, even taking into account SpaceX's operational speed, it's still going to take another month. I'm guessing another month. There's so much left to do with the pad. Yeah. Yeah, look at so. They're literally all hooked up. I heard most, if not all, of the remaining parts and engines from version 1, version 2 will be new and improved. Ken confirmed. I don't know what version 1 and version 2 means, but yeah, I can't confirm it because I don't know what you're talking about. NSF reports that Super Heavy is close to 100 million. Oh boy. I mean, even 100 million for what you're getting here is insane. I mean, Super Heavy has pretty... Even if Super Heavy launched, like... Okay, I'm going to go out on a limb here, and this is just me kind of guessing, I guess. I'm pretty sure that thing, what you see on the screen there, could SSTO like 10 tons into orbit, no problem. Yeah, I'm pretty sure it could. I'll bet you if you put 10 tons of lead in a nose cone on top of Super Heavy and then launched it, it'll probably make it into space. Yeah, I'm pretty sure that has enough delta V to do that. Do you think all 29 engines are functional? Functional? Yes. Tested? No. See the nozzle discoloration on some of those things? Some of them aren't even tested. But SpaceX wanted to do fit checks, so they took engines that weren't tested, like RB19 right there. See how the nozzle's light? The nozzle's a lighter color. That means it hasn't been test fired. At least I think. I'm pretty sure that's what that means. Either that or it's some experimental kind of coating that they have in there or something. I don't know. So it's about as effective as your SSTO. Kappa. I don't know why you'd Kappa that, but sure. So what does need to be done on the pad? What does need to be done on that pad? I don't really have much of a clue what a launch pad needs to be operational. They want the capability to stack. My guess is that they want to stack a Starship on Super Heavy to make sure that their inner stages work correctly. If one engine fails, does it endanger the others? It's possible, Entity, yeah. Yeah, of course. I mean, but once again, you got to think about Starship and Super Heavy like an airplane. Do airplanes have engines next to each other? Sure. An A380, 747, and if one of the engines fails, could it wreck another engine? Yeah, sure, absolutely. But why does it not? Why does that not happen all the time? Well, it doesn't happen all the time because we have a lot of time messing with high bypass turbofans. The aim of what SpaceX is trying to do is have a lot of time with full flow stage combustion cycle engines to get them reliable to the point where, yeah, you could be pretty damn sure it's not going to break. So that explains the high engine cluster. On any other occasion, I'd be like, But once again, actually, if I was going to worry about anything, are they going to test fire it? Not today, Infected. No. I don't know if they're going to test fire this one. They might. But even if they did, it would be a little while because the pad isn't hooked up. None of the fuel lines are hooked up to the pad. But yeah, I would be more concerned with heat, to be honest with you. But either way, that's pretty damn cool to see. Even if it's just fit, if they're just doing a fit check, it's pretty ridiculous. What a shot from NSF. You guys gotta go over and support them, please. Like, we're getting spoiled by this, seriously. Yep, there's Booster 3 right here, which was a ground testing prototype, and then there's 4 right there, which 4 will fly. It's just not going to fly for a little bit. And keep in mind, if this was NASA or anybody else, when I say not going to fly for a little bit, I would mean like a couple of months, like 4, 5, 6, 7 months. Judging by, like, I follow this stuff every day. I look at the NSF footage all the time. Judging by the rate of iteration that SpaceX is working at, when I say that that's not going to fly in a little bit, I'm thinking like a month and a half, maybe 2 months. Not 7, not 8. Starship will fly. It will fly soon, but maybe the end of the summer, something like that. Falcon 9 has an octaweb that contains an engine, runs to a single engine, but how would S-Master, once again, you're thinking about that backwards. You're doing exactly what Elon said not to do in Tim's video. You're thinking about it backwards. If you make the engines reliable enough, then you don't have to worry about that problem. So make the engines reliable enough. Don't put all your eggs into doing defensive engineering like that. Once again, if you watch Tim Dodd's interview with Elon Musk, the first part, he talks about this. Don't constrain your method of thinking like that. That's a bad idea. So, in that regard, that explains why all those engines are so close together. Because if they make Raptor reliable enough that you never have to worry about it, then I don't think it's going to be a problem.
It's not going to be a problem.
You're not going to be a problem,
No,
got him.
you.
What's up, sweetie?
No, I just want...
You just want a hug? All right,
Yeah.
you get a hug.
Mwah. I also wanted to ask you if you could do the dishes tonight because I'm really tired.
Yeah, of course.
Thank you.
Don't worry about it. It's no problem.
I love you.
Love you
You're
too.
the best.
That's why I got a hug, isn't it?
No.
I love you. Can you do the dishes?
Maybe a little.
Who are you trying to fool, woman? Who are you trying to fool?
Not you, because you knew.
Of course I know. I know you, Norton. Yeah, I know, Grabshark. Can you believe that? You know what's funny? I do the same thing to her, but she doesn't realize it.
I don't?
Hey, can I buy another truck?
No.
You sure?
Yes.
Well, I'm gonna do it anyway.
Don't.
Why not?
Because.
But
No.
it's my money. I'll use it when I need it. See, that was my version of doing that. I'm just gonna buy another one anyway because I can. Hug her first, then she'll say yes. Nah, I just kind of do it. Yeah, just kind of do it. It's better to ask for forgiveness. That's my way of buttering it up.
Discovery, go at throttle up.
Watching dishes stream after space news? No, I'm good. Yeah, we're done. Exactly. Yeah, Zach, 37 months. Thank you. So, guys, what we're watching here is we're watching them do the first stacking attempt for booster number 4 for the first Super Heavy. This is SpaceX's Super Heavy booster, as it's kind of tentatively named. It's about 70 meters tall, 230, 220 feet, somewhere in there. Tall, about 9 meters wide, or about 30 feet wide. It's got 29 engines in the first stage, and they're moving it with a Liebherr what is this? A Lever 11350, super heavy lift crane with a power boom attachment. Booster weighs about, it's somewhere around 200 tons or very freaking heavy. And what SpaceX is trying to do is they're not going to fire it or anything anytime soon. What they're testing is how that thing bolts to the pad. SpaceX, for whatever reason, has deemed it a very important thing to figure out how to put this thing together. So, meaning booster on pad and then Starship on booster. So, I'm not exactly sure the reason why, but I would guess that it's preparations for putting together a stack for the first orbital flight test, which should happen a little later this year. Why didn't they round up to 30? There's not enough space. How's that pad supposed to divert the exhaust? If a rocket exhaust is high enough up in the air, Savage Duck, all you need is a pad deluge. And I think that's what they're trying to do, but I'm not 100% sure how you're going to deflect that much thrust, but who knows. Did we see any assembled tower crane parts yet, or just pieces? Just pieces. Crane operator has to be nervous? You're nervous. There's nothing to be nervous about. It's funny, because to do lifts with the crane, you have weather violations, just like a rocket. Can't be too windy. Wind is actually the big one. You don't want to get deflection with the crane, because that would be very bad. If the crane boom does this because it's too windy, or if it sways too much, there are wind conditions, all kinds of preparations, tensioning cables when you go to do the lift operation and then lift. Make sure the cables get fully tensioned so that the cables aren't going through transient load. There's a bunch of physics involved, but I don't think the crane operator has really much to worry about. The reason why he doesn't have much to worry about is because if something goes wrong here, at this point, it's because physics stopped working. Seriously, physics doesn't change. The laws of physics are pretty easy. And the crane's working well within the confines of physics here, and as long as it's not too windy, it should be just fine. Everything should work correctly. Or he was an idiot. Yeah, I mean, could be that, but I don't think they'd put anybody in the house there, goalie. What are they going to use as a test payload? Elon said on Twitter 2 days ago that they're going to use a wheel of cheese. Crazy stat, only a year ago we were launching SN5. Yeah, Just Space. Imagine where we're going to be in another year. Okay. Entity, a little more of a detailed response there. SpaceX is going to put Booster 4 on the pad here, and then they're going to put Starship serial number 20 on top of that. Now, this is the stack configuration with 4 and 20. No, that's not a coincidence. I'm pretty sure Elon changed the naming convention on the boosters so it was Ship 20 and Booster 4. Yes, I know, it's the number. Ferd. No, junk. Ferd. So I don't think they're going to launch it with any payload. I think that SN20 is going to have an empty payload bay. Now, why? Why is that? Well, the reason why I think it's going to have an empty payload bay is because from what I understand, and this is from an FCC filing that SpaceX filed for this orbital launch test. SpaceX in the FCC filing, which is basically the papers saying what antennas and what frequencies you'll be using for the flight test. That FCC filing showed that SpaceX is really looking to test the thermal protection systems on Starship. This whole orbital test is basically a heat shield test, akin to NASA's Exploration Flight Test 1 in 2014 that launched an Orion capsule on a Delta IV Heavy. That Orion capsule was a dud. It was a dud. There's no like seats inside or anything. That Orion capsule was a mass simulator with a real heat shield, and that's what they were using. That's what they were doing during EFT1. They were testing the heat shield, because I have this theory about how you design rockets, especially rockets that are reusable. If you're going to design a reusable rocket, the first thing that you should work on is not the first stage. The first thing that you should work on is the capsule, or the part that comes back. which is why works with SpaceX, because we saw them doing Starship landings, right? The shuttle program was the same way. One of the first flight tests for the shuttle was them launching Enterprise off the back of a 747 to make sure that the shuttle could land, right? So you go backwards in that regard. So SpaceX already knows that a Starship can land by doing that flip and burn maneuver. What's the next thing? The next thing is the thermal protection system. So if you're going to do a thermal protection system test, Starship will likely launch with payload, right? It'll launch with payload. It deploys the payload, and then it comes back down with an empty payload bay, presumably, right? So, I don't think there's going to be anything inside a Starship but a freaking wheel of cheese for this flight test. Because the test is primarily to test out the thermal protection system. And Starship will primarily be coming back down with no payload, at least initially, right? You want to get a good baseline. So, once again, this is all pertaining off of an FCC paper an FCC filing from SpaceX that said they wanted to test the thermal protection systems, which makes sense. They're going backwards. That's what you do when you make a reusable vehicle. You go backwards. You work on the landing first, and then you work on EDL, and then you work on on-orbit operations, and then you work on full fidelity launches. Why cheese? Because Monty Python. That's not a joke. Yeah, Forge, you have the PDF in chat. Mm-hmm. I don't know, Jack. A big one. Maybe, Laws. It could be an internal test. The Wheel of Cheese is a nice callback to the... Yeah, COTS 1. Yeah, SpaceX's first payload ever launched into space on a Falcon 9 was a Wheel of Cheese. Imagine being under that monstrosity. Yeah, Julid... I wouldn't stand under it. I'd stand next to it, though. Don't ever stand under something that's under load. Ever. Bad idea. It doesn't matter if it's like a car up on a lift without the locks in, or like a crane that's holding a payload. Don't ever stand under it. It's just a good rule of thumb. I wouldn't want to go under that thing when it's under tension cables, like hanging from the crane. I would not. I would go to the side, but not under it. Lols, yeah. Can you imagine? Just make the crane so reliable. Yeah. No, they already did that. It's a Leaper crane. Of course it's reliable. But I still wouldn't stand underneath that thing. You could call me superstitious. That thing weighs over 200 tons. If it falls, they're going to pick you up with a sponge. Yeah. No, I don't need to be under that. Yeah, no. Hype, I'm thinking another month, but I don't know for sure. Month and a half, maybe the end of September. Sometime in September is what I'm gauging right now. That's just my personal estimate. But I've been following this since SpaceX started building... I've been following Starship basically since the beginning. And I've been following SpaceX and Falcon 9 for the better part of a decade. So I'd like to think that I kind of understand the cadence. So I'm going to say a month at the very least. So like no earlier than like the 1st of September. Hey, Enroy, 63-month resub. Raptors. Nah, maybe a shovel. Yeah, right. That's why they're wearing helmets. Yep. Dragging the booster with a rope. Hey, it works. That's how they do it. How do you think the crane's precision place stuff? It isn't the crane operator, dudes. He's talking to these... Goalie, what's the name of these guys? The cablemen. No, the cableman isn't right. Those guys are just basically pulling it to counteract the wind. And there's a guy up there with a CB that's talking to the crane operator. Cable guy! How does this thing land? The launch pad will catch it. Short bus, at least that's their plan. There's going to be a giant grabber arm on this truss structure up here, and it'll literally grab the thing. I'm not making that up. Here, check this out. So there's a Twitter user called ErkX, right? And ErkX showed a render animation, and this is... Check that out. That's the plan. It's going to grab the thing right out of the sky. No landing legs. Landing legs is just extra parts that you don't need. It'd be better to put your landing legs on the pad so the rocket's more efficient, so it's lighter, right? It's not lighter, it's less mass. And before you say, oh, EJ, that's just some fan render. So there's that. I mean, that's the guy himself. If he says it's real, I'm very close to real. Yeah, if he says that's very close to real, I'm gonna show people this and say that's how they're gonna catch it. Assuming Starship doesn't completely replace Falcon 9, could they do something like this out at the Cape for RTLS stuff? No, Falcon 9 will never land like this, Dino. No way. Won't they want legs for landing off-world? Well, sorry, that was the freaking Cyberpunk soundtrack that he put to it. My bad. With this thing, that's just the first stage for Earth. Starship will have landing legs on it. Sorry about the ear rape. My bad. Dude, it's Windows. Every time... So I shut my computers off every night because I don't need my electric bill being ridiculous amounts of money. So every time I turn it on, Windows just likes to change my sound settings for me. Oh, hey, you had your volume setting at 10? Here, let me put it to 100. I'm being helpful. No, Bill Gates, you are not. Stop doing that. Don't do that again. But, yep, it's cranked. Yep. Nice. Overdriven audio. Lovely. What? I can't hear you. Wait, what? What? Bill, stop! Sorry about that. Are you awake yet? No, Draco. Different bill. But yeah, this thing right here is not supposed to land on other planets. That's just supposed to get Starship up into space. Starship is the one that's going to have landing legs on it. He said he's selling chocolate. Chocolate? Do we know what kind of hold down system they have? So, see these little recessed pieces right there at the very bottom? Those are the hold down points. And the hold down points are on a pivoting arm. And see, this is where having a 3D model of this would be super freaking useful. So the hold down points pivot inward. So there's a ring, right? And they pivot inward like this. And then at the top of the hold down point is kind of a C-clamp almost that does this. And the C-clamp reaches into that recessed area and clamps super heavy down. I think that there's 20. And it looks like the hold down point shares a common flange or a common mounting piece with the engines, from what I can tell. Because it looks like the engines are mounted right where these recessed pieces are. So it looks like when the engines fire, the hold down points are attached to the same spot. Which is, I mean, because the engine is mounted there, it's going to be a structurally stable spot. So that makes sense. I mean, Falcon 9 does the same thing. Falcon 9's hold down points are on the thrust structure, very similar to this. It's similar idea, but the architecture is different. One's a contemporary house, the other one is a brick house. You know what I mean? Like, but there's like a little C-clamp that reaches up and in. So like if this is the bottom of Starship, right, and the engine is mounted right here, there's a little part right here where it reaches up and over and holds it to the pad, and then it'll release. Super Heavy will leave, and then that folds into these areas down here. Hold downs are between the Raptors per the transport stand. Yep. They're between the Raptors? I'm pretty sure they're right there. That's the hold down clamp. Unless they're holding down right here. But I mean, if the transport rig was doing that, then yeah, maybe. Yeah, they're actually moving the booster. Yeah. It's not going to cost much to move it. It doesn't take much force to move the thing back and forth. Most of the force is on the vertical axis here, and it's on the crane. The crane is holding it up. But if the crane is holding it up, it should be really easy to just move around. The transport stand clamps to the flanges between the Raptors. Okay. Is that the camera shaking or the booster? I think that was just the camera blowing in the wind. Because it did that for a second. I'm like, What are the black bottles for? So, you're correct to call them bottles, floating disc. Those are composite overwrap pressure vessels. So what's a COPV? COPV for short. What is that? They're designed for holding gases at very, 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 very high pressure. Or liquids. I mean, you could put liquids in there too. Basically, picture like a scuba tank. Like a scuba tank bottle, right? Just wrap that in carbon fiber so it's really, really freaking strong. So you can store a lot in a very little area. Rockets, all types of rockets use COPVs. Overwrap pressure vessels are actually something that the space shuttle, the space shuttle was the first thing to implement COPVs because they had weight problems because the shuttle had a fat butt. Shuttle was thick. So they had to find ways to shave mass off of it. And just using a straight aluminum pressure vessel doesn't work. But aluminum wrapped in carbon fiber really, really, really makes it light. Tank is very, very strong and it's very, very light. And the industry term for it is a bottle. Those are COPV bottles. And I say bottles, but literally it's like twice the size of a person. But yeah, in terms of what they're carrying, I have no freaking clue. It does not seem like Booster 4 has its autogenous pressurization system hooked in, so I'm going to guess that these bottles are probably for tank pressurization, for tank gullage. Because see these pipes right here? These pipes are... So these two Raptors are going to that pipe, and those two Raptors are going to this pipe. And what these pipes do is what's called autogenous pressurization. What does that mean? Basically, some of the liquid methane that goes into Raptor and some of the liquid oxygen that goes into these Raptor engines gets turned to gaseous oxygen and gaseous methane. The motors do that on purpose. It's kind of a byproduct of a staged combustion cycle. It's called a tap-off, right? And those pressure lines feed into these tubes right here. Now, one of these could be to methane, or that one could be gaseous methane, and that one could be gaseous oxygen. I'm not exactly sure how this is all hooked up. Actually, these are probably the methane lines because the oxygen lines probably go into the LOX tank, which is right there. So basically what Raptor does is as it's going up into space on super heavy, it's draining the fuel out of the tanks, right? And you need to keep the pressure in the tank high so it feeds the propellant correctly. I mean, that's pretty reasonable thing to understand. The ambient pressure is really low. You got a vacuum outside. So if there's a vacuum, and you expose the tank to vacuum with a vent line, it's going to suck the propellants out the side. You don't want to do that. You want the propellants going into the Raptor engines. So the Raptor engines take some of the liquid methane and some of the liquid oxygen, and it goes back in and it repressurizes the tanks with some of the gases that are coming from these engines. That's called autogenous pressurization. Now, it's very clear that the autogenous pressurization on Booster 4 is not hooked up because those are the repress lines. There's a completed one somewhere on the side here. I think it's on the other side. And maybe it was on Booster 3. And we traced where these lines went, and they went to the top of the methane tank, which makes perfect sense to me. A vent line goes into the top of a methane tank. The liquid fuel goes down, gas goes up, right? So if you want to fill up an engine, you're filling it up from the bottom. You're not pouring liquid into it, so to speak, right? So there's a gas vent up top and a liquid vent down the bottom. And these go right to the top of the tank. They go up here, and they connect into two lines up there. And then there's a hole. You can see it right there where the lines go through. Actually, that could be a vent line, but I'm not sure. Where the lines go through, and they go into the top of the methane tank up here. So... Now, that's what it should do. That's obviously not hooked up here. I think the COPVs are there for helium or nitrogen. It could be either one to keep the tanks at pressure because the autogenous system is not finished yet. They haven't finished designing it. I think. I'm not sure. I'm pretty sure that's what's going on,
Going
but
throttle up.
I could be incorrect in that regard. Also, we completely misunderstood the hot gas thrusters, but Elon said that they would get 300 specific impulse. I don't know how just pressure can achieve it. Have you ever blown your keyboard off with compressed air? Same thing. I mean, I didn't misunderstand the hot gas thrusters, Balxy. That same autogenous system is basically going to be feeding the tanks, and then the hot gas thrusters pick up off the tank pressure. Pretty straightforward stuff. Like, is there something that I said incorrectly that's not like that? I'm pretty sure I remembered explaining it that way, but I could be wrong. I don't know. Hey, Katsumi, 2-month resub. Those guidelines look like KSP struts, yeah, right? But 300 specific impulse? That is unlikely without combustion. Well, he said that impulse is basically determinate by pressure. So if your tanks are at high pressure, and I would assume that, I mean, these tanks are at 6-7 bar, so he said 6 bar for internal tank pressure with Tim's interview, so that's 606 kilopascals. That's really high pressure for tanks. With that higher pressure, you can get higher specific impulse with a hot gas thruster like that. Drone. Guys, that was just a bird, okay? It's just a bird. Birds are drones. Den, when's it scheduled to launch? A couple of months, maybe a month, something like that. They're nowhere near ready to launch it. This is just a fit check to make sure that the booster can bolt to the pad correctly. Birds aren't real. Biodrone. Yes, Kuro. How well do you think the exposed Raptor plumbing will handle suborbital reentry? Well, I was talking with a viewer a little while ago about heat. Guys, I'll be honest with you, this thing's probably going to experience the same amount of heat on the way up as it is on the way down. Why? Because, and this is something that Kerbal does not really model at all if you're a Kerbal player. When in Kerbal, you could just cluster engines. It's really not a big deal. In real life, that's hard to do. The reason why is because, well, engines radiate heat, especially down here in the atmosphere. There's air in here. And the air on the way up is usually at extremely low pressure because there's a vacuum going on here. Because all the rockets are shooting gas out fast and the rocket's going up and all the air is just basically passing through. This cavity right here is very low pressure. If it's very low pressure, it's not going to take much to heat that air up. So the engines end up transferring heat to each other. Yeah, that's absolutely a thing. Engines can melt each other from the outside. Yeah, the rocket engine will melt. The heat coming off one rocket engine will melt the outside of another engine and vice versa. So, my guess is, and this is just a guess, once again, big guess, don't know. My guess is that if the engines can be that tightly packed to each other and they can fire on the way up, then I don't think that heating is going to be a problem on the way down. Honestly, the rocket engines and re-entry heat, especially with something like Raptor, should be about the same temperature. It's going to get hot right in this area here. Right here is going to get very, very warm. Not here or here so much, but right here when the rocket goes off, it's going to get real hot. And you do have to worry about radiating heat. This is why the shuttle engines are kind of spaced apart, right? And why SLS's engines are spaced apart as well. Delta 4 Heavy, it has those 3R68s. They're far apart from each other on purpose. Could you cook a hot dog with the heat? Yeah, you'd need to probably like Geeson. You could cook it in like maybe a second. So like the rocket engines turn on, you put your hot dog next to it, provided you don't die from the sound because rocket engines are loud and the sounds can scramble you, like scrambled eggs. Yeah. Not good. Don't stand next to it when it goes off. Good pro tip for the day. Yeah, I'd cook a hot dog in like a couple seconds. Yeah, get a nice good steamed dog right there. So do you think all 29 engines will be working correctly to land? No, just the center engines, Dak. You don't need all those engines to land it. All those engines are needed to push a fully fueled Starship with 100 tons of payload up. To land the booster, the mass of the booster is like maybe one. I don't know. I don't even know. What do you guys think? Like 1/36th of the mass that it was taking off. You don't need a heck. It might be able to do it on one engine. One Raptor could probably move this thing with almost no fuel in it when you're running on fumes, so to speak. But I think they're going to land with the center cluster. It's crazy. Another way that I know is that the center engines are the only ones that gimbal. These engines on the outside that say RB with the RB designation do not gimbal. They're bolted right to super heavy. They are bolted right to it. They do not move. All they do is make flamey bits come out the bottom. All they do is just generate thrust. They have a fixed mount. The engines in the center are gimbaled. That's because you don't need a lot of gimbal to keep a rocket on an even keel. Hey, through the tape measure. What engine performance-wise to Raptor and Raptor Vac compared to? Raptor, I think target was 2,300 kilonewtons, RJ. But I want it now. Yeah, I know what you mean. Yeah, Zany, I know. This looks like something out of a sci-fi or whatever, dude. I still, every day when I wake up and look at new pictures of Starship, because I do that every day. I mean, I do that with SLS too, to be honest with you. But SLS is a lot more believable than this thing, you know? And that's not a knock on SpaceX by any means. I am not knocking SpaceX. I love it. I think reusable spacecraft is the way to go. Expending spacecraft is dumb, but I understand why NASA does it. I get it. The way they conduct their engineering and the way they do their mission profiles, expendable rockets make total sense if you're going to the moon, right? With that being said, I think this way is the right way to do it. But I like all rockets, to be honest with you. But this thing seems like something out of a movie, dude. Like, I wonder what the internal failure percentage guess on the first orbital attempt is. That thing is just so experimental, it's awesome. I don't know. It's probably pretty low. Is that thing spinning? Yeah, the guys are pulling on its zivs to get it aligned so they can move it into position. Yeah, there's Raptor Center boosters, which has an RC designation. Those are the ones that have the gimbal actuation, so they can vector their thrust in different directions. And then there's RB, which is Raptor Booster, which has a fixed gimbal. That's what these things are on the outside. And then there's Raptor Vacuum. So there's RVAC, RB, and RC. And then SpaceX, on top of all that, if that didn't get complicated enough, they're going to roll out with a Block 2 version of Raptor soon. They're already on Block 2. Okay. Are all the guys, everyone here is a SpaceX employee, cooking fat, or a contractor? I'm guessing the guy in the high-vis yellow is probably a contractor. He's a crane operator, I'm pretty sure. Crane operators always wear high-vis like that. See the guy with the yellow shirt? That guy's probably a contractor. Everybody else there is probably SpaceX. So looking at some stuff, I found out that the exact dollar amount for the Europa Clipper mission is $178,322,196. Yeah, for the launch, Thomas, for the launch. But yeah. EJ, are we not worried about another N1 sort of issue? 29 engines is a lot. I mean, SpaceX demonstrated 27 with Falcon Heavy, Zany. If anything, SpaceX is the one that has experience with clustering engines together like that and actually having it work. But with that being said, there's always stuff to deal with. Yeah, I'm sure Super Heavy has its... Dude, guys, one does not simply put 29 engines together and make it fly. There is probably engineering challenges with that thing that we will never hear about that are insanely complicated problems to solve. But SpaceX, I mean, once again, they're, you know, I don't mean to keep referencing it, but Everyday Astronaut's interview with Elon is very telling. Do not constrict yourself to one way of logically thinking. There's 1,000 different ways to solve a problem. Find the best way to do it. Not the first way. Keep refining, keep going, and then then execute from there. That's really smart. It's really freaking smart, man. That's such a good way to think about things. Yeah, maybe. Yeah, Sevi, that makes sense. Yeah, pretty much, Kaz. It's a very Edison or Henry Ford way of thinking, which is interesting. Dude, Kaz, I always say, and I've been saying this for years, man, that Elon Musk is just... He's just looked at Henry Ford's playbook and just kind of did that with electric cars. Straight up. And you know what's funny? Henry Ford got a lot of crap from everyone when he rolled out with the Model T. When he started mass producing it. Oh, you'll never get a return on investment on that. You'll never get it. Why do I need that? I have a horse. Why do I need a car? I have a horse already. I don't need that. You're never going to get... Oh, yeah. Oh, yeah. Okay. Sure. And you know what? It's funny because he said, fine. Yeah, sure. You have your horse. That's great. And then 20 years later, everyone has an automobile. Yeah. Interesting, right? Can you explain how SpaceX or NASA test vacuum engines? Yeah, sure, Apocalypsis. No problem. So, you have a vacuum testing chamber. So, a regular testing chamber for a rocket engine is a stand with a flame deflector, right? And then you have your rocket engine there, right? And then it's mounted here. And then you have your 2 fuel tanks, right? Yeah, I know. Great drawing, right? And then the rocket engine fires and... That's a regular rocket test stand. A vacuum test stand looks something like this. Similar concept. You have your stand, right? And then you have a flame deflector. But the flame deflector is in a tube. The flame deflector is a pipe that goes over here and comes out over there. I mean, this is a very, very crude drawing. Just bear with me. So your rocket engine is mounted there, like that. And here's the thing. The tube just keeps going. And then the rocket engine is on like a stator mount almost. Right? The rocket engine's mounted like that, and then the pipes are on the sides, and your fuel tanks are over here. And this pipe just keeps going. And then at the very top, it does this. And then there's an intake up here, like an intake on a jet engine. Anybody know what that is? Yeah, see, this is the internet right here. It's a series of tubes. That's a Venturi. That's right. When the rocket engine fires, right, it's going to start sucking the air down. And air is going to start getting sucked into the intake, right? And it's going to get impinged here, and then it's going to depressurize. And in here is going to be a vacuum, just like a carburetor. It's a big freaking carburetor with a rocket engine being your carburetor jet. That's how they test in the vacuum down here. Don't get me wrong, NASA does that. Most rocket developers that test upper stage engines, so Rocket Lab, SpaceX, Firefly, Relativity, they literally just take the vacuum nozzle off and just fire it with no nozzle. That's how they test down here. But NASA does have a vacuum testing chamber like that. Basically, it's a big frigging carburetor. And instead of the carburetor spraying fuel, right, the rocket engine fires and it sucks the air in and creates a vacuum. Yeah, that's how they do it. You want to see? I'll show you what the vacuum chamber looks like here. The A3 test stand at Stennis, even though it's not being used, is literally that. If you look, trying to find a good picture of the top of it. See? Big freaking Venturi up at the top. It's... I mean, they do have heat exchangers and condensers, etc., 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 but see the intake pipes up there at the top? That's what it's there for. And there's your fuel tanks stacked on top of each other. There's your intake pipes, and then the exhaust comes out here. They actually throw the exhaust through a heat exchanger. That's what this thing is right here, just to make sure that flames aren't coming out here. But, yeah, pretty straightforward stuff, dude. It's a water slide. Yeah, right? high-res image. So Jack Beyer over for NASA Spaceflight has a really nice picture here. Oh my goodness. Oh, mama. Okay. Yes, Zany, that's correct. Actually, no, they use the SRB test stand for that. Yeah, you know, NASA wants to get the Earth to spin more. They just fire that thing, and it, yeah, see what I'm talking about? Yeah, that's how they do it. That's not how they do that at all. But if anything, R2B2 is on there, Phil. Yeah, it's there. If anything, you know, I mean that one probably does it. Yeah, see, R2B2. See, this is a bunch of Raptor nozzles, or it's the internet, because it's a series of tubes. Yeah, you can see that some of these engines haven't even been fired. They came straight from the factory. See how some of them are charred on the inside, and then see the staining right there? See the staining on the inside? That's they put something in, they spray something inside of the nozzle after it's been test fired. I think it's to keep moisture out, but I can't remember for sure. It's some kind of safing agent or something. RB21 spray painted on the side. Nice cyberpunk. There's R2B2. The ring of 8 are gimbaled into the center. Yeah. Yeah, I see it. I can't even imagine the sound those engines are going to put out. Yes. Man, Raptors seriously got some upgrades, man. I don't ever remember these things being on there. They had like a plate that was right here that had a bunch of electronics on it, but I don't remember all this. They literally installed 29 Raptors on this thing in one night. I just installed 29 Raptors for you in one night. I'm a little tired, I'm a little wired, and I think I deserve some appreciation. So this thing with my brother's over. Over. Done. Sorry, I'm sorry. I won't do that again. I mean, I will. I'm not going to lie to you, but not right now, at least. You're in my garage. I just bought this new Raptor engine here. It's fun to fly up into space and back, but I got this new Lamborghini, this new Raptor engine here. My plumber could do it in 6 hours. Yeah, right. Would take some work to make a Raptor in Maya, so much detail. I could do it. Euler, I could make that, sure. No problem. It'd take some time, but it's tedium. Modeling is... The thing about 3D modeling, dude, is it's like a craft, dude. It's like welding, or a trade skill. Plumbing, electrician, that's what modeling is like. And I've done both of those. I've done those things before. I haven't been a plumber, but I've done plumbing before. My cousin's a freaking plumber. Yeah, dude, look at my cousin. He's broke, don't do nothing. And then I have another buddy that's an electrician, another guy that's an HVAC. It's trades, man. It just takes time. But if you sit there and you're patient with it, you'll make something insane. I mean, look at what I did today in modeling when we were messing with Maya. I made a couple of pipes, but I took my time with them, and look at how good they came out. Modeling, you did that? Yeah. Yeah, I'm a runway model. You see, here's my Zoolander face. I feel it really captured my good side. What is this? A rocket for ants? Now turn left. The rocket needs to be at least 3 times as big. You're absolutely right. Here, I'll show you. Whoop. So I started working on the thrust puck for Starship right there. That's where the plumbing splits to 3 Raptor engines in the center. All we did was work on some of the LOX pipes, but I took my time with them, and they came out really good. The reason why that's like that is because it's supposed to do that. See? I was using a Boolean cut for the 3D modelers. And then I just used a cut tool and kind of went from there. See? That's pretty neat. And then there's going to be 3 of them. There's going to be one there, and one there on this puck piece. And then I have the bulkhead pieces there, and then the rings, and then the nose cone. And then I started just putting stuff together for Starship and Super Heavy. And then maybe we'll make the Raptor sometime or something. I don't know. You also have to worry about poly count when making 3D models. It depends, Synerd. Poly count really comes into play when you're making video games. That really is where it comes into play. If you're doing film, it still comes into play a little bit. Not as much nowadays. You really won't. But model resolution and topography is really dependent on what you're modeling for. That's very important to understand. Needs grid fins, yeah. Blue Steel, Ferrari, Laticra, they're the same thing! You pretty much have a 360-degree view of the engine with that last image you looked at. Yeah, you're not wrong. Here, let's see. Have they lowered it down yet? Yeah, but yeah, that's what I was working on before we turned on Space News here. But Synerd, I mean, yeah, it really depends on what you're doing. With film, you're usually awarded more poly count because render time is... You're not rendering in real time, right? Because it's not a video game. With video games, oh yeah, you absolutely have to be careful. You have to do the most with the least amount of topography. Yeah, least amount of polys to make the most high-res thing. Hard thing to balance. It's like Delta V. It's like the Delta V formula with rockets. You know, you have to make... If you want to make a bigger rocket, you have to find a way to make that rocket as little rocket as possible. Yeah. Yes. That was not a misspeak. I always say, and once again, I said it again, but I'll say it again now. If you really want to understand how rockets work, what is that? Is that guy smoking? Oh no, he's vaping. Huh. I guess that's all right. The less rocket that you have on your rocket and the more fuel you have on your rocket, the further your rocket's going to go. Simple as that. All I meant is that unless you're using a CAD program, you're going to have to trade model detail for UV map detail. I mean, with a good enough UV map, you can make something triangular look round-ish. I mean, UVs are, yeah, I mean, UVs are entirely dependent on your poly count, though. Every poly has a UV, so less polys is less UVs. But yeah, I understand what you're saying. You're right. You're correct. But it does. What I'm trying, Steiner, what I'm pushing back to you is saying that it depends. It really depends on what you're doing. It's application based. So like CAD, it really doesn't matter. CAD, that means nothing. And that's why CAD, you're much more likely to use what's called surface modeling. CAD systems are based in a type of 3D modeling called surface modeling. That's really, really important to understand. And video games are using polygons, and nowadays they're using polys, tris, and subdivisions. Subdivisions use a similar type of thing as surface modeling, but a little bit different. Yep, they're lowering it down. Normal mapping detail. Yeah, I mean, there's normal mapping and, you know, bump mapping is 2D. Normal mapping can get into 3D stuff too, and that's where stuff like ZBrush comes into play. Very cool, actually. Just let me walk my dog here. Yeah, right. Texture painting is key. That's right. Yep. And that's why 3D modeling is such a challenge, dude, because you have to use the lowest amount of polygons. And you can't make your textures high. I mean, you could do a higher res textures nowadays, but how we did it when I was back in school is that you'd use a higher res texture with a lower poly count. And the higher res texture would still take more time, but if you could paint a better texture, it always looked a lot nicer. Man, look at that thing. That is ridiculous, dude. Normal mapping is what I was talking about, not UV mapping. I got my terms confused. Yeah, okay. Yep. Yeah, this is that Jack's picture of the engine section. Booster 4 is in the air. Surreal is the only way to put it. Let's see. That's insane. See the lines right there? There's the autogenous pressurization lines. You see, that is going to split into two, and it's going to come down here and connect into these pipes. It's not hooked up, which is why I think those COPVs are there. We were talking about that a little earlier. Right? Jazos, it's amazing, dude. If this one is going to land... Is this one going to land? It's going to land in the water. Yeah, the Booster 4 will be expended on the flight test, on the Starship TPS flight test. If you're wondering how it's going to land, here. Let's make sure we don't overdrive the Cyberpunk this time around. Here, ready? That is how it's going to land. Not 4. 4 is going to get expended, but that's how they want to do it. And this is a render coming from ERCX, or ERCX, on Twitter. And, you know, people are going to say, oh, isn't that just a fan render? Well, look down here. It rests on the grid fins. Correct. They're going to catch it. Elon has said they're going to catch it like the Karate Kid catching a fly with chopsticks. Yeah, that was his reference, not mine. Yeah, they're going to catch the thing. It's actually a pretty smart idea, guys. The reason why it's pretty dang smart is because, well, if you don't have landing legs on this, less rocket on your rocket, right? That means this thing, which already has crazy amounts of thrust to begin with, you saw those engines, right? That's just less mass that it needs to move up to come back down and land. Basically, put the landing legs somewhere else. They put the landing legs on the pad. Because with that type of optimization means that you don't need to worry about, I mean, like extra mass on the way up. Your booster, your first stage is more efficient that way. Less rocket on your rocket, more fuel that you can put on your rocket. So they literally outsource the landing leg to the launch pad. Pretty smart. Yeah, I know, Southern. It's going to be insane. It's going to be ridiculous when it does that. It's going to be absolutely absurd. Dude, I am going to blow a gasket when this thing, if this ever happens in real life. Now, once again, that is a very difficult problem to solve right there. Getting that thing to do that is very difficult. It's not impossible. It's not impossible. It's just nobody's ever gotten a rocket to precision land like this before. What's the ETA to get to that point? End of the year, Den? Seriously, they're building this thing. They're building this thing right over there, right next to where this booster is being picked up. It's right next to it. They're building those parts. How do you think they know what the catcher arms are going to look like? Where are they going to drop Booster 4? Out in the Gulf of Mexico, Cairo. How precise are the Falcon 9 landings? Falcon 9 can get within a couple meters of the bullseye. Couple meter deviation. And that's why this problem is really difficult. As if landing a rocket wasn't difficult enough, right? Landing a rocket with less than a meter deviation is going to be insanely difficult. I'm wondering how they're going to align roll when the arms lower the booster back down. Mason, my guess is the crane. What this thing isn't showing, oh my goodness. What Eric X's thing isn't showing is, if we remember, there's supposed to be a crane on top of this. The Appleton crane is supposed to be up there. And if the crane, if this thing catches it and lowers it down, and then they lift it up with the crane, you can put it right back into position. They can literally do exactly what they're doing right now. They could do this. How long did this take? This took less than an hour. There will no longer be a crane on top. Thomas, you okay, all right. This is where EJ is going to second guess SpaceX, all right? And everyone's going to say I'm wrong. It's fine. It's okay. I disagree. I think there will be a crane up there. Yeah. How are they going to get the booster on this thing in the first place? Is the 11350 just going to sit there the entire time? I highly doubt that's going to happen. That doesn't make sense with how quickly they want to integrate Starship and Super Heavy. It doesn't make sense at all. It doesn't make sense having a lattice crawler crane just sitting there the entire time. That's probably not what's going to happen. There'll probably be a crane on there. Or somewhere in this design. What are they going to do? Have a crawler crane just sitting out there on an oil rig to reintegrate the booster? Nah, that doesn't make any sense. They're probably not going to do it right now, but they'll put a crane on that thing. I'm calling it now. And you could say that I'm wrong, but I mean, and that's fine. If SpaceX doesn't plan on doing that right now, I get it. But how else are you gonna do? How else are you gonna do this? Is the Libra just gonna sit there? They don't need to make it autonomous, Livid. No, not necessarily. Like I don't think that they're just gonna keep a crane there the entire time. But they might. I mean, link pose to this? Yeah, sure. With the crane on top, how tall would that make the structure? 500 feet, give or take? Elon tweet. Oh my god! Okay, so he's out there. Holy shnikes. Imagine being a crane operator for Super Heavy in the future. That'd be pretty cool. You aren't wrong. The current crane is clearly for the landing arms as they are fixed. You need a method to move the rocket and Starship sideways. I doubt the catching arms can do this. Actually, the catching arms will be able to do this, but Mason's question still stands. How are you going to realign the booster to the hold down points? Unless you somehow have an androgynous hold down point, but that's never been done before, ever. Because you have to line umbilicals up. Check the next tweet. It's exactly what we're talking about. Look at the next. What the hell? Megazilla will do this for future rockets, but it's not quite ready yet. How? Okay, that's just strange. Why would he... That's weird. I mean, it's probably something to... Probably something to talk about, I guess. How? How are you going to realign it to the roll axis? That makes no sense. Unless they just... No, that doesn't make sense either. So, Thomas, how would they do it then? Unless they're going to have, like, maybe a small crane or something? Maybe a little small, like, boom sticking off Mechazilla or something? How would you realign this? Be careful, Itar, in the next picture. What? Oh, it's... Yeah, no, it's fine. That one's okay. You can't tell. Even with the business ends things, you can't really tell. They have plugs in the nozzles. Have the lower pad rotate? Come down aligned already? Yeah, maybe. Nah, dude, that doesn't make any sense. Looks like 5 engines are not fixed. All these ones move, Balxy, but if you mean the gimbal is just hanging there, yeah. Yeah, see, they got... The reason why this picture's okay is because they got plugs. They got plugs in the throat to prevent foreign object debris from going in. Yep, there's your hold downs. Now, the real question is, what's that thing on the side? See, the table isn't even finished, dudes. The launch table isn't even done yet. Oh, fired, not fixed. Oh, yeah, see, these ones, yeah. You could tell which ones haven't been fired. SpaceX needed to do a fit test, and they didn't have enough engines tested, so they just started throwing engines. They probably shipped these directly from Hawthorne. It went right, they'll probably ship them back to McGregor when the integration is done. That's absolutely, I mean, that's absolutely absurd. I don't know, man. You know, Elon saying Mechazilla will do it is... Elon saying Mechazilla will do that, you know, I'm pretty sure that just refers to the whole thing. Am I wrong? Like, when is this thing launching? A couple of months? Yeah, see, not even all the piping on the pad is hooked up. It's close, but it's not there yet. Mechazilla is the catch arm stuff. Maybe it's part of it. Maybe the crane is on the movable thing, Thomas. I mean, if it's strong enough to catch the damn booster, it's strong enough to lift it up, right? Like, would it not be possible for the computer to account for the roll? Yeah, to an extent, Big Body, but it's the umbilicals and stuff, dude. The computer probably could compensate for roll to an extent, but this is what I mean about this being an extremely difficult problem to solve. It's not that you can't land the thing, right? Of course they can land the thing. SpaceX is good at landing rockets. They're the only ones that do that. But landing it with that margin of accuracy is very, very, very difficult. That's really hard. That is in-freaking-sane. I'm just gonna, you know, save these pictures in my Starship research folder, if you don't mind. Yeah, it's just, I need this for research, okay? I'm just gonna save that one, dude. I'm just gonna put that in there. Yep. Yeah, I'm just gonna save Jack's picture there. We'll just I need these. I probably need these later when people are gonna reference the ask questions and stuff. Yes, Spiffy, research precisely. Yes. Big Buddy, I mean, presumably the rocket could use different hold down points. It could twist a little bit, but you got to line up your umbilicals. That's where I'm wondering. Where the heck are the umbilicals for this thing? How are they gonna fill this thing up with fuel? I don't see any fuel lines here. And don't get me wrong, they could be inside of it. They probably are. But here, actually, you know what? Let's go back and look. You see any place to hook up fuel lines here? We should be able to spot it. It should be pretty easy. It should be just a big pipe facing down or something. That's ridiculous. This is absurd. This is crazy. Portal technology. They're on the side. Incoming transmission. I mean, how much more accurate it is? The drone ship's within a couple meters, so about 10, 20 feet. Well, land in one piece, you mean? Well, of course. That's the expectation. You don't want to land it in pieces. Where's the sound suppression system in Deluge on the pad? My guess is it's going to be mounted up here. Just a guess, though. Or sprayed in down here. But anything that's in this area here is going to get really warm. So, I don't know. Isn't there pictures of the umbilical on the other booster? I don't know. They had something hooked into them on the SPMT. So it might be out on the side, and it might be on the side that we can't see. Relative to... Here, let's take a look at this one. Anything? See, these are the AG pipes, or autogenous pressurization. Those are the AP pipes. I don't see anything in that picture. Anything up there? It's hard to tell. I have no idea. That could be it right there, but then again, that could just be a part of the scaffolding that's up there. Let's check this picture. Hey Frank, what's going on? I wonder what the 3 nozzles on each arm are for. That could be it right there. See whatever that is? That's Falcon Heavy, right? It's a little bit bigger than Falcon Heavy. The hold down arm's in the 3rd picture. Yeah, those. I don't know. Yeah, that's peculiar. I do not know what that is, Mason. I have no idea. That could be the fuel line. It could be. It makes sense. Maybe they don't have an umbilical at all. Maybe they have a tap. There's a tap on each Raptor, and it flows inwards through the Christmas tree. Yeah, I know. Yeah, that's right. So my question stands: is this the most powerful machine produced by man to this date? It should have more liftoff thrust than the N1 and the Saturn V, Horsu. So yes, it is. SLS, actually, SLS probably has about, I forget. Oh, very nice, Snap. Yes, very nice. The insides of the nozzles, what are those 4 stick things that seem to be offset by 45 degrees? These are just the booster plugs. Fuel line blob. It's not working, Mason. But did you listen to the thing that I did? No, I'm kind of in the middle of something right now, my guy. Yeah, so there's your main fuel inlets right there. See these T-pipes? That's the main, or these elbows, that's the main fuel inlets. So it looks like Super Heavy is going to have a tail service mast, similar to SLS, from what I can tell. That's right, Medisa. I don't know, twitching maybe. That's the fuel inlets right there, so it does have a kind of more run-of-the-mill thing. Elon said that specific impulse loss does not matter when it comes to the booster because he wants more TWR. But I always hear you and Rocket Guy talking about how important specific impulse is. Why is that? Specific impulse really comes into play with upper stages, Goalie. You generally want your upper stage engines to be extremely efficient, so have higher specific impulse. That being said, having higher specific impulse across the board would be better, but sometimes you have to trade ISP for thrust to weight ratio. You have to trade an efficient explosion with an energetic explosion, right? So you could have a very efficient clean burn, right, like a hydrogen motor, or you could have a solid rocket booster, which is not very efficient but extremely energetic, meaning it puts out a crazy amount of power, crazy amount of energy, really, really fast. And when you're talking about first stage efficiency, obviously you do want higher specific impulse. That is ideal. But TWR is the name of the game with your first stage. First stage TWR, it will mean it gets out of the atmosphere quicker. And if it gets out of the atmosphere quicker, that's less time fighting against gravity, less time fighting against aerodynamics. You actually can net more delta V if you have higher TWR. First stages are more efficient, not necessarily by specific impulse. Specific impulse does have a lot to do with it, but they're more efficient from higher TWR. That's what made Block 5 Falcon 9 Block 5 Falcon 9. Falcon 9 Block 1, Block 2, full thrust, Block 3, Block 4. Every time the big difference between like Block 4, a Block 4 Falcon 9 and a Block 5 Falcon 9 is that the Merlins were stretched even more and it gave it high TWR and it's less efficient. That's why Falcon 9 Block 5 comes in and it's like extra sooty every time it comes down, because they ran way fuel rich they ran fuel rich to keep them cool and get more energy out of it, but at the behest of efficiency. Just like a car, literally the same thing. A car, if you run fuel rich, your engine's going to run nice and cool, and you're going to make more power, but you're not going to be very efficient. That looks to be the fuel port. It's covered in this picture. Yeah, maybe Sevi. Wait, during the shuttle launch, did they spray water on water coming out of the engine? They shot water at the rocket exhaust. There's a pad deluge system, and then there's a sound suppression system. The sound suppressor is down underneath the pad, and what that does is that quenches the sound because water absorbs sound. And then there's the pad deluge system. The pad deluge system sprays water over the pad after the rocket leaves. The reason why the pad deluge does that is because the heat from the rocket engines can melt the pad. It's how they protect the pad. Pad deluge systems protect the pad. Sound suppression systems protect the rocket. The reason why the sound suppressor is there is because when the rocket takes off, the sound reverberating off the ground can damage the vehicle. So they need to quench the exhaust and they need to protect the pad. That's what those systems do. So theoretically, higher specific impulse is more of a priority for higher orbit beyond trajectories. Yes. Higher specific impulse for upper stages would be better. You don't necessarily need thrust up there. It's more about efficiency. You got a long distance to travel. So the more efficient you are up there, the better. The one scenario where that might not be the case is if you're making a lander that's designed to land on Mars or land on the moon or whatever, in which case you need to have a certain amount of TWR, because even if you have enough delta V to slow down, if you don't slow down in time, you're going to hit the ground. Yeah, that's kind of where it really comes into play a lot. Yeah. If you make a lunar lander and it doesn't have the right TWR, you might have 10,000 meters a second delta V, and it takes like 2,000 meters a second delta V to land on the moon. And by the time you hit the surface, you've because of low thrust to weight ratio, you're still going like 1,000 meters a second. So TWR matters when you're making landers, and TWR matters when you're launching rockets. It basically matters anytime you're launching or landing on a planet. That's really the right way to do it. When you're up in space doing transfer orbits and stuff, ISP is the name of the game. Specific impulse will get you much better delta V. It really matters with upper stages. Yeah, Simon, right? Sorry for the dumb question, but are they going to do a flight test with this booster? Kind of like what they did with SN. Yeah, they're going to do a flight test with it, Frank. And SN20 is going to be on top of it. And they're going to launch it into space to test out Starship's thermal protection systems. When? Sometime later this year, a couple of months.
But I'm going to reiterate both Jerry and Mac.
Yeah,
Mary and Jack. Mary and Jack. Oh.
Jerry and Mac.
Mary and Jack have
I see 'em.
Been out there all day, not just for this, but for the earlier lift attempt as well before those storms. So I do want to cut them loose at some point and let them get back into the AC. So, yeah. It could be, like, if you're wondering, oh, well, will we stay alive until the crane actually detaches?
I've been doing a lot of talking. I'm going to take a break for a second. I'm going to turn on NSF.
So it could be quite possible that the crane stays attached for a while. And there, in the upper corner, you can see Mary and Jack's information. They're the two folks out there in the field running the crewed cameras, like the actual cameras that are operated by a human being, as opposed to the robot army that's out there. They can move around and they can get shots and angles like this one right here that the robots just can't do. The robots are great at being out in all weather and getting these wide context shots, but they're really not meant for the close-in work like this. 24/7 surveillance of the workers. They're more for the big picture stuff. And Mary and Jack running out there to be able to bring us these close-in shots.
Buddy just sent me a picture. It's
I
not a
think at some
SpaceX
point,
or
what we
anything.
may do here is back off and have Mary and Jack both shut down their feeds and pack it up, and then go back over to the robotic cameras. And
That's
when
right,
we do that,
Arcsign.
we'll probably shut down the commentary and leave you in the capable arms of Starbase Live. Starbase Live is our 24/7 stream.
I haven't
Our
actually
robotic
covered the other
cameras
stuff
that are
yet, Signer.
outstanding in their field.
Oh,
Hey.
oh boy.
Shots
Oh.
You know that my camera's very advanced. It's not crude at all.
So we leave it in the hands of the robotic cameras and let our human beings get back into the air conditioning. I think we are very rapidly approaching that point now. Y'all agree?
Yeah. I think so.
Yeah, I
we're
think so. I
pretty
think
much
it's
there.
just about as much as we're gonna be able to see.
I agree. So I think it might be time right now to start spooling down. Let's go around the horn and just once again put names to voices.
I mean,
I know a lot of times you hear a bunch of voices.
yeah,
You might not know exactly
kind
who's
of.
talking. We don't put faces on the screen, not our faces at least, because we use all of the screen real estate for rockets and rocket-related activities. Not a lot of face
Well, I
cams
tell
going
you
on
what,
here.
boy, we got
So
rockets
let's
and
start off
rocket-related
from the top.
activities
Chris
up in
Gebhardt,
here. I
thank you
tell
so
you
much
what.
for hanging out with us here today.
My absolute pleasure. That was
Chris.
incredible to witness.
Yep, that just looked crazy, didn't it?
Yeah. Yeah. Oh man, just seeing all of them there together, all those Raptors together, amazing.
Y'all, Chris Gebhardt is the assistant managing editor for NASA Spaceflight. Find him over on Twitter at ChrisG_NSF.
Das did that on purpose,
and
Blue.
usually mods put the links into chat as well.
Okay, so it seems like they're winding down, so we'll get back to regular space news here. But once again, if you missed it, look at this thing. Look at that. Give me 1 second. All right. How many Raptors? Yes, 29 of them, guys. 20 freaking 9. Yeah, there's the fuel lines right there. Okay. So I'm going to guess there's going to be a huge tail service mast umbilical right here that with the lines plugged in. That probably looks like the TSMU that's on the suborbital pads, but up here and sideways instead. Wait, is that a GoPro on the left? A GoPro? No. They're going to catch that damn thing with that tower. How is that going? How is that going to happen? I still just don't get it. It's going to, guys, it's going to do this. This is what they want to do. And this is an ERCX render, who's a user on Twitter, ErcX. Yeah, that. All right. Yeah, hourly expensive. I don't know how much that thing costs. I have no idea, guys. We kind of did the math out. Like, Raptor is like $2 million a pop, and that's from Elon's estimates on Twitter right now. He wants to get it lower than that, and that's what Ian, NASA spaceflight correspondent, was telling me. So, 29 Raptors, $2 million a pop, 58 million. And then the stack is probably a little bit more than that, and then all the operations to get it out there and then fly it, 100 million for one of those things. That's still, I mean, that's still ridiculous. That thing, what you just saw, this thing can probably SSTO, like, I don't know, 10, 20 tons into space. I'm going to say 10 at least. Yeah. 10 tons. You could put a Dragon capsule on top of this. That thing can get a Dragon capsule all the way into space, which is just damn impressive, considering what it is. I mean, that's by far and away the most powerful first stage designed. It's more powerful than Saturn V, about as powerful as SLS, but SLS has boosters in the core stage, you know? I think total liftoff, it's better to compare total liftoff thrust to total liftoff thrust, but even then, that still is insanely powerful. Into orbit, you mean? Yeah. It'll shoot a Dragon capsule into orbit, yeah. Do they have plans for a skirt around the engines? No. Not at this time. I don't think so. So many Raptors. Bradley, it's insane. It's insane. Hey, Predominant. Good morning. I've watched Tim Dodd's interview with Elon Pohl. Yeah. Pretty cool, man. Did you watch Tim's video? Yeah, I did. That was probably just chat delay. Imagine a super heavy combination similar to Delta 4 Heavy. 3 of these next to each other, Jax. I don't know what the heck you'd need for that. I mean, maybe if you needed to put a super heavy on orbit by itself. 2 super heavy side boosters with this thing? Yeah, you could...
Yo!
Yeah, that could go easily into space. Hello?
Hi, they're offering refunds.
Oh, alright. Well, that's good.
Yeah, I think I'm gonna do that, because...
Yeah, that's fine.
Yeah.
I get it.
I'm like... if I get my money back, then screw it.
Yes, screw it. Brimo was going to this thing, and then it got canceled, and then, yeah. Take the refund. This makes you appreciate how tall the launch table is. Yeah, the launch table's a good way off the ground. It's free. It's free money for you, Jim. Okay. Any Starliner updates since you've been at work? All right, I think we've substantially covered Starship. Starliner has a mechanical valve that's stuck inside of the service module. Not sure how or why. I don't know how that missed checkout or anything, but yeah, there's a sticky valve inside of there, inside the service module. So they scrubbed again today, and not sure when the next net date is. I know someone's going to ask. There is a mission to the asteroids that's going to launch in the late part of the summer.
Discovery Houston, press to ATO.
Hey, Dust, thanks for the host, man. And I'm not 100% sure, because the ISS has other traffic going up to it. I'm not 100% sure if, like, they're gonna have time to get Starliner off, depending on the severity of the issue. Mid-October is Lucy. Yeah, but ISS traffic would put the launch window near Lucy's launch campaign. Lucy is a payload that's going out to the asteroids, but it has to launch in October because it's going to grav-assist off other planets to get to the asteroids. So it needs to launch then. So Starliner has an ever-constricting window of opportunity to launch to the ISS because there's going to be other spacecraft up there taking up the docking ports that it's supposed to have in, well, another couple of weeks. So whatever it is, they got to fix it quick. There's no doubt in my mind that they will. The other thing hey, Ren, what's going on? Dylan, 21-month resub. Thanks, man. The other thing to take into account, guys, is that it's a test flight. guys, you're going to have weird problems like this. It's the second time that they've put this capsule out there. There's teething problems. Dragon 2 had teething problems as well. It's just SpaceX goes faster, so you don't notice it as much. So, yeah, there's going to be teething There's going to be teething problems. I don't think it's that big of a deal. I mean, depending on the severity, I mean, you got to figure out... It's one thing to take that valve and close it, the sticky valve, wherever it may be. It's a whole nother thing to figure out why that happened. Boeing has said that it's not software related with Starship, with Starliner. Sorry, too many star things. Starlink, Starship, Starliner. With Starliner, they said it's not software related. So it could just be that the valve is junk. So just swap it out. You know, it could be that. Who knows? So, yeah, there's a bunch of different things. A Boeing Starship is a scary thing. I mean, I'm not going to say that I don't want that scary. Hi, by the way. How? All right. Starbase, Stargate, Star Killer Base, Krennic, the Death Star. Star person, star man, fly. Okay, anyway. Sierra's 23 is launching on the 29th of August and undocking in early October, and Crew 3 will be launched in late October. Yep. They got to get this problem fixed, whatever it is. Antares has a CRS soon. Yeah, but Antares doesn't... the Dragon one is the one that uses the same docking port jacks. The Antares uses, with the Cygnus capsule, uses a common berthing mechanism. So, yeah... I mean, traffic nonetheless, but not one that's going to take up the docking port that Boeing needs. Ringo Star, Superstar, Space News. News! Alright, let me move those Ruski links into the Space News here. Nupa Ruski. Dolga. It is important to understand your adversary's language. Alright. Alright, so here, a little bit more about Starliner here. Let's see. This is coming from Christian Davenport at the Washington Post. What is he saying? Boeing is being deliberate about finding out what's wrong with the Starliner valve issue. First step is to inspect it in the vehicle integration facility and hopefully launch on Saturday. But two officials told me there's a good chance that the vehicle will need to be destacked in order to get at the problem. Uh-oh. Uh-oh. Oh, I don't know, man. I don't... Really? Destack? Yeah... I don't know. Maybe. Well, good thing it was delayed by Nauka. Yeah. Yeah, if they destack it, if they take it apart, yeah, that's not happening anytime soon. If that does happen. But once again, that's two officials told me. Okay. There's no way to verify that the validity of that information. There's no way to know if that's, you know, two officials told me. Yeah, okay. Just finished watching the live stream. What amazing crew. Yeah, it's good stuff. When you said sticky valve buried in the service module, I took the idea of needing to destack Starliner as a given. It depends on where it is, Synerd. If the valve is near the outside, it might just be literally near the outside of the circumference of the capsule. Like if it's closer to the diameter of the service module, yeah, you might need to just take a couple of plates off. But if it's inside of the service module, closer to the center, then yeah, you might have to take the thing apart. I mean, new drinking game, every time Starliner has a problem, take a shot. I mean, if we played that drinking game with Dragon, we would have done the same thing, S-Master. We would have all gotten alcohol poisoning after the dragon blew up on the test stand. Remember that? Just got to the hotel track walk in 20. Killed 19 of those minutes with you. Hey, all right, dude. Scary, you gotta drive. You gotta come back when you get a chance and beat Ren, please, because he keeps winning and it's getting annoying. It's not, Ren. It's awesome. Thanks for racing with us. I do appreciate it, man. Scary is your skill level, man. No, Ren's like, no, I don't want this at all. No, don't do that. But Dragon blowing up on the test stand is just one really big problem, right? Yeah, I guess. Soon. Nah, I'm just kidding, man. Yeah, no, you do you, man. All right. Let's see. What else do we got? Hey, Suni, what's going on? Yeah, human, just take your vitamins. I can never wake up for it anymore. Enroid's getting... I mean, we still Valtteri Bottas people from time to time. You know exactly what I'm talking about. And no, it's not too soon. Shut up. That was dumb. But yeah, the racing is pretty good. It's pretty clean. Valtteri, wait. The left pedal does what? Bottas. Bowling. Dude, I can't believe that. What? See, like... when we play Friday Night Racing and someone gets punted like that, they're always mad. Like, what the heck? I don't know what's going on. This never happens with real racing. It's just no, it does. It straight up does happen with real racing. You saw it happen at Hungary. You know. Hey, are you a programmer? Nah, Trash. I'm not a software guy. Mechanical engineering and aerospace engineering is what I understand. Software is might as well be Japanese to me. Well, with that being said, we got plenty of software guys here. The Hungarian triathlon, bowling, racing, and running. 2 drivers did that. 2 crashed. Yep. We have multi-class racing every week. Ren and Scary, then Storm, Max, and such. Then the rest of us with EJ in the pits with speed penalties. That's not funny. Dick, I beat you last week. It's not my fault. Real penalty is dumb. Pit speed limit is 50. Is it though? Here, I don't want to keep talking about this. Subject change. Boop. There's a picture that's coming from a Twitter user called BioReconstruct. And it's a picture of Arecibo. And it looks like they've cleared most of the debris and they're going to fix it. That's pretty good. It looks like they took off all the damaged reflectors on there, and they're going to start replacing the stuff. Very nice. There's a petition to delete Radion. Delete Radion and make it a straight? By whom, Forge? The Committee for Experimental Ball Removal Surgery? With all due respect, and I mean with all due respect, Mr. Dennett, I didn't know you had experimental surgery to have your balls removed. Ridiculous. They spoke about it on Coast to Coast AM a few months ago. Cool. He said with all due respect.
Discovery.
No, when you can't just say with all due respect and then talk to me like that. Oh, well, I can with all due respect. As long as I say with all due respect, I can say whatever I want. Well, your daddy used to love it when I used to win. Mr. Andy. Welcome to Mission Control. You go and throttle up. Thanks for the sub, dude. How do you take a corner out? Yeah, well, Radion is where the track goes it goes left to right, and then Eau Rouge is the up to the left, cresting the hill. It would ruin the track. Cars would go way too fast down the Kemmel Straight. way too fast. Oh, yeah. And then they would say, hey, let's put a chicane in the Kemmel Strait to slow them down. Yeah, see, I already see this bull crap coming from a mile away. Don't listen to those people. It's racing. It's dangerous. You can be safe and still have dangerous corners. But a safe track with super safe cars makes for very bland racing. You gotta have some thrill somewhere. Like, I get it. It's not, I get it. It's dangerous, okay? Going around a track at 200 miles an hour is dangerous. It doesn't matter how you spin it. It doesn't matter how safe it is. It's dangerous, okay? Like, how about we just leave the track the way it is? What's that, predominant? Hot take, yay or nay? Blue Origin punting launchers for prioritizing in-space transportation and habitation. They have the budget to do both, Scary, but yeah. I love this guy. Greetings from Deutschland. Hallo, Marius, wie geht's? They're extending the road off on the left side of Radion, that's for sure. That's fine, Max. Totally fine. Understandable. Have a nice day. Yeah, that wall comes up quick if you don't get the corner right. What did you think of the Blue Origin flight? I thought it was cool. I thought it was cool, dudes. Screw me. I thought it was really neat. I get it. Everybody, yeah, Jeff Bezos, blah, blah. Yeah, whatever. It's a guy that wants to spend billions of dollars at space. Why am I supposed to... Billions of dollars on space flight. Why am I supposed to hate that again? All right, let's see what we got here. FIA Formula One race director and safety delegate Michael Massey remains confident that Spa is safer following a major accident last weekend Spa 24. Dude, if they ruined Eau Rouge, I will never watch a Spa race again. I don't care. The rest of the track's amazing. Yeah, if they did that, I would be like, I don't need to watch that. Yeah, I don't need to watch that. Danke. Good. Hope you have a nice stream. Thanks, man. Yeah, whatever. It's a turn complex, dude. It's like if you say Maggots, Beckett's Chapel, or Beckett's Maggots. It doesn't matter. Everybody knows what you're talking about. But once again, chat. We gotta be super clerical in a time where it's just people talking, just buddies talking. No. Let's be super clerical. Are we gonna make sure everybody's grammar is good too? If they are forced to change it, then they will choose not to host F1 probably. Anroy, yeah, no. Why would they? I wouldn't do that. Don't change the track. It's not our problem you can't drive it. I agree with you. Yeah, no, I'm sick of this. Hey, we got to change the track to make it safer. Anroy, we could sit here and keep saying, and this is where I'm at, dude. And don't get me wrong, I don't want race car drivers to die. And you can make the sport safe. That's totally fine. You can make auto racing safe. The thing is, at the end of the day, people are still going to get hurt. You know why? Because it's auto racing. If you have a bulletproof vest with ceramic plates on the battlefield, does that pretty much guarantee that you're not going to get hurt? No. Why? Because war is dangerous. So is auto racing. Same thing. Like, it's not. I get it, but it's just an analogy, right? Like, it's not. I understand that that's not the same thing, but it's just, we keep making tracks safer, and we keep making them safer, and people keep dying, and people keep getting hurt. Gee, I wonder why. Like, what's the constant there? The constant there is, it's auto racing. It's dangerous. Like, that's just, there's no way around it. Like, they could race at Zolder instead. Yeah, just like they decided to do, Sebi, in the early 80s, and Gilles Villeneuve got killed. Great. That ended real good. Yeah, even the F1, F2 drivers want it to be changed. Well, at least I'll have another Sunday late in the summer to Another Sunday open where I can sleep in late in the summer because I ain't watching that if they change overs. I'm not doing that. I'm not doing it, man. They've made so many of these changes to Formula One under the guise of safety, people still get hurt. See your last puzz. Is this relevant? Yeah, okay. Even the driver that got hurt. I personally would never want any change to this corner. We all know the risk when we sit in the car and go flat out at 240 up the hill. The only thing that could have helped us is the gravel on the left side. If you replace the asphalt with gravel, every driver will be 2 to 3 kilometers per hour slower. Right now, we all drive at the limit or even over the limit. Knowing that if you have a moment, you just cut the track and do a track limit. Yeah. In modern times, we're not afraid of crashing when we are afraid of getting a drive-through because of the track limit. Yeah, it's funny. Runoffs actually make the race more dangerous. And you know why they put runoffs in? Because everybody said that gravel traps were dangerous. Yeah, we just went over that, Kachri. We watched them move the booster on the NASA spaceflight livestream. It was really cool. Speaking of Villeneuve, hot take from Jacques Villeneuve, stroll the Mercedes next year. Yeah, sure. Sebi, are we talking about the other guy that locked up his tires and drove his car right into Leclerc at Hungaroring? Yeah, let's have them replace Bottas, who did the same thing. Thanks, Jacques. Merci, Jacques. No. There's also calls to add Shred to F1, which is kind of French Spa. Ooh, that track looks nice. I was always a fan of mini cores, though. Space and Rocket review. Oh, yeah, we're not talking about space for like the 15 minutes out of the 4-hour space news segment in the 12-hour stream, Sea Dragon. Thank you. Thanks. Yeah, you're very observant. You must feel great about yourself. Here, I'll go back to space news just for you, BB. All right, so let's see. This is coming from Jeff Faust here over at Space News. Former NASA official joins NanoRacks to lead commercial space station work. Let's see. Commercial space services company NanoRacks has hired... I love you, C-Drag. I'm just kidding. Not really, though, but also yes. Well, yes, but actually no. Sorry, man. I tried to do it with a straight face. I couldn't do it. Oh, my God. I'm trying. I can't do this. I can't do the chat disrespect thing without laughing because it's funny. It's so stupid. With all due respect, and I mean with all due respect, chat, why don't you do me a favor and shut the hell up? Sorry. Okay, all right. Commercial space services company NanoRacks has hired a former NASA official most recently involved with planning for the Artemis program to lead its efforts to develop commercial space station. NanoRacks announced on August 2nd it hired Marshall Smith to be its senior vice president of commercial space station. Smith retired from NASA at the end of July after more than 35 years at the agency. Most recently as Deputy Associate Administrator for Systems Engineering and Integration of Human Exploration and Operations Mission Directorate. Basically the guy that figures out how to put people into space and what NASA needs to do that. Yeah, that's the right way to say that. Systems engineering is like all the pieces that you need to put somebody into space, like launch pads, the capsules, the spacecraft, yeah, training, blah, 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 blah. Actually, systems engineering is more not astronaut training. It's more the hardware sides of things. But in his new role, Smith will oversee the company's Outpost program, which also seeks to convert upper stages of launch vehicles into modules that can be used for in-space manufacturing or habitats, as well as plans to develop free-flyer commercial space stations. Smith will run the company's new office in Huntsville. Ooh. Very nice. Puts people into space good and does other things good too. Why does that picture just look like a New Glenn upper stage? Maybe Project Jarvis is just a wet workshop thing. Well, Nanorax doesn't make upper stages, so yeah, you might be right. You liked Silverstone? You worked there about 4 years ago. Sick atmosphere than when the main race is on. Silverstone's good. I'm not really a fan of when they moved the paddock. When they moved the paddock and they got rid of Bridge. Yeah, I'm not really a fan of that. I don't like when they move the paddock. I don't like those changes to the track. They're not the worst changes, but I think that the changes pre-paddock move for Formula One, that version of the track with Bridge, Club, onto the main straight, and then Copse, Maggots, Beckett's, Chapel. Yeah, I like that version of the track better, but that's just me. Pretty sure that's a Centaur. Let's see if they've worked, let's see what they're working with, if it says it. Nanorax is one of the pioneers in commercial use of the International Space Station, working with NASA to fly payloads to the space station and use it as a platform for CubeSat launches. Nanorax deployed a commercial airlock called Bishop that was installed on the station in December of 2020. The company is one of several that has expressed interest in developing commercial space stations as successors to the International Space Station. In his last role, Smith was the senior engineer for the directorate responsible for human spaceflight, converting high-level goals into program objectives and requirements. Before that, he was director for lunar exploration programs, overseeing development of the Gateway, human landing system, and other lunar exploration efforts. Interesting. Wet workshops. So a stage that you launch into space that's empty, and it's empty, but it has an airlock at the front, and the airlock is sealed right when the fuel is in there. And then they find a way to evac the stage, evac all the propellants out of the stage after it's been up in space, right? You inert the stage, and then you have a pressurization system that pressurizes it, and then you open the airlock, and now you have all that free real estate. That would be terrible, Forge. Why would you have solar panels all around it? So that's actually pretty cool. This next news also is just a Twitter post by the guy who wrote that article. Not necessarily. I lost a customer to the Chinese space station. Jeff Mamber of Nanorax says at the ISSRDC conference, we're in a competition now. This is the ISSRDC, International Space Station Research and Development Congress. It's like GDC, but for the ISS. Yeah, same thing. I've been to the ISSRDC. In 2014, it was in Boston. I got to go, and it was amazing. Yeah, it was really cool. They just talk about what they want to do with the ISS, all the research, all the development, what the plans in the future. But yeah, interesting that Nanorax is saying that they lost a customer to the Chinese space station. Uh-oh. Oh boy, it's almost like Apollo Applications Program had it right the entire time. Yep. What is this, Forge? This is kind of awesome. So this is coming from Joy Roulette. SpaceX updated its Starlink app earlier this week with a new way to scan for obstructions and a new tool that logs and visualizes outage data. Oh, neat. Oh, that's actually pretty cool. You could pretty much guarantee that uses AI. I mean, yeah, of course. You're going to have to analyze the image somehow in real time, drummer. Like, right? Like, that's really cool. That's coming from Joey Roulette over at The Verge. How neat is that? Well, that's pretty neat. You could tell it's neat because of the way it is, Mason. That's pretty neat. All right. So here, we got a video coming from Rocket Lab. Rocket Lab just successfully had a return to flight like a week ago. And here, let's see what they're up to.
Hi, I'm Peter Beck. I'm the founder and CEO of Rocket Lab. Why don't you join me on a bit of a tour of these facilities?
I will do that, Peter, and I will enjoy it.
So right now I'm standing in between the composite line and the final assembly line. So behind me, all of the carbon composite tubes and parts of the launch vehicle are manufactured. Then they transition over to the final assembly line where everything gets bolted onto them, and then finally they shoot out the door and down to the launch site. At Rocket Lab, quality is always number one. And as you walk around this factory, you'll see that not any tool is out of place. Everything is in its own place. You can eat off the floors, and this facility is absolutely organized and beautiful. Within this industry, there's a lot of talk about factories of the future. You're standing in a factory of the future, and it's not a CAD image, it is up and running. And every 20 days, a rocket rolls off this production line. Raw material in one door, 20 days later, rocket out the other. Everything is done here and the other factories. So in this particular factory, we have a whole lot of composites. We have machine shop, 3D printing, avionics, clean rooms.
At the Rocket Lab facility here in Long Beach, we have a lot of things under one roof. We have engine development, we have avionics development, we build solar panels.
Nice.
We have a vast array of CNC machines and 3D printers that allow us to build all these things and test all these items.
TGP, what's up, dude?
So
oh, dude, laser sintering.
Key functions.
That was a
Firstly,
3D metal 3D printer.
Integration and keeping our costs down, so we can manufacture our flight components much cheaper in-house than if we were to outsource them. But secondly, we are still an evolving R&D organisation. We push the limits. We've got our Space Systems division. We're going to the moon. We are constantly iterating. We've got Hypercurie coming online. They are an iterative process of development, and so you want to be able to turn around new parts really fast. We want to have that new design on the test stand tomorrow. The only way you're going to do that is if you maintain that capability in the house. We're extremely vertically integrated. As a result, we really understand that product really well. We've proven that through 20 plus flights.
Automation has been a really key part of our composites division.
Forgot how many times
raw material fiber comes in, it's automated
plus.
into components, and then those components go into a giant machine called Rosie the robot.
Not sure, SnowRunner, they're still trying to figure it out.
All those components are transformed into their finished products and then out on the production line, all within about 12 hours. You know, just about everything we've done in our history is included some carbon composites of some description. So not only do we build launch vehicles here, but also of our spacecraft components. Behind me you see the composites clean room, and then just over there we've got composite spacecraft elements that are used on the Capstone mission and many other missions that are going to far destinations.
That's cool, man.
So in the last year, our Space Systems division has doubled, and we intend to double again this year. We make flight computers, we make batteries, we make
solar panels,
radios, we make solar panels, all in-house, all vertically integrated in order to facilitate the development of full spacecraft.
Dude, they're making,
we also
you see
have
that?
A facility
making the PCBs
here
in there.
A laboratory where we can do calibrations for reaction wheels, star trackers, and all the equipment that's required for guidance, navigation, and control systems of spacecraft.
Wow.
Rocket Lab is responsible for a lot of firsts. One of the most important being actually 3D printing of rocket engine and rocket engine components. We are the 3D printing experts within the space industry. Our first rocket engine was 3D printed over 8 years ago, and now we have 200 of them that have gone to space. What 3D printing enables us to do is meet our manufacturing rate, and that's one engine every 24 hours. Within Rocket Lab, we have multiple factories placed all around the globe. The engines are produced out of the Long Beach factory, and they arrive down here to New Zealand where they're tested and then finally integrated onto the launch vehicle and then ultimately launched to space.
Before the launch vehicle gets to the launch site, the elements of the launch vehicle go through a significant amount of testing through our propulsion test complexes. This enables us to
look at the little baby test stand.
Fire level through to stage testing, through to final assembly before it's shipped to the launch site.
So at Rocket Lab we run a very deep hardware in the loop
Not that
program.
I know of, RJ.
So basically the whole launch vehicle is laid out, or actually use the components of the launch vehicle to simulate flights and the build of the vehicle as it's coming down the production line. The HITL guys will be able to determine if there's an error in the launch vehicle before it's even built.
They're not 3D
and those
printed.
guys can actually fly that launch vehicle to orbit before it's even built on the factory.
Look at
and
the
determine
gimbal.
If there's any issues
It's a
with any
little,
of those
it's a little tiny
calibrations.
gimbal
All
test
of our facilities
stand.
around the world incorporate not
It's
just
a little
production,
tiny
but all
gimbal.
of our design and analysis and development teams. And I think that's critically important to not segregate your production from also your engineering and your design. So throughout all our facilities, all of those functions are distributed. Look, our team has perfected manufacturing. The next step for us is reusability and recovery. And we've already had multiple successful re-entries and also 2 successful splashdowns where we've actually recovered the booster in wonderful shape. And right in front of me here is actually the next recovery booster on the way down the production line. So what that really means is that from a manufacturing perspective, we don't have to build as many rockets because we can literally bring these launch vehicles back and these rockets back, refurbish them, put them back on the line, and fly them again.
It's not like it's
So
going to
these
rust. The
factories
thing's
represent a
carbon
huge
fiber.
investment by the company over many, many years. And we've got to the point now with these factories where any changes that we need to do to the launch vehicle or any increase in production, it is really quite trivial.
Right behind you see the Mission Operations Center for Space Systems. We currently operate 2 spacecraft on orbit. All of our future spacecraft for space systems will be operated right out of here in our headquarters in Long Beach, California. It's co-located with our engineering department, allows for fast iteration with the team, and allows for seamless operations and calibrations of the systems that we launch. We're doing a vast portfolio of missions here, all the way from low Earth orbit to interplanetary here at the Space Systems Division in Long Beach.
Capstone.
We're doing a mission to Mars, which is 2 spacecraft for a NASA mission called Escapade. We're also doing several LEO missions for commercial and government customers that'll exercise the full capabilities of the engineering staff here in Long Beach.
Our first launch site is Launch Complex 1, located in the Mahia Peninsula.
This is a great video.
It is the world's first privately operated launch site, capable of 120 launches per year. The reason we can achieve such a high launch frequency out of LC1 is that we're located in a very remote part of the world, and wide access to azimuths and inclinations gives us high frequency but also high access to a range of orbits. Having 2 pads at LC1 offers us incredible flexibility.
They built the second
we're no
one
longer
the other
constrained by a particular
the other
customer's
day.
delays or what's going on in a
Been a while.
specific launch pad with a specific launch vehicle. So the 2 pads fundamentally enables frequency, but it also gives us the backup and redundancy should we need more opportunities in short order. The beauty of owning your own launch site is that if we want to go tomorrow, we launch tomorrow. LC1's the home to many world-class
Not big
facilities
enough
that
yet,
support
Pat, so we
launch.
need more buildings.
On top of the 2 launch pads that we have a host of clean rooms, even capable
Look at the
of
little tiny
processing,
satellite.
spacecraft
Little
fueling
small
activities at the
satellite.
launch site itself. We've also got an integration facility for the launch vehicle. We also host the range control center,
Pretty
2
much,
kilometers
Iman.
away from the launch pad, that house our critical operators before launch. So operating our own site at LC1 gives us incredible flexibility. We essentially own the schedules. We determine when vehicles can get launched,
Sheep.
can get wet dressed and tested. Part of that
More
includes
sheep.
operating our own range safety team, so we have no reliance on external contractors or government entities to provide that service. What that enables, again, is incredible flexibility. We control the spend, we control the way we operate, and therefore allows us to provide a very lean, commercially viable service. So in support of our test and launch sites, we have 4 key control centers, 2 mission control centers and 2 range control centers. They're all interconnected, and it doesn't matter where you are, you can support a test or launch
That's right,
operation from any one of these sites. And this enables us to deliver a global launch capability, whether it's for a launch service or a satellite service.
Cool.
Launch Complex 2 is based on Wallops Island, Virginia.
Yeah,
It was strategically
dude.
selected to be in Virginia, again, primarily because of its low activity. We've got access to a relatively high part of the launch calendar at Wallops itself.
Sweet.
Also includes the integration control facility that's located off base,
Yeah.
so it's completely
Is it
deconflicted
mission
from
control
any
or a
other
land center,
base
Hip Hop? I'll
operations.
let you decide.
The ICF is a one-stop shop. It's the place where we integrate our payloads onto Electrons,
Right, Okie.
as well as house the local operations team to command and control the launch. Having built multiple launch sites in the past, we certainly have the ability to set up shop really anywhere on the planet. We've been able to navigate the local regulations and meet all the compliance requirements, as well as do the infrastructure, get the engineering done in record
Right,
time.
Thomas?
So you can't have launch and spacecraft operations without a network of ground
Yeah, it's right
stations.
next to Antares'
We
pad,
own and
yeah.
operate some of our own ground stations, as well as have a strategic partnership with KSAT that gives us ability to get data from launch or space on demand.
One of the strongest attributes of Rocket Lab is the team, and no more is this prevalent than the production team. So these guys here have put 20 launch vehicles
Yes.
on the pad, and as you can see
is
around
good.
me, probably another 10 in production. And the team here is the best in the world. Rocket Lab is really, really well known for taking incredibly complex aerospace structures and components and systems and just producing them at volume.
That was a cool little video. Yeah, I mean, when they say that Rocket Lab's totally vertically integrated, they'll build your satellite for you too. All you really need to give them, if you wanted to do a mission with them, for instance, right, is the sensors. Say you want a satellite that takes pictures of the Earth, right? Their payload attachment fitting is a satellite. That's what we saw that in there with Photon. Let me go and find it here real quick. No, not yet. See this thing? That's their payload attachment fitting. It's its own satellite. You could just put, all you got to do is just give them the camera lens, and they'll handle the rest. It really is one-stop shop for small sat launching. They'll make the satellite for you. This right here, their payload attachment fitting. So the PAF on rockets is usually just a structural adapter that holds the payload fairing, it holds the payload, and it attaches to the upper stage. Rocket Lab took their payload fairing and made it into a satellite. So after it pops off, right, it can separate from their upper stage and it becomes its own vehicle on orbit, which is actually pretty damn cool. That's really smart. Shady, 16-month resub. Time for a career change. Job alert, SpaceX mixologist needs a cocktail connoisseur at its rocket campus. Space who can whip up some space-themed drinks. Yeah. So, yeah, that's actually really cool. They'll build the whole thing for you. All you got to do is say, I want a satellite that can monitor temperatures, and then you give them the temperature monitor piece, and then they'll just attach it to their satellite rig, which is actually pretty cool. They're making the PAF into the payload bus, or the satellite bus, is a really interesting concept. I really think that's neat. Yeah, there's shots from their mission control. That's a shot from the bottom of the upper stage looking at the top of the first stage. There's the second stage engine. These are all pad cameras. That's a tracking station view. First stage view right there. That is the mission control, and that's mission control in Long Beach, I think. I'm not sure what that is. Maybe the payload. Who knows? How much to send a wheel of cheese into space? Oh, you'd have to ask Elon for that. Yeah. Anyway, so let's see. The next bit of space news here is coming from the International Space Station Twitter account. So NASA and Northrop Grumman are targeting the launch of the Cygnus spacecraft or space freighter to the station 5:56 p.m. on a Tuesday. On a Tuesday. Got them. Running out of toes is on the pad. Cool. Yeah. Most interesting. You sure showed them. Oh, I did. On a Tuesday. So actually, that's a really cool picture. There's Cygnus. There it is. There's the Cygnus capsule and its service module. And then there's the PAF, the payload attachment fitting here. That's attached to the Castor 30 XL. And then there should be... There should be a forward load reactor here, an FLR. That's what that white plate is right there. A forward load reactor is just... So Antares' fairing begins at the top of the first stage, of the Antares core stage. This is just a fairing, but it's just a fairing that's in the shape of a funnel. It's a full cylinder, right? And it's hollow on the inside. There's a payload attachment fitting inside of that, and that payload attachment fitting that's on top of the first stage is holding that Castor 30. The Castor 30 is a much smaller diameter than the core stage. So the engineers at Northrop Grumman came up with the idea of having a PAF to the Cygnus capsule, and then the Cygnus capsule's fairing is attached on a forward load reactor, which is running on this piece that says Northrop Grumman right there. It's kind of like an interstage almost. And then the fairing is attached to that, giving the outside of Antares a very sleek appearance, right? But the upper stage is actually, you could see that that's the Castor 30 XL. It's an SRB, vacuum optimized SRB upper stage. It's derived from ICBM tech. Yeah. Yes, Jackery, it is. What rocket are they using to launch this Cygnus? It is Antares. It's been Antares for a while. Yeah, and then the fairing will attach to the forward load reactor here. And then the forward load reactor will pop off when they deploy the upper stage. So the forward load reactor will pop out, and then the upper stage will just keep going. Stolen idea from ULA. ULA with Atlas 551 does use an FLR like this. You can see it's segmented, so it'll end up popping off sideways, and then the upper stage will shoot out. The upper stage, once you hit the go button, it's go, because solid rocket. But it's actually a really cool little design. Antares is quite a capable rocket for what it is. It only launches Cygnus, though. But even then, for what it is, still pretty cool. So that's going to happen on the 10th, so that's next week, next Tuesday. Maybe I'll drive down. Nah, I can't get press coverage. I can't get press access, which sucks, but hey, it is what it is. I should have a week ago, or I could have applied for it a week ago, but I don't know. That would have been a good one, because I could have driven down day before and then driven back. Yeah, that would have been a bad idea. Anyway. So, next bit of news here. This is a little more Starship news than we discussed. We discussed a lot of the booster stacking, but it is important to mention that SpaceX also installed all the engines on serial number 20, on Starship 20. It has the 3 vacuum engines and the 3 sea level engines. This is the first time a Starship has had 6 of the engines installed. No landing legs on 20. Yeah. No legs. No, well, I mean, water, Thomas. Land, not do, no landing leg, water. The Raptor with the visible serial number was static fired on Booster 3. Cool. It's Lieutenant Dan. Why no flippers, smirks? Booster or Starship 20 is the one that they're going to use for the orbital flight test. And the orbital flight test, I'm pretty dang sure, is just to test the heat shield. It's not a full Starship. It's basically just what SN15 and SN16 were, but with a full-fledged tile system on them. It's very similar, but it's not exactly the same. But it has a high-fidelity thermal protection system on it. It means it's a real heat shield with parts of the booster that aren't there. Like, it's going to have no interior payload volume. It's just going to be an empty space, from what I understand. So, yeah, it doesn't need landing legs because it's not going to land on water. They're just testing the heat shield, and Starship's going to come down and land in the Pacific testing range, just near Hawaii, actually, north of the northernmost island in Hawaii. Yeah, so it's landing in water. So is Super Heavy, for what it's worth. Got him, Coltec. Yeah. I don't know, 420. I don't know if they're plumbed in, dude. Oh, excuse me. I don't know if they're plumbed in. That nozzle, I don't know if it's that vacuum motor or what. That thing clearly hasn't been fired. I mean, it's not sooted up, so either that or it has been and it has a nozzle. It has a new nozzle on it. I don't know. I mean, I don't know if these are plumbed or not. They could be just using them for fit checks, or yeah, I don't know. These engines are just for fit checks. They'll be taken off to allow for cryo testing. So yeah, they are real engines, but yeah, okay. So they're just using them for fitment here. They got to make sure that they can integrate to Super Heavy. This whole thing is about stacking a high fidelity prototype, but not actually using it. Clearance looks really close. Well, these things don't gimbal 619. They're actually fixed. They don't move. These are the ones that move, which is... that is a thing. That is a thing that happens, man. Yeah. It's going to be pretty nuts, dude. It's going to be pretty nuts to see this thing firing. Do you think they'll try and recover anything that survives? Yeah, Game Coder, I'm not sure, man. Maybe? Like, I've thought about it. What do you do? What do you do with Starship? Like, okay, so it's going to come down north of Hawaii. So it comes down in the ocean. Then what? So you got to safe the booster, right? So you got to vent it to make sure that it has no explodey bits in it. If you want anyone to get near it, you have to safe the thing. When Falcon 9 lands, they vent all the extra liquid oxygen overboard. It boils off and they open up the vents and it vents out. So I'm not saying that this couldn't do that. But now what? Now you have a 50-meter tall Starship inundated with water sitting in the middle of the ocean, literally the middle of the Pacific Ocean. How are you going to get that home? If you look at the vacuum raptor in the back, you could see a bar. This is likely where they attached it to the skirt. Oh, yeah. Yeah. It's in the testing range. Hit it for target practice. Yeah. Well, I mean, if you... Yeah, that's most likely... They'll most likely just sink it. But I suppose if we were going to lift this thing up out of the water, how would we do it? You'd need a crane. You'd need a pretty big freaking crane. I suppose you could get divers to attach it to attach the attachment mechanism to the nose cone and then try to lift it up out of the water by the nose. That would take time. You could do that. And now, okay, so now Starship is vertical. Now what? Okay, so you put it on the barge. Now it's on a barge. Okay. Now what? You're gonna move that barge all the way back to California? It's not impossible. I just don't see why you would do that. You could tow it. Okay, where are they going to tow it? Mighty Servant. That could do it. You could tow it to Hawaii. Okay. Now what? What do you do? Take it apart? Inspect it there? I mean, I suppose you could. But I'd want that thing back in Texas, which means you have to bring it through the Panama Canal and back to Boca Chica. And even when you get it to Boca Chica, okay, it'll stay in Port of Brownsville. I suppose that could work. Can starships be transported horizontally? It's an honest question. I don't know if they can. Maybe. I mean, well, this one's already gonna get damaged, so I suppose it really doesn't matter. It will take 2 months, and it's a waste of time. Yeah, and I guarantee you, by the time that thing actually physically reaches Boca Chica again, even if they did recover it, Starship's design will have changed so much ironically, from its test flight, right? That it'll be irrelevant. They'll just put it on the side of the road. So I think they're gonna scrap it. I think they'll sink it, just like they did with GovSat and a couple of other Falcon 9s that landed out in the ocean by themselves and survived. I mean, heck, even the Falcon 9 that Sierra 16, the one that malfunctioned and landed in the Atlantic right next to Cape Canaveral, even then they scrapped that thing. They didn't use it ever again. Booster 1050, they scrapped it and they're like, yeah, no, never mind. Can you take it to Hawaii and relaunch it and fly it back? I would not fly a rocket that's been inundated that much with salt water, Katra. I wouldn't do that. I mean, I don't know. SpaceX is crazy. You never know. Can you leave it in the ocean with all the fuel and the electronics? How is that any different than a first stage? Unless SpaceX is just going to put a barge out there that we don't know about and land it on the freaking barge. But then again, if you're looking at it, it doesn't have any landing legs. Doesn't even look like it has the mounts for the landing legs. How much fuel does Super Heavy go through every minute? Yes. It's not as much as you might think. If you want to see a good visualization of it, Haze Gray Art has a very good video here. I'll find it. On fuel consumption. This one. This ended up, dude, this this video got super freaking popular. Check it out. Here, I'll link that if you want to see. I won't show the whole video, but watch. It's like a visualization of fuel getting drained. I mean, look at the hydrogen. The hydrogen, once again, because it's so dang efficient, it sips fuel. This is Saturn V. So the red is kerosene. This is hydrogen right there, and the blue is liquid oxygen. So like if you go further in the video, look, even like 5 minutes into it, look, the space shuttle still has a half tank of gas. Pretty crazy. And the SLS core as well. Pretty nuts, huh? Watch the whole video. It's really cool. If you want to see how fuel consumption works. So methane, lulz, is going to be somewhere... Methane is somewhere between Falcon Heavy and hydrogen. It's between these two. It's about average between Carolox and Hydrolox. It's a good median. Hydrogen, though, is freaking cheating, man. Hydrogen is insane. It's absolutely nuts. What I mean, like, just look. It's barely draining any fuel. And the 3 shuttle engines are going. The shuttle engines aren't. They don't sip fuel by any means, but they're barely draining anything out of that external tank. Same with the core stage. It's pretty damn cool. It's a great video. Go watch the whole video. Trust me, you'll like it. Project change secrets if they blow. Clammy, that's what they did in the past. SpaceX made jigs to transport Starship on the side, so yeah, they most likely can move it on its side. When did they make those, Thomas? All the possible outcomes.
Victor.
Oh, what is this? Victory, Nice. Mark II era? Interesting. Okay. This is coming from Thomas Zurbuchen. He's the head of NASA's Science Mission Directorate, so all the science missions he oversees. Let's see what we got. Here we go. Psyche missions. GRNS flight hardware has left Johns Hopkins and headed for JPL, where to go through final tests before heading into space. It will characterize the elemental composition of the asteroid Psyche and help reveal if it's the shard of a planetary core. Oh, very cool. The Psyche mission is going to be launched by SpaceX to the Psyche asteroid. That's pretty neat. I love the aesthetic of space. It's very sketty. That's from the end of 2019. So ancient history. Got it. All right. So what's going on with the Russian space news? Let's switch over to that here real quick. Let's see what we got here. Sergei Krikalev said in his interview to Russia 24 that the unscheduled engine burn of Nauka was probably caused by the module's control system, which thought that Nauka was still not docked, and the safety algorithm commanded to perform a withdrawal maneuver. Oh. He also noted that there's no damage to the space station that's been noticed yet, but an additional load isn't good for the solar panels and the constructions of the station. Specialists will analyze the consequences of the incident. He also thinks that it's reasonable to continue the work on the ISS at least until 2027 and probably later, depending on the technical condition of the station. Will we see a Falcon Heavy with dual drone ship landings and expendable core? I'm pretty sure yes. Okay, next bit of news. That's interesting. So this is coming from R.A. Novosti here. The agreement on the lease of Baikonur by Russia until 2050 entered into force. Oh. Changes to the lease agreement by Russia of the Baikonur Cosmodrome from Kazakhstan until 2050 came into effect following the amendment of the lease agreement for Baikonur, published by the government, basically. Baikonur is leased out until 2050. And the agreement, which was signed in 1994, was stated Baikonur was leased to Russia for 20 years. Agreements to extend the lease until 2020 were reached in 2004. Baikonur is the world's first cosmodrome that launched the first human into space and the first artificial satellite into space. It launched Yuri Gagarin and Sputnik from Complex 1-5. After the collapse of the USSR, the Cosmodrome became property of Kazakhstan, and Russia pays $115 million annually for the lease. Huh. Cool. Do they have a plan to build a new ISS? Somewhat. Yeah, the plans are very preliminary right now, because NASA wants to use the ISS until 2030. So, very preliminary right now. Not exactly sure what the plan is just yet, but when there's something iron, I'll tell you. Roscosmos explained why a bolt flew out of the new Nauka module. A bolt that took off could remain in the science module after assembly operations. A bolt that came off the Nauka module is not able to do much harm to the ISS, said Sergei Krikalev. Earlier, Russian cosmonaut Oleg Novitsky told the Moscow Control Center near Moscow that everything is in order in Nauka and that there's no deaths, but a bolt flew out of the module when the hatch was opened. It doesn't pose any danger. The station is made in such a way that some foreign objects do not lead to something jamming. According to him, all necessary parts are in place, and this bolt could remain in the module after assembly. Could have remained in the module after assembly operations on Earth. Chief Executive added that the bolt's visual and design experts will determine where it comes from and what it's intended for. Sergei Krikalev spoke about similar cases that have happened previously. In some modules at the station, they found metal shavings that remained after machining in the shops, which on Earth was almost impossible to recognize, and in zero gravity it floated up. With such a phenomenon, according to Krikalev, they learned to fight, and now the modules are thoroughly cleaned before being sent to the ISS. So it's $115 million every year? That's what that looked like, Kem, to me. $115 million annually. That's nothing, dude. It's yeah, that's nothing. Yeah, I mean, whatever. They put it back together. They had a couple extra bolts. That's no problem. That always happens. Give me 1 second. I just heard the pickups on the guitar go off. That's why I'm wondering if there's a thunderstorm near. Nope. It's south of me. With IKEA furniture, yeah. Last time they drilled a hole in the ship, they're improving, yeah. I heard the pickups go off. There is a thunderstorm, it's just not near me. But they did pick up. They did pick up something. Anyway. The last picture is an aerial shot from RGV here. This is the last bit of space news, and it kind of is a little late for this one, but there's a picture of Booster 4. 4 is now sitting on this mount right here. But still, seeing it from up here is pretty awesome. Yeah, Cam, it's a pretty good deal. Yeah. Man, they're putting in a lot of conduits on the inside of that thing. See? Look, guys, they already started installing conduits in inside of the tower. Those pipes right there are for electrical. A conduit is just a metal pipe that has electrical wires inside of it instead of like water or air or whatever. There's probably a fire suppression system in there too. If I had to guess, that's what those big pipes are. But they usually paint them the right colors. But still, they're doing work on that thing. The tower is going very quickly. Looks like fuel lines as well. I wouldn't put fuel next to electrical, Phil. Just putting it out there. But then again, I wouldn't put water next to it either. So who knows? Maybe. Did they literally do the paint on the launch pad and said, yeah, just go up as far as you can reach? Yeah, I don't know, man. Maybe. Yeah, just go up as far as you reach. Or that's still under construction. Man. The scale here is just unbelievable. See the dude right there? Just ridiculous. The scale here, man, it's just crazy. I watched the whole thing, Zizep. How about you? Thomas, are you still here? Dude, see, this thing right here is obviously designed to get the vehicle to be hooked in a certain way. Meaning that if you have a crane hook, right, the booster will orient to the crane hook. I just, even if they catch super heavy that way, you know, they catch it with the grabber arms on the sides, right, which we know is what's going to happen. I don't think that these hooks here on the sides are there for no reason. Whatever they're going to use on Mechazilla to lift it is going to utilize something similar to that. But I'm just trying to figure out how. Man, those grid fins are huge. They're as big as a truck, Klein, yeah. They're like, not as big as that pickup truck right there, but close. Maybe that thing. Maybe a little bit smaller than that. Dinosaur traps. Good video. That video was amazing. Anyway, guys, that's going to do it for Space News. I hope you enjoyed it. I'm going to switch over to KSP now, and, well, we're going to work on the SSTO. Chat and I basically decided that get the SSTO buttoned up this week. Get it ready to go by the end of the week, and then next week we vote on missions for it, because the unanimous consent was to keep the program going. So, we're going to, yeah, I know, the crawler looks tiny in that front. It's ridiculous, right? We're going to work on our big SSTO. Your background is failing. Oh, no. We're going to work on the big SSTO and go. What? This green screen is a lot bigger, Forge. So when I lean back, the chair kind of rolls onto it and pulls it down a little bit. I got to be careful that I don't pull that thing out of the wall again.